and that is reps from the Executive Governor of Lagos State, the Comptroller General of the Nigerian Customs Service, Director General of NASDA, as well as a rep from the Lagos State Commissioner for the Ministry of Commerce, Cooperatives, Trade, and Investment. The energy continued with practical sessions, including an introduction to ArcGIS field maps, showcasing the power of mobile GIS workflows. We then heard compelling user stories from our key public sector organizations. That's the National Communications Commission, the Ghana National Petroleum Corporation from Ghana, as well as our very own Ikeja Electric, who demonstrated successful and innovative GIS implementations. The afternoon featured a look into the energy sector with our Esri rep, Adele, followed by a thought-provoking panel on geospatial innovation for resilience, efficiency, and economic growth. Day one was packed with knowledge, networking, and a shared vision for the future. Let's carry that momentum into another exciting day of learning and collaboration today. Thank you very much.
Okay, while we're waiting for our MC to come on stage, I would now like to welcome our first presentation for today, which will be taken by our very own Esri, that's in the person of Mr. Adel Fernandez. A round of applause for him as he steps up the stage. Good morning. Please keep clapping until he gets up. Thank you.
Can I have the slides, please? Hello, everyone, and welcome back to second day of this lovely conference. Obviously, the theme of the conference is so everything about GIS and how we are geo-enabled, how we are connected. And maybe yesterday there was a lot of talk about leveraging capabilities of GIS and geospatial intelligence that people weren't really aware of in other departments in our organizations. And that's due to the fact that we all had access to this data sets. Today, my focus is mainly on digital twins. So the idea of a twin, which is a GIS system connected to all other systems, not just ArcGIS, not just Esri systems, but all the other systems that are connected via geography together, that being all other IoT sensors, all the sensors come from SCADA systems, from other systems, all the data sets that come from other asset management systems, that come from accounting, billing, and so on. Everything that builds up that 3D model that is geo-empowered with other connections and other relationships with other third-party systems. So today the focus is on location-enabled digital twins, and it's more of focus on cities, countries, and governments, and how they leverage digital twins for the use of GIS and geo-enabled systems within their own cities and within own countries. So GIS is fundamental for any smart city. GIS is what brings all this data together and helps solve problems and questions such as what are the common patterns of travel within a city, for example, understanding things like the road network, understanding the travel mobility patterns, congestion patterns. Also, where do I, if I have pandemics, if I go back to 2020, where do I build hospitals to be resilient, to put up with pandemics? Where do I have more bed spaces and beds available for cases that might come in for specific diseases, for example? Where are my vulnerable populations within a city, and how do I account for that? How do I address that? Where do I build schools, or where do I plan and change my planning zones for certain areas? How do I make my transit services better? Where do I locate or relocate bus stops to make my transportation system a more efficient one and serve my citizens better? Other things are such as where do I start up businesses? Where do I open shops for commercial centers to start? Those are all big questions, and they're not, I mean, you can't just take a guess, stick your finger in the air and start saying, well, I can build a community here. It would be nice to have some kids play around this park. These have to be data-driven decisions. These have to be decisions that are based on information that I've got. There's no use of there's no use of collecting information if we're not going to use it in answering things on those questions using geointelligence. So a digital twin basically is not more than basically a GIS model with all those layers, all the buildings, 3D blocks, electrical grids, things like infrastructure, our digital terrain models, digital surface models, and so forth for those geomatic engineers like myself. All these kind of things come together to create a GIS, right? A digital twin is a bit more than that. Digital twin is those, but also, like I mentioned, it's all the systems that are connected to those layers, all the workflows that I have in my departments. If I have workflows that help me, for example, navigate within roads, workflows that help me dispatch police vehicles in certain locations and put them in the right locations to address specific issues. All the workflows that happen around and relationships between all those layers is what creates my digital twin. Now, the idea of digital twin is that it empowers smart cities. It helps me generate more ambitions for my city. Now, the notion of smart cities is basically things such as saying, well, how do I make my city, I want to make my city more livable. You get government officials come out and say, like, I wanted to make it prosperous. I want to have, everyone should have food. Everyone should find a place in a hospital in case they get sick. Everyone should have good healthcare. Everyone should have good transportation systems, and so forth. Those are all big dreams. The only way to measure those dreams and the way I want to reach these dreams is have them being data-driven. So I have to have my data being collected, which is what we all do in all our different government departments, but bringing these together into my digital twin of the city and enabling, calculating those, and measuring those metrics to achieve those goals is how I make my city smarter. That's the only way to find out and to measure how smart I'm achieving my smart city goals. Now, there's lots of operations that happen around smart city, and one of them is obviously the designing, planning the city better, all the engineering side of things, working with contractors that work with municipalities, with planning commissions, planning departments, and those workflows very much leverage things like GIS. They kind of bring in BIM models or CAD drawings, or even big printed drawings that are generated using CAD, go into the system for contractors to build, for planning departments to start planning better, rezoning certain parts of the city to make them more viable, more transportation efficient, lessen the congestion, like what we see, for example, in Lagos, trying to mitigate those issues, the peak hours and rush hours and things like that. All these kind of building blocks, all these kind of operations leverage the digital twin or leverage GIS data that we already work with. Another side of things is the monitoring things. So if we have a digital twin, we can easily start monitoring, create dashboards, like we were saying yesterday, create dashboards out of anything, out of a building site, to create dashboards out of my transportation network. Having my dashboards and vehicles moving around, it's an easy thing. It's not because it's already, the data already exists in the GIS, it's very easy to spin off a dashboard that has all those kind of pie charts and bars and camera feeds and even environmental factors like carbon emissions and things like that being measured from sensors, all being drawn on one dashboard. So monitoring is another function that kind of very much leverages a digital twin capabilities. A third thing is the maintenance side of things, so operations and maintenance. So I've built everything, I've started monitoring things. Now I want to have my field crew, though. There are people that for an electric company, there are people, that engineers that go down, and technicians that go and fix problems. You also have for statistics agencies, you have people going to kind of collect statistics. Your inspectors, your surveyors that go in land and want to be connected to that digital twin to know where to survey next. You have your telecom operators, people who want to go down the field and want to check on signals, certain areas, try address and do their operations in the field. They need to be connected to that twin. Anything to do with maintenance very much leverages that GIS infrastructure, that digital twin. Another part is the cloud computing, what I call enhancing, which is basically the side to do with analytics. So ArcGIS or Esri's technology in general leverages a lot of the analytical side of things, because once you store the data, you know how to store the data, you can analyze data, you can use AI and so forth. And we've heard a lot about that. Lots of us already kind of use AI in our workflows. But it's good to know now that with all those kind of tools, we are leveraging a lot of the cloud computing capabilities to do with AWS or ArcGIS, or Microsoft Azure capabilities that kind of get integrated with our platform. We deal with lots of big data because we're collecting data on every second of the day now from all the sensors, from all the data sets that we generate, and we need to have the infrastructure to be able to deal with big data, which could be done on a cloud, could be done on our infrastructure, but again, using parallel computing. A lot of focus of our technology has been on this area because it's an area where it generates a lot of value for lots of other departments. But then to leverage the twin as well, the communication side of things, and we've discussed this yesterday on the collaboration, or not just collaboration within a department, but this is more about our citizens. So if I want to gather information from my citizens, which is a very, very important thing to put my ear to the ground and see and listen to people and see their feedback, because the feedback very much helps me not just gauge people's opinions, but it helps me, rather than sending inspectors to kind of try to find out things, I can generate apps and create very quick apps that leverage that digital twin to collect information that I would have spent inspectors and spent money on inspectors to go and inspect certain areas to raise these things. Communication is a very important part, and I'm going to talk about that in a bit as well. And then collaboration, which is working with other departments, with other government organizations. And that's the part also that through a digital twin, this would be something that I could use. So the idea here is that, at least in my thinking, a digital twin is all of these together, but it kind of connects all this life cycle of things coming together, all these different operations, the building, monitoring things on site and dashboards, maintaining all my assets and operation and maintenance stuff, all the analytics side of things, and the collaboration and the communication with my citizens, so within departments, but also to the outer world. I'm going to touch on each one of those briefly, but the underlying infrastructure for us with Esri's technologies are those basic tools. So you got ArcGIS Pro, which lots of you know, which is our desktop tool, ArcGIS Enterprise and Online, Enterprise, which is on-premise, and ArcGIS Online with all the services it comes with, but also ArcGIS Living Atlas, which is, again, a library that we host on our SaaS solution that kind of has so many layers that are available for all ArcGIS users to use for free. But then on top of that, there's so many tools that kind of go on top of those workflows that help you do specific things. Some tools are generic, like dashboards, for example. They could be used in many of those workflows, whereas other tools are very specific, like you get ArcGIS for AutoCAD, for example, BIM-GIS integrations, the ArcGIS Urban that could be used in the building and construction side of things. You also get, for example, the notebooks that could be used in the analytics side of things, ArcGIS Hub for communicating to the public, availing data sets and things for academia, for research institutions to work with government and help government solve their problems. So there's so many specific tools also that are specialized for some of those areas. All right, so I'll start by talking quickly about planning, designing, and construction. They're different things. I'll start with planning. So basically, before I jump into that, our AEC side of things, which is architecture, engineering, construction practice, which is a practice within Esri that we've got, kind of has evolved a lot through the years. Esri or GIS wasn't necessarily something that lots of our engineers used. GIS was always something that was used in, for analyzing some data sets that a GIS specialist sat on a desk and worked on. Nowadays, it's integrated in everything because it connects everything. It's the main container where everything comes together. And as part of our AEC patterns, or the architecture, engineering, construction patterns that we see, are four different parts as we see them within Esri. One of them is the planning and design side of things. So the focus on, again, the urban structure, urban planning, zoning and rezoning parts of the city, bringing in the aspects of geodesign, bringing in plans and drawings and BIM models into my GIS and vice versa. And then the project delivery side of things, so lots of integrations with project management tools nowadays that we have with GIS that brings a lot of value. We have tools such as GeoBIM that kind of connect both worlds, the BIM world and the GIS world, while you're running a project, while you're executing a project. A third part here is the reality capture, the field capture. Capturing information, capturing data in general happens through many ways. Some of it is using drones and aerial photos. Some of it is using our apps. So apps like Survey 123, like Quick Capture, like field maps that kind of, where people go in and collect that information. All this information is what goes into that AEC sort of workflows. And then the visualization and simulation side of things, it's not just a fancy thing. It's not just a reality, kind of a gaming engine, cool thing to see. It actually brings a lot of value. It simulates a lot of the planning and things that departments in a higher level do, and it shows you what is the plan for government officials to take decisions before things actually get spun off on the ground. So this is sort of a classical way we run our AEC practice within Esri, and the way we design tools and break workflows for people that work on those fields to work with. Okay, so on the planning side of things, there's an example here of the city of Boston. Let me just go back one. Okay. Okay, so the city of Boston basically had issues such as not being able to, they had a lot of congestion in certain areas. They had so many proposals for neighborhoods to be built. So just like in, let's say, Abuja, Lagos, and other places where you have certain neighborhoods being built and, you know, housing in certain areas where developers are growing and building things. You have a master plan of the city, right? You want to make this master plan better. So in order to, when the Boston Planning Development Agency, which is the urban planning agency of Boston, when they receive those proposals for the building blocks for certain areas being developed by contractors and developers, they had to have a way to assess those building proposals and kind of say, well, I don't like this proposal, don't like that one is best for me. It's not by how it looks, it needs to be data-driven. So what they've done is they've taken a tool that we have, that we designed, it's called ArcGIS Urban. ArcGIS Urban helps zone and rezone certain areas to make things a bit more applicable. So it kind of calculates things like saying basically you have so many jobs in those kind of zones, you have less jobs in those zones, you have 30% jobs in those zones, you have transportation links here, you have those number of bus stops, it breaks it down to geographies, also tells you how many schools, how many hospitals, and it starts rezoning things for you with your help when you say, like, I want to increase the ridership of people of my buses, for example, within the city, or I want to increase people walking to certain places, walkability in certain areas, or I want to increase certain number of jobs in certain areas to attract specific type of calibers within those regions. Those are all planning questions, and ArcGIS Urban helps you put all those GIS information together and start telling you, well, you need to, these areas, you need to increase jobs for that kind of, those type of jobs, entry-level jobs, in those specific areas. You need to start commercial centers in those areas. You need to increase bus stops in those areas. These are the sort of questions that help a city cope better and achieve its goals, all the goals that are set of, I want everyone to have a decent job, I want everyone to afford to have 3 meals a day, and so forth. Those questions and those planning questions help very much, are helped by using data, and tools such as ArcGIS Urban help you achieve those indicators and replan based on those indicators. And that's what the Boston Planning Development Agency has done. And it's not just taking that, also the tool also helps you to do things such as measuring, comparing proposals from one proposal to the other, and telling you which proposal that people have submitted kind of really fulfills your goals. A second story, second story is the workflow of project management. So project management tools exist everywhere. People use them to kind of track their budget, track their expenditure, and so forth. And okay, so an example here of integrating, bringing in things. So we worked a lot with companies such as Autodesk, and not just Autodesk, but open source as well, IFCs, which is basically the standard for BIM models being submitted by contractors to go into GIS. Now, lots of the engineers and designers that work, and contractors that work with CAD files, work with BIM data, they initially didn't see the value of bringing that in GIS or finding GIS information out, bringing it out into the design side of things. But this really brings a lot of value. The reason being is that first, you're bringing that vertical world into the horizontal world. Once you have a building, a BIM building with all the different dimensions of it, with all the stuff that goes into it, you can start measuring things outside automatically from the GIS, seeing how far are windows from the road, how far are windows from each other's, from neighborhoods, do they satisfy those building regulations or not, and so forth. So you can do those comparisons. Other examples are such as here, risk flood analysis in Taiwan, if that works, where a building, here you go. So where BIM models were superimposed on a port in the port of Buduzi in Taiwan, and basically flood simulations, which is a basic GIS thing that you can do. Flood simulations were done of the sea level rising by a specific level, and given that level, you can start identifying automatically how many assets within your BIM model, what columns, what metal, what iron rods, what I-beams will be affected by that specific flood in case it rained that much. Or if rain levels increased by that certain much, you can start having an asset inventory of the type of risk that I see with that kind of building. And you can start comparing models based on that. If you have different BIM models, different things, you start realizing, well, in case of a flood, my assets are not gonna be affected as much with that specific design, and you can start building based on those designs. But also here in France, for example, where they were redesigning their Paris Metro, one of the Paris Metro lines, where they superimposed their BIM models, and they were building, basically they were designing their metro stations. So while designing the metro stations, they had to come up with specs for each metro station. I need to redesign those metro stations to make them bigger, smaller, accessible, having shops inside or not, accessibility for elderly or not, are there many kids in those areas or not? So all those design specs came from the demographical data that the statistics agency had. So they superimposed all the statistics agency's data of all those kind of small areas of the city corresponding to the metro stations, and started building a profile for each one of those metro stations. And then started saying like, well, I need a BIM model, basically the submission that needs to come in, needs to have those elements, has to cater for so many kids, for elderly people, people that maybe have more disabilities, areas where there's more concentration of hospitals, so they're likely to have people with injuries, with problems with them, so I need to facilitate things for them to move to hospitals. So all those design questions came, and design specs came from the GIS. So there's a lot of those stories, lots of the power of bringing GIS with design elements, and it kind of helps a lot mitigate all these problems before they arise. Now, on the project management side of things that I just mentioned, there's so many lots of people use drones, and yesterday, I think every other talk there was a mention of, we flew a drone took pictures on a daily basis, we've created a model, So drones is a technology that is being used day in and day out by everyone. Similarly, in construction sites here, where you have a project plan every day on a daily basis, drones fly on a daily basis, and in this example, and they track and take an image and take a video of, an image of this whole site, starting extracting non-conformities, piles of rubbish, for example, constructing, also building the 3D model of the construction as it is now, and comparing that to the BIM model that was submitted during design. And those comparative analysis can tell you where you are in the project. You can go back and forth on dates. So you can go forward in dates, backward in dates, and see where you were at the design model. It's nothing fancy. This is literally a drone just flying, collecting data, dumping it into ArcGIS, and just doing automatically the comparative analysis. And another example here is a project management cost monitoring example from Jamaica Station in New York, where they had the budget, so they had the money, and the owner, which is the New York Metro owner, they wanted to monitor the amount of money being spent out of the budget versus where I am at the project, and compared to the design where I'm supposed to be. And that is a GIS question, because it's obviously a long railway, it's a big connection, and it kind of and you can time slide, go back and forth, and see the progression and delay in construction and issues that they had during the project timeline. So this was kind of the planning, the building, the designing side of things, but then moving into leverage digital twins on the monitoring side of things. So we've heard a lot about dashboards, and as you know, that there's so many dashboards. They're easy to build, easy to understand by people that are non-GIS users. ArcGIS dashboards are also free, so you can download them. As long as you have all the data available, you can dump them into dashboards and work with them. They're very flexible, very configurable. There's so many templates as well that are out there. If you are looking for a template for a specific thing, for traffic monitoring, for example, there are several templates for that you can grab and do things with them. So dashboards are really a good tool to portray your message or what you're showing to other people, third parties or inspectors or top management, to see a dashboard where we are now in a bigger picture. Because they don't care about the details and the very important and technical stuff they do. They focus more on the bigger picture and where we are at the moment now. Dashboards is the way to communicate that. And there's so many examples here for kind of many cities around the world using dashboards. And one example is the digital twin being built for the city of New York again, where they kind of have all their cameras, all the sensors, the pollution sensors, everything being connected here, and portraying that on one dashboard where you can click on a specific camera, it opens up the camera, it opens up the sensors around it. It kind of gives you a real-time visibility, a common operating picture of that specific incident or of the city at a glance. Any official walks into the room, they can start saying, oh, bring that area, bring the island of Manhattan. I want to see what's happening down South Manhattan and so forth. Another example is in Saudi Arabia, in the event of the pilgrimage, Al-Hajj, in Saudi Arabia, where so many pilgrims travel in there. They go, they move. You know how the Islamic kind of pilgrimage is. It's very busy. Every year, the Ministry of Pilgrimage in Saudi Arabia used to have around 6 to 7 deaths because of crowdness, because people used to crowd a lot. People used to push and shove. That's how we are as humans. We are impatient. So people used to push and shove, and the problem is because of the traffic flow. So it's a traffic problem, basically. So what we've done is we've teamed up with SAP they brought in Trimble. They kind of put in a lot of sensors to kind of track people. They had cameras to count people's heads. There were issues such as umbrellas and so on, and they couldn't track people because people were covered under umbrellas. But we found ways to kind of start calculating how many people are in every segment of the whole venue. The venue is so many stories. If you've been there before, it's very complicated. But also, we found a way to monitor those pilgrims, have cars on them, have different ways to monitor them, and bring them. They had all the GIS background on ArcGIS. They had all the data, the base data. What they've done is we've created dashboards using ArcGIS dashboards to monitor in real time where pilgrims were, where congestion was happening, and that triggered alarms. And as soon as you found an alarm, some certain areas, we kind of said like, well, we want to dispatch, want to open more doors or open less doors in specific corridors in order to let the traffic flow faster or flow slower, depending on what you need, how we need to regulate the traffic. It's essentially just like traffic monitoring and managing cars or vehicles on roads. And that was a very interesting one. But then there are other ones, such as in China, for example, where in Hong Kong they brought all the kind of every type of sensor known to humanity from the city of Hong Kong into an ArcGIS dashboard. They used it for different things. They used it for a smart site management system when they were building certain buildings and managing all the permits around it, managing the cameras around it, understanding exactly where things were happening and why were they happening. Other dashboards were for real-time monitoring of traffic, understanding all the concentrations of pollution, different chemicals that are in the air, also access to cameras, access to junctions. There are also other dashboards that created for workforce management and supervision of where were people doing different types of jobs. There are other dashboards to do as well with areas where they had concentration of specific populations in a construction site, and obviously supply chain and movement of trucks within the city and facilitating that using again monitoring of ArcGIS into construction sites and areas around the city where you need accessibility and you need to minimize the effect of having big vehicles moving on rush hours within the city. So managing all that, again, is a GIS problem that is based on a digital twin, a geo-enabled digital twin. So you can see those dashboards are very interesting in the sense that they can very easily just portray a picture in real time for people that have nothing to do with GIS in a very geospatially savvy, intelligent way, very interactively. It's very interactive, people can play around with it, and it solves very, very big problems. A third part is the maintenance side of things, or operation and maintenance and field mobility. And this example, again, from New York, which I've mentioned several times, surprisingly, in this presentation so far. But basically, the New York Housing Authority, New York City Housing Authority, to be exact, they basically they wanted to embrace the idea of digital twins and the maintenance works that happen around it. So they have their own maintenance crews that go and fix certain issues in different parts of the city, like any municipality or building society or areas or different authorities around the world. So what they've done is basically they didn't have a GIS, they didn't have a CAD. All they had is CAD drawings. They got those CAD drawings and they started scanning them, converting all those CAD drawings into a GIS format. So they started automatically trying to automate the way, so they're not going to go on each line and convert them, but they started automatically recognizing shape, having a small algorithm in Python to kind of push everything into GIS using a predefined tools. Once this was done, what they've done is they started extruding and building the 3D model of the building, identifying where the elevator shafts are, identifying where the service rooms are, where the car parks are, which areas and facilities, and they overlaid that with all the infrastructure and the utilities, maps, and blueprints within the building. But then afterwards, after building that kind of 3D model out of CAD, it's basically CAD drawing, old CAD drawing that they have that was built in the 70s and the 80s, they started building a 3D GIS model. What they've done with that is, in operations and maintenance afterwards, dispatchers they have apps where they go in ArcGIS Indoors, which is one of Esri's tools, and what it does, it kind of has this data in GIS now. It says, well, there's a specific job that needs to be done on a specific building. Now I want to dispatch people, my maintenance crew, to fix that specific tap that's been running, or specific leakage, or there are rats or rodents or mice that have been found in a certain building. I need to dispatch someone to kind of get rid of them. And what that has done, that kind of triggers the dispatchers to kind of trigger something to the nearest field worker. The nearest field worker then gets the message on his app, and the message in the app pops up and tells him, well, there's this job, you're assigned to this job now, move to that specific place. You have an email to kind of respond to, you click on things, and it takes you to that specific things. You log in, and it tells you the exact issue. But because this is all based on a digital twin, once they get to that specific asset that they need to fix, what happens is they can have a link to the PDF file that describes the asset, tells them all the specs of the asset, has the background and history from the GIS, so it gives him all the information. So the guy is in the field, doesn't have a laptop, has his phone, and automatically has access to all this information, all this wealthy GIS information, and is right in front of the asset about to fix it, but he has the background and says, well, 2 years ago, they fixed the valve on the bottom of this asset that had a problem because it had leakage, all in an instant, and now they have a better informed decision-making to a process that they have through, rather than just going blindly and start calling their friends and bringing someone else to expect something else. But obviously, all these jobs have been happening, and there's some supervisors somewhere that want to have the bigger picture. So again, ArcGIS dashboards there were used to kind of see how many inspectors were there, how many technicians were down in the field dealing with rodents, how many technicians were dealing with leaky incidents where water has been leakage, for example, things like that. So all these things, a supervisor can look and automatically see, well, on a bigger scale, I have 200 of those incidents happening out there. In 30 of them have been addressed, 80 of them are in progress, and 70 of them haven't been addressed. And they can then say, well, do we need to hire more people? How do we need to fix things? And that's decision-making in real time based on GIS. But also, I don't know if you've seen this video run or not, but it's basically on a bigger picture of that digital twin. You can start seeing now historically where incidents tend to happen, which units have started having incidents happening, and how do I address those? How do I see is there a pattern? Are there specific buildings, for example, those kind of apartments down on those buildings, they've been having problems for the past 2 years. Same exact problem happening. There's extra pressure on the pipes, and the pipes burst. And so there's always leakage. Is there something behind that? Do I need to go inspect a bigger problem? And this is the power of analytics, 3D analytics, basically, in 3D space. So GIS, only with GIS, you can actually access this information and start making sense out of it. So that's why this is a cool kind of story, because it brings it all from CAD drawings, from just having some drawings, to building a 3D, to having people inspect and go in field, to gathering all this information, to having 3D models like that, fancy stuff like that, all out of just CAD drawings, basically. Very simple. We've mentioned ArcGIS Indoors. So ArcGIS Indoors is obviously a tool that kind of helps people navigate indoors, but not just navigate indoors. It helps you do a lot of things like managing all your indoor assets, doing facility management for lots of things to do within your facility, occupant experience, seeing people who lease the shops within a mall, for example. They have specific experiences. We want to measure that. We want to try to understand the dynamics, the traffic flow within those malls. Space management, so people that have been renting, for example, a retail store somewhere, you want to relocate because they haven't been getting traffic, because not lots of kids walk towards their baby toy shop, for example. Where do I relocate that shop to cater for traffic where kids tend to walk? All these questions could be answered using ArcGIS Indoors. Very good product to look at. Oops. All right. So Survey 123, you've heard of Survey 123 and the capabilities that it's got. Again, a recap on that. You can create surveys. It's a web designer in its own sense. It's a connector. You can very easily tailor it and cater it and build things on it. So I don't want to go a lot into Survey 123, but Survey 123 is just a very easy tool, and I think it's one of the most used field mobility tools that Esri has got. because it's very simple, it's very text, it gives you, it makes life very easier, so much easier. You can create it out of an Excel sheet, you can create it on a web device online, and it connects directly to your GIS data, and it brings it up on ArcGIS, and it and you can export things into a spreadsheet if you are comfortable working with Microsoft Excel. You can do lots of other things with it. Okay, field maps is another one. So ArcGIS field maps, and we had a talk yesterday about the description about it, but very quickly, it kind of very much builds on the digital twin story. Digital twins are built with all this GIS data, but it's not a lot of use if we don't really use it in operation and maintenance a lot, because that's something that's very simple. And so many people, no matter what level they are, they kind of have a smartphone. And that's becoming, it's not just common, it's 90% of the population have a smartphone. It could be the lower end stuff, could be the upper end stuff, but they have a screen on their phone. And the idea here is that let's leverage that, let's work with that. We already have the data in the GIS. Let's expose it, let's start doing stuff with it for enabling field crew and people that have phones to trigger messages, to trigger things, notifications, very simple apps. It doesn't need to be anything complex. An app with 3 buttons where you click, say, well, I've spotted leakage, like Quick Capture, for example, which is one of our apps, where you click, it gives you 3 options. You find an open manhole, for example, or you find a leak on the road, or you find a road crack. 3 things. And people walking around the street, oh, road crack, click. That's it. That triggers a row inside your GIS and automatically records stuff back in the GIS. So for working with municipalities, working with inspections, with operation and maintenance anywhere around the city, this is just really easy. It's really easy to deploy. As long as you have the GIS already data, you might as well build an app for it and have your inspectors use it. Let me move on to the next bit. I'll spare this logistics side quickly, and I want to move quickly into the enhancement side of things, so the analytics aspect. So we kind of work with the word Geo AI a lot, which is basically saying it's a geospatially kind of aware AI, artificial intelligence. And we, in the GIS journey of data, so any data, it gets collected first, it goes into a model, so we kind of model it, we try to put a schema to the data, we store it on a certain databases in a certain way, we kind of start maintaining it and adding new updates to it, and we start doing stuff with it, and then we enable access. So we say, well, we have the data now on our GIS. Well, I want person X, Y, and Z, John and Joe and Ibrahim or whoever, to access just this data. We want those 3 people in that department to access just this data. We want to develop an app so those guys and that team just to view data and interact with it. And that's the accessibility side of things. You share the data. You want to analyze the data. So once you keep on using data, you want to analyze it, visualize it, and then predict it. Now, this is sort of the journey of data, right? Journey of not just geospatial data, but data in general. But this is how we view it. And usually we find the geospatial infrastructure, or where the data is usually stored, is in this area. And there are so many tools to visualize it, predict, analyze, and collect the data. Now, in our AI journey, what we've done is we basically created tools or specialized kind of and bent AI or machine learning to work in 3 specific areas. One of them is in the collection phase. We're using deep learning, so we've developed lots of deep learning tools. We've adopted lots of other existing deep learning tools and stuck them into our interface, our ArcGIS Pro. On the analysis side of things, so analyze element, we have adopted lots of spatial-temporal machine learning tools that enable you to analyze data, find patterns in data windows, and so forth. And then the prediction side of things, we've adopted so many regression models and prediction models that kind of help you predict what's going to happen later with your geospatial data sets. Now, there's so many examples that kind of lay within those temporal side of things, but this is how I view it. I view it in the sense that the deep learning and lots of the feature extraction elements kind of fall within this collection phase. So if you're part of a collecting team and you're in data collection side of things, there you can do a lot. So you can use deep learning to collect things like identifying roads, damaged structures, building footprints, graffiti on walls, road cracks, anything. You can detect anything, and that's the idea of deep learning. Basically, is being a human that can see with their eyes and can extract things out of images. The analysis side of things is a bit slightly different. So it's not very much on the computer vision side of thing, but it's more on creating a time-aware GIS. That time-aware GIS, traffic, let's say traffic, for example. Traffic happening on roads of Lagos today, tomorrow, day after, and so forth, and every day building basically a 3D model for you. Now, drilling through these 3D models, like in what we call space-time cubes, you can start figuring out and finding trends, not just daily, but could be hourly, could be every 5 minutes, could be, as transportation agencies do, they break the day into 6 time slots, the AM, pre-AM, AM, PM, post-PM, and so on, nighttime and evening, la-da-da. So kind of they have different time windows by which they aggregate the geospatial data temporally in terms of time, but also in terms of neighborhoods and space, and start figuring out where do things happen, where does congestion accelerate, and correlate that. Very funny, not funny story, not so funny for me, but when rain drops and you have rain, for example, and depending on the amount of rain, what level of rain is the critical amount of rain that will affect your movement within the city, or transportation links will break suddenly. And those are the small questions. Like if I anticipate tomorrow there will be a precipitation level higher than a certain threshold that I've set, I know that there are problems going to happen on road X and Y and Z. And those are the areas where I need to from now mitigate that and start redirecting traffic in certain directions, close traffic lights, redirect people already, or advise people over the radio or any social media to use different roads and so forth. Those are very simple things with very simple tools that are already out there. If you build them and just get people aware, you won't have gridlocks, you won't have traffic issues. And that's the power of geography. Another part is the prediction side of things. So again, there's so many libraries out there for those of you techies who kind of work a lot with machine learning. There's CNTK, TensorFlow, and Skitlearn, and other libraries and other frameworks that they adopt and work with Python and ArcGIS. And that kind of helps you do a lot of things like anticipate, for example, where traffic is going to happen in the future. And that's, again, coming back to the question of you already found the pattern, you already mined the data, you did data mining, so you found that pattern. Now put that into a prediction model and start taking that and start predicting, saying, well, it's going to rain tomorrow. I have a football match of the Nigerian national team is going to play in that X stadium tomorrow. Plus there's rain. Plus there's the president is going to be coming down that specific road. Plus there's House of Parliament. Plus. You put all those together and you start creating a GIS model out of it that enables you to predict traffic tomorrow. And that's all based on very simple things: roads and transportation links that have a measure to them and have specific weight on them. That's the power of geography, again. Now, we've also moved to the next level, which is AI assistance, or again, generative AI, Gen AI. And Gen AI there's so many things to do with it, again, from simple things like ChatGPT and Grok and all the kind of other chatbots that you kind of work with, to helping the geographical side of things. We've developed assistants, AI assistants, if you're familiar with the term, assistants that kind of help on different apps. So it's not a product on its own, but it's ingested in every one of those tools. So Survey123, for example, we've created an assistant that helps you. If you take a photo of an asset and you're trying to fill a survey, it automatically tries to extract information out of the numbers that are written on the asset, the shape of the asset. Say it's that type of asset. It's a water main versus a sewer. It's a drainage line, for example. It's a customer end, and it will try, using location also, could start to extract for you, fill all those kind of windows for all those kind of boxes for you. So even in Survey123, when you send the inspectors to write things down, with AI assistance, there's so many ways where you can minimize the amount of information they need to put, because AI can start extracting that out of a photo that you take and start filling it for you. And that's really powerful. Other things are, such as an ArcGIS Pro, we have lots of the AI, the kind of generative AI or Gen AI tools now integrated into them, where you can start basically asking ArcGIS questions for visualization. You say, well, I have this data, here's a shapefile. And it says, well, do you want me to do something with this data? Do you want to visualize it? And you say, yes, I want to visualize it. I want it to show me patterns of people who are above the age of 60, but also who move a lot or whatever. And you throw those in, it will start converting those internally to questions like, well, the best way to visualize quantitative data, to kind of show it in terms of size, and the colors need to be different to the background, because my base map is dark, so I want a lighter kind of colors to kind of try to show those things. So all those kind of visualization aspects are done using Gen AI. It just thinks about it, and it starts proposing for you visualization tools. It starts also, you could, in ArcGIS Pro today, you can start asking it questions, and then that's in beta, that's not out yet. In beta version ArcGIS Pro, we have AI assistance tools where it can recommend tools for you to use, statistical tools or geostatistical tools for you to analyze the type of data that you've inputted into it. So there's so much stuff being done, Copilot, Microsoft Copilot integration. We're integrating as well our GIS maps in Microsoft's toolbox in Microsoft Copilot to try to start to kind of apply geospatial intelligence to it using Gen AI as well. So many things happening on the AI assistance side of things, and the new, let's call it the AI 2.0 kind of version. All right, so the communication side of things, and this is basically talking to our people, talking to our citizens. And the city of Los Angeles here, and that's not just the city of Los Angeles, there are many cities even around the region have been doing that. It's great, and they're using a tool called ArcGIS Hub. ArcGIS Hub is a GIS that can help you face the public with. So it kind of opens up ways for you to connect with your citizens, create apps and awareness things for your citizens, but also create apps where you can collect feedback from citizens on certain areas using geography. And Los Angeles, they had issues such as high unemployment in certain areas. They wanted to create, again, want to reduce homelessness. They wanted to improve water conservation and use less energy in certain areas and so forth. So they wanted to do those things. They wanted to build things. They had projects, and they wanted to communicate those projects with their citizens. But what they also wanted to do is not just the communication and tell them what we're doing a great job here, or we're doing this project there. They also wanted to spin off specific apps for users to use and gather information from them. And part of it, for example, they've identified where all road cracks were across the city, and they wanted to prioritize where is the priority. We only have a limited budget, and by every quarter, we have a certain amount of $. How do we spend our money? Very valuable questions. Where do I start? Which roads do I start with? You could argue, like, I'll start with the big roads. Well, does that solve most of the problems? And they thought, like, you know what? I don't want any of my citizens coming back to me and telling me, well, you spend the money in the wrong way, in the wrong place. We should have started in my neighborhood first. So what they've done is like, okay, we're going to open feedback. Here's a map, interactive map. Click on the areas of priority. Most of people obviously went in, they clicked on the neighborhood. I said, I want to fix roads on my neighborhood first. But some people were looking at the bigger picture. Some people were looking at roads that during their daily journey to work used to affect their commute, and they used to create punctures for the tires. So they started objectively thinking about areas and the priority of areas to do to fix. And the County of LA, they kind of looked at that and they were like, all right, based on your opinion, guys, now this is what we're doing. We're doing those roads first because most of you have voted for those roads, and then those and those and those. So it's given a lot of it's given transparency, it's given prioritization, it's connected and communicated with citizens, made them engaged in the whole process with minimal. It's just one app, very easy app where people have to click. So it's not rocket science, but it's also it created that dialogue with citizens. And also now, I mean, if they got anyone to blame, they can blame themselves, right? They've made the decision. But also, it kind of helps them with lots of the information gathering and telling them, well, we're moving, we're doing this for you. This is how we're progressing on those kind of elements. City of Dubai, where we live, they've created, and Abu Dhabi as well, they've created several apps to do different things. One of them is for people, Dubai is slightly different. Lots of expats come and live in Dubai. Anyone that lives in Dubai, if you ask them, they probably are not from Dubai. Most of people who live in Dubai are expats. They come from different countries, right? So in Dubai, they kind of, they recognize that, Abu Dhabi as well. And what they've done is they said, you know what, I'm going to create an app, an end-to-end app for people who are looking to move to our city from anywhere in the world. I'll tell them, well, those are the areas that we've got. We have so many properties around here for rent, for purchase, or areas to live in general. But I want to empower that with GIS stuff. So they've started adding on the GIS, they all use ArcGIS Enterprise, but they've started adding where the schools are, French-speaking schools, for example, for French people who want to move to Dubai or Abu Dhabi and want to send their kids to a French school. But also, their income level is not that high, it's within that tier. But also, they like beach stuff, so they want to be close to the beach. But also, they don't want to drive a lot, so they want to take the metro. So they have all this kind of it's basically site selection, like our basic GIS stuff. By enabling that for those people, which you don't see a lot of websites, you see properties, even you can look and search by area, but it doesn't recommend for you, those are the best 3 properties for you based on the criteria you're looking for, right? And this is what those kind of cities have done. They said, like, you know what, we have those tools, we have this information. Property agent or property websites, they don't have this information. They don't have all this detailed information about a city. We do. So let's create apps to facilitate that for people to kind of move in. And again, it's just exposing that through an app. People just click, I want to be far away, distance from metro, distance from schools, fill out that profile, and kind of it narrows down the places, and then it connects to third-party websites where people post properties with companies, all this kind of property companies kind of post their properties, and then you can choose, and it automatically connects to the other website, and then they have other apps, super apps that kind of help you start your tenancy contract, connect with the land department, and do things. So it's all digitalized. It's a literally digital era, no paper trail whatsoever. Again, GIS here jumping into action. All right, so city of Alola, very quickly, it's a city that is, it's a city in the middle of the desert in Saudi Arabia. I mentioned a big desert. Talking a lot about Saudi Arabia today because they've been doing a lot of cool stuff lately, and they have been doing a lot of stuff for many decades, and then suddenly, for the past 5-6 years, there's a lot of things happening. So many stories coming out of Saudi Arabia. And the reason being is that, well, there's a vision from leadership, there's money, obviously, and also there's willingness, and there are so many calibers that got attracted to kind of doing GIS. Lots of people like you, who are GIS people, think geospatially, but they've been given as well leadership, okay? So they've been given driven, and we've seen all the presentations yesterday. These things wouldn't happen without having leadership and without having push on budget to kind of feed into those things. Budget will only happen if leadership is strong and has a good vision. And that's the people on stage yesterday, that kind of only proves that, shows you like things could be done because it comes from up above with a good team, but you need to have someone pushing that, a champion that pushes all that down. Now there in City of Alola, they built a big ArcGIS enterprise that kind of has all maps. It's a heritage site, so they have so many things they want to show to the outside world. They don't have many things, but they have a lot of valuable things that go back thousands of years. And they want to really show it, like any country wants to show their heritage. And they want to preserve it as well. The way they build hotels, they build things, they want to make sure that their ESG kind of indicators are sort of kept in check. And they also want to make sure that there's a good journey for any visitors to come from point A to B, from the point they land at the airport, to go to the hotel, they go and visit certain sites. Transportation links are made and catered for them. They visit the right places. They've used things like, they use things like story maps. You've heard of product story maps that kind of helps you navigate and go into certain areas. I think that's. It helps you basically, story maps, online story maps that are open for public, for people to kind of visit certain sites, understand information, see which trails they can walk onto, which areas they can navigate, and it's a really good thing. There's articles online on it that kind of shows you a lot of the capabilities and things they've done. It's all focused on tourism for heritage sites and conservation elements. And then again, ArcGIS Hub and those things kind of, so many governments around the world want to stick and want to measure their UN SDGs or Sustainable Development Goals. And there's so many countries, some of those countries you are familiar with, where they kind of they've adopted ArcGIS Hub, and they started building all those metrics and indicators and measuring them based on their existing GIS data. Because the country on a federal level has all the access to this GIS data from different states, from different parts, from different cities. You can very much build those hubs and expose that information to show the world where you are in terms of achieving your SDGs goals. Let me just pause this. So the last aspect here of leveraging digital tools is the collaboration. And again, maybe I've touched in the petroleum talk yesterday, I've touched on that a little bit, on teams kind of working with each other. But the idea here is that you have many different government departments, right? Every government department has their own workflows, they have their own things that they do. Each one of those have their own enterprise as well. So you get all those government departments, they're all very precious about their GIS data. Yesterday in the panel, we were talking about people don't want to share data. This is exactly it. Like we're so precious about data. We don't want to share it, which is good when you work in government, but you need to have the right access control rights. You need to establish that governance model. So have a strategy. And the word strategy here is important. It's not just thinking about things high level. Yeah. Have a governance model. Which departments need to see which type of data, and how do they need to see it? Do they need to see it via an app where they kind of investigate the data, or do you need to have a download capability? Do they need to develop their own apps? There are all those questions. That's how a strategy is made. You ask those questions to every department within every one of those organizations, and you start coming up with the requirements. As a GIS team now, we know all my stakeholders. We know what they want, what they need, what they think they want, but what they actually want, which is you need to translate that in your own language, your GIS language, and come up with it, right? And establishing a system where you have all those people who have all those agencies who have their own ArcGIS enterprise. They have the systems that they have their own accessibility routes. You have within the planning department different subdivisions who go into different types of data and work with it. But on a federal level, what you want to do, you want all those people to deal with each other, to interact with each other. You want transportation agency and the water agency to kind of work with each other. So you need to have a center of GIS. There's always an organization in every country we've ever been to. There's always an organization that always wants to raise the flag and say, like, we are the GIS sponsors. Or there could be several organizations that do that. They do it in their own respect, in a certain way. And the reason being is that they want to connect to all those organizations. They want to get that collaboration between organizations working. Our message usually is we need to work on the idea of a network of networks, or an infrastructure of infrastructures. Everything connected to each other. You're interconnected, but you're also intra-connected with other organizations. And the idea to do that is through our ArcGIS portal. Through your ArcGIS portal, you can enable portal-to-portal communication. If we're talking on the technical side of things, you can enable ArcGIS Enterprise here to talk to ArcGIS Enterprise somewhere else using those governance rules. You need to address those rules first. Have those rules in place, those governance rules, and then take those governance rules and implement them. The technology is easy. This is the easiest part. Coming up with those rules and who needs to see what and how they need to see it and why would they need to see it. All those, that's the tough part. That's the hard part that you need to do. As long as you have that in place, then whoever the center or the centers of GIS are, they can connect those people. But also exposing that to the outside world using things like ArcGIS Hub, for example, that we were talking about. And you want to connect other people to that certain type of information, just like we're saying in the city of LA or Dubai or Abu Dhabi or others. So there's so many tools that help you achieve that. And as saying, like all the ArcGIS solutions, all the things that you're using on the enterprise, that's all what you use inside your organizations. Some of them are specific, like utility network, for example, specific to water companies or electric companies. You have specific other tools that are relevant to other organizations, ArcGIS Urban, for example, for urban planning councils and so forth. And then all of them, they have enterprise. So they have the ArcGIS Enterprise or ArcGIS Online that kind of connects to things. But you can expose things out there using ArcGIS Hub or ArcGIS Online, if you may. So again, the city of Abu Dhabi, because I've worked with them a lot over the years, and I've seen their struggles from coming from nothing and then starting having having that big strategy. What they started with, they had an enterprise agreement with Esri, so we've signed an enterprise agreement with them 13 years ago or so. But what we've done with them is that they said, we want to have one agreement that covers all those kind of agencies. We have all those agencies that want to connect together. So we sat with them, we said like, okay, let's come up with a strategy. Those are the elements of the strategy. Having a governance model, so a model where we see how those agencies interact with each other. What's the governing way? The transportation agencies, do they work with a utility agency? How do they work with them? Why do they work with them? What are the type of requests that go from one side to the other? What are the policies in place? Can utility companies give out the asset numbers to anyone else in government? Is that part of the policy or not? So those policy questions, standards, obviously, if I have data, utility data, if I have police data, if I have transportation data, I need to put it according to standards, because if I have transportation data across two different agencies, they cannot exchange information unless they both adopt the same standard. So therefore, we need to all adopt specific standards across all government. This is the law. That's it. Everyone from now on, anyone that has utility data needs to adopt that specific standard, standard X, Y, and Z from the OGC standards, for instance. Type of applications. So to achieve all those, what type of applications do I need to build? And then what type of communication I need to have with the public? What's the mandate of the government? All those questions fall within the strategy of the government. Once the government comes up with a geospatial strategy, what they did is, they said, well, for all those, we're going to create a big, what we call a spatial data infrastructure, an SDI, that kind of connects all those different data sets to one another and connects all those government organizations to one another applying those governance rules. So governing all this kind of exchange of data between organizations and adopting those policies and standards that we've created. And as a result of that, over the past 12, 13 years, they've created so many different departments have created so many different apps. Those different apps do different things. Some of them monitor marine water quality with the environmental agency in Abu Dhabi, for example. The transportation agency at Abu Dhabi have created an addressing system for every single unit, similar to what you've got here as well. Addressing system using GIS based on that SDI. They've also created a transportation app, a journey planner app based on GIS. So anyone, you don't need to use Google Maps because their app charges tolls, charges everything, and it's way more accurate than Google Maps. And it's a government-made one. It's not a big company like Google. Rural payments agencies down here have been using rural payments agencies is part of the Abu Dhabi Food Control Authority. They have farmers claiming subsidies. What they've done down there is that some farmers obviously have been lying. They go to the government, give me money because I've been growing your crops. I've been growing the crops you asked me to grow. They haven't been doing that. They've been installing swimming pools, or they have some certain facilities they're not allowed to have, or they use it as a dumping ground. And in that respect, they've used drones. They fly drones. Drones fly up above. They extract, using AI, they extract different elements, and they start interpreting that and saying, well, there is a swimming pool here. We need inspector to go to those lands. Those lands highlighted in red. We need to send inspectors there. So it prioritizes where inspections need to take place. All those are different apps that couldn't have just been done in silo. They need those organizations or those cross-departmental communication to happen between those organizations on GIS. Okay, so closing here is, again, we spoke about digital twins. We spoke about all those, components that we have. As a recap, there are many products, as I said, that I touched upon on this talk, and they're all very relevant to specific industry, and you all would have different interests and different focus in different parts of this life cycle, right? Now, the last slide here I have is basically on, well, what do I do? Like, let's say I have some GIS stuff that I'm doing, lots of workflows. Where do I start? And as I mentioned many times, probably in the past few slides, a geospatial strategy. Come up with a strategy. Come up with a small strategy that you have. It doesn't need to be anything that you bring a strategist and pay them millions of dollars that you don't have to build stuff. You don't need to do that. You can start thinking about, who am I serving? Who are my stakeholders? Start thinking about that, or work with Sambus to help you with that exercise, to tell you, well, this is the guidelines, these are the guidelines of strategy. And Esri, we have strategy documents that you can use as well, so it can help you with building your own geospatial strategy. It's a thing that comes out of conversations with different departments, with different stakeholders that you have. People who want GIS data, that always get in touch with you and send you emails telling you, I want this data for this area. Those are your stakeholders. Put them in a list, start seeing where the requirements are, what they need, how they go around and finding it. And then, obviously, ArcGIS Hub and community websites, very important, very easy to spin off. Dashboards, very useful tool to use, and we've touched on that. Field mobility and inspections, apps, so many apps to kind of go through. AEC workflows, something that you might have not worked with or not have seen. There's a lot of stuff that is relevant to that nowadays. And then AI tools and all the things that you could adopt to kind of leverage and extract geospatial intelligence out of your tools. All of that is in ArcGIS Pro and open libraries and ArcGIS notebooks, so feel free to explore that online as well. Anyways, that's me, but that's at least my digital twin story and Esri's digital twin kind of technologies around it. So hope this was useful, and it kind of give you some insight to kind of think about where you can go next, or what you might have missed, or the opportunities that lay ahead. And thank you very much.
Very distinguished delegates, ladies and gentlemen, that was Adele Fernandez. Please, can we put our hands together one more time for him? For the first time, I sat down both in front and at the back to listen to a presentation, and you ended the thing by saying, I hope this was useful. This is the most useful thing I've seen in my life. Very amazing, very insightful, very wonderful, very well done, intelligently presented. Can we clap for Adele Fernandez one more time? Questions? So I will borrow all of you 3 minutes, personal decision, to just take questions before I get His Excellency to come for his speech. I will just borrow the first 3 people that have questions that can be answered in 1 minute. I'll give you 30 seconds to raise your hand. If you don't raise your hand, I will assume you don't have a question. Questions? The presentation was very amazing. This is the first time I'm allowing questions to come. So you should know that I enjoyed it. Questions? No question on digital twin. Number 1. Number 2, a lady. Lady. I need a lady. Number 3. That's all. Number 1, sir. Please, can you step forward? Number 1. Yeah, let's do it from there. Your name, your question, bam, straight.
Thank you very much, Adele Fernandez. My name is Nasir Olagunju. I'm a GIS developer. I just wanted to make an observation. I noticed that a lot of the presentations have been more about decision makers and policy makers, which is very good. But developer lives also matter. So perhaps you could have gone a little bit into the developer tools and opportunities that are available in Esri system. Thank you very much.
So, sir, if I go around the 3 people, will you remember everything? Okay, number 2, so we can take it quickly. Oga is here. Sir, your name, where you from? Bam.
Well, thank you very much. My name is Dr. Agbaje, a consultant and expert in geomatics, also space application expert. It's a wonderful presentation. I really appreciate it. The issue mainly is about capacity building. Yes, it's good to collaborate. It's good to use enterprise GIS. I know the presentation, it solves so many problems, but at the same time, the capacity of the indigenes or the people that you are selling the product to, so that it will not be like we are all hanging on you, is very key. It's very important, and it's also very good for future development. The other thing is, will there be will the presentation be available for the audience? Thank you.
He's like a Yoruba man with small Igbo man inside. Okay, the microphone, please. So observation and question. The only lady on the queue. Yes, I wanted the lady to be there. Please, can we clap for the lady? Let's clap for lady. Yeah. Your name, then.
Thank you very much. My name is Rose Mibwala. I'm General Manager, Postcode and Address Team, NIPOS. I'm not going to ask questions in respect of NIPOS because I know we are in discussion with Sambus, but I want to ask this question just concerning Nigeria. We have a predominant problem in Nigeria, which is security problem. I don't know whether you have brought your solution technology to Nigerian government in respect of security challenge in Nigeria, because I know, for example, where I come from, we have a serious security challenge, and which I know is also affecting other regions in Nigeria. So I would like to have a situation where you can have a kind of presentation, maybe to the Nigerian government, either at state levels or at national, so that you can actually educate Nigerian government on how we can solve this security challenge in Nigeria. Thank you.
Please, can we clap for her? You see what I tell you about women? When they discuss small things now, she cannot go Nigeria. Even Fernandez don't shock. Okay? You're the chief of defense staff now. So I start with Nigerian problem, then you move to the chief of army staff now.
So the security problem is, you mean national security as in, yeah. So we have a dedicated security team that obviously works with governments around the world for solving that and gathering intelligence, but also trying to make sure that everything is known for decision makers, again, to deploy certain units in certain areas, to make sure that the safety is achieved in certain areas. There's that part of the government side of things. I can name a long list of agencies that work with our technology to try to achieve that, gather some information, try to mitigate things, dispatch things in the unit, and there's a lot of solutions for that. However, also on the government, not however, but also on the government side of things, like the civilian government side of things, there are other aspects, very technology intelligence stuff. So we've seen so many municipalities, for example, use things like street lighting on trying to measure where people don't feel safe in the city because there isn't enough light, or there isn't enough crowdness, or there isn't enough shops, for example. So there are areas that are dark, areas that are not well paved, areas that are restricted or have too many shops, have little shops, have too big gatherings, have little gatherings, and trying to measure or correlate that with places like sense of security and other aspects. I'm not looking even here at crime data. I'm not looking at stuff that you could always use with crime agencies, with police or national security and public safety type of organizations, which they do already with our technology. I'm also talking about the simple things that local governments can do. Local governments can, again, measure those kind of sense of security of people. People feel or report problems, or report that, well, I'm not going to walk down the street at night because what? It's dark, because there's so many kind of dodgy characters around the street. There's so many things, and when you understand those, you can start to plan properly the city and make things a bit safer, make corridors, for example, roads a bit more fluid, or create more commercial centers, or create more interactivity with citizens. And that's the science of planning. That's basically urban planning in a nutshell. But also, since you can add lightings, you can add mitigate those kind of different, have those strategies to do things, you can very much solve part of the problems. I'm not saying I'm not tackling it just from the public safety side of things, which public safety officials can do, and we can have a talk definitely with them on all the public safety solutions I've got, but also from a municipality, from a planning department side of things. There's so many things that we all can already do. We already see the problems because we can measure the data, we can gauge people's opinions about how they feel in the city, and we can start kind of finding kind of mitigation strategies to kind of deal with it. Very simple things like I say, lighting, or having more people, informing the police that these areas people don't feel safe. We've had so many disruptions. We had so many break-in of people are jeopardizing city assets, for example, or break-in, stealing stuff and whatever. Those things as a municipality, I know that these things do happen. So what do? Is I tell the police, well, can you just have one police car in these roads between these times on the weekends, because they tend to get a lot of complaints or things being broken over the weekend from these areas. This is all GIS questions, but they're also they're government questions that you can very easily start at least eliminating half of them by just kind of planning better.
Okay, so thank you. Please can we clap for him? So I think it was just observation, but it's a straight question here. Are you making this presentation available for
Yes,
Ross?
through the team of Sambus, that's going to be available.
Okay, so we'll talk to Sambus.
Well. There are links to online stuff as well on it, so you can click on them and it takes you to the website.
Okay, so I think that's it. Thank you very much. Please,
thanks.
Can we put our hands together? So for security issues, we just take 1 minute. We'll take, Madam wants to say something quickly, and I'll come to you just in 1 minute too. Yes.
Okay.
No, ma'am, could you just help us? Yes.
Thank you so much.
45 seconds remaining.
I just want to add to what Adele has said. Sambus is supporting the defense sector very strongly. We're supporting DSA, we're supporting the Air Force, we're also supporting the Navy. We're trying to get into the Navy, but the Air Force, DIA, DSA, we're supporting them strongly. They have good infrastructure. DSA is here, they're represented here, and we're hoping that we can have a collaboration. The challenge is a handshake. So the Air Force has their own data, DSA has their own data, the Navy has their own data. There's no handshake. So the handshake will really help them to solve most of the issues that we're having. The police is a major one. We hope we can really support them with crime mapping and a lot of the other issues that Adele has mentioned. Thank you.
Okay, thank you.
Oh, so customs, I forgot. Customs is also here. We're supporting customs. Forgive me. We're supporting customs too. Thank you.
My mic. Can we clap for her? She has to support my mic. Okay, so I see the military men were just raising their hands. Is it a question, sir? You want to add to what she said? Okay, sir, because of camera, you may have to... you are shy. How do you carry gun if you are shy? Okay, well, sir, so everybody can see you from here. Sorry, sir. He has obeyed me. Okay. Thank you, sir.
Okay, thank you very much. My name is Major A.O. Kilani. I'm from Defense Space Administration. Okay, in regards to the question asked, the thing here is that we provide resilience and affordable space products to support the armed forces and other security agencies. So in this, we carry out series of analysis. We have terrain analysis, hotspot analysis. All these analyses are tuned towards solving all this problem. But as you know, the problem in Nigeria is much. But we are trying our best to do that. And again, one important thing here is this: data. Data is a major problem. And we are working on having the NGDI, so that we can be able to put all this data together and then help solve this problem. For instance, while you're traveling and then you see bandits on the way, in as much as you are safe from that action, you will not report it. So these are some of these problems. If we have data of all this action that are happening, we can put this together, create a pattern out of it, and then we can predict by so doing, we can reduce this problem that we are having. Thank you very much.
Please can we put our hands together? I was supposed to give the military officer 30 seconds, but who am I to question him? Thank you. So because we're going to catch up on time, breakfast is supposed to be 11 o'clock, and this is already 3 minutes to 11. I'm going to quickly squeeze in 2 things, and then we go for breakfast. First, I'd like to, with all due respect, invite to the microphone His Excellency, the Executive Governor of Ekiti State, ably represented by Special Advisor on EGIS, Land Management and Survey, Professor James Bola Olaleye. Please can we put our hands together for Professor? The clap should be a little louder for Prof.
Thank you. Thank you. Good morning, everyone. I just want to observe that keynote addresses are supposed to be in the opening day, usually made by politicians. When they make it, they go. But we are putting our own after the very heavy technical sessions. So I'll just read the speech of my governor, whom you have invited. But I think next time we should observe that. So I'm here to give a keynote address. The last paper that was presented has taken the front seat, and you begin to ask yourself what more to say. Everything has been said. But I will read the address of His Excellency as a way of our contribution from Ekiti State. All protocols are observed, and I just go straight to read the address. It is a great pleasure and a profound sense of honor to be here today. I am being represented by my special advisor on survey, lands, and ArcGIS. The governor was excited to be here personally when we got the invitation, but had to yield to the pressure of state matters, and then asked me to represent him. This year's theme, Envisioning Tomorrow, Geospatial Innovation Shaping Our World, is not merely a topic for discussion for us in Ekiti State. It is the very blueprint of our administration's development philosophy. We envision a tomorrow where every policy and every project, every public service will be informed by accurate, accessible, and actionable location intelligence. And this is why we are innovating our land management system for tomorrow's excitement. Our journey from paper maps to a GIS-enabled state. When our administration came into office about 3 years ago, we noticed a critical gap in our land-based operations. Our land services were in dusty papers. Our base maps were analog, outdated, and discontinuous. A single plot is being allocated to 2 or 3 people or agencies. Our land was fragmented because of uncoordinated growth. And our agricultural and environmental policies were often based on incomplete information. It was so bad, it was becoming difficult to get land, even for government services. And we also saw that many of our agencies were operating independently. It was clear to us that the problem was that of deficient land administration system, which underlies all government activities. We were challenged by the thought that if you cannot manage the land, you will mismanage whatever land carries. Yet, our conviction was, if you have a way to solve a problem, you have a chance to solve it, and you do not solve the problem, then you are the cause of the problem. These convictions and our desire for the land management to support the intensity of the land demand for our government made us to embark on this journey. Now,
we had to create what we call ArcGIS. That's Ekiti State Geospatial Information System, or Ekiti State Geographic Information System. The origin of the Ekiti State Geographic Information System. The term GIS is an acronym for Geographic Information System, which we understand to be the technology or system for the capture, the storage, retrieval, manipulation, integration, and display of information for visualizations, for decisions and actions about land and all resources that are placed on it. In effect, GIS collects various land data, processes them, and presents information in visual, textual, and other forms for decision making. Coincidentally, our land administration system requires land information, visualization, decisions, and actions to acquire land, to allocate, and to monitor, and also to save land wastage or land lockdown. And this, the ability of the GIS to link several modern data collection modules to data processing unit, thereby providing information for visualization, decision, and actions, makes it an ideal system not only for monitoring the land itself, but also for administering and appreciating other land-based assets that are placed on it. Therefore, the realization came to us that the implementation of a GIS is the solution to all our land problem, and hence we created the Ekiti State Geographic Information System, which we call the ArcGIS. And like the human brain, the ArcGIS is the brain box of our government, because it will receive data input and process data output loaded with insights, which we call information. But unlike the human brain, the GIS does not take decisions and actions unless it is enhanced to do it. But of course, it will provide the information for visualization. Our land management reform steps, the steps that we have taken to reform our land management, number one was for us to create what we call Ekiti State Geographic Information Center, EKGIC, as an agency to oversee the realization of the Ekiti State GIS. The EKGIC is a domain for the agency to manage and house the central nervous system of our new information-driven land management. And that's the one we call the brain box of governance. The EKGIC was mandated to build the necessary administrative and technical infrastructure for implementation of the EGIS. The technical infrastructure was considered to be more urgent than the administrative. Though they are important, the administrative is mainly policy documentation, but the technical aspect, which has to do with the geography and the cadastre, were more urgent, and that is what we are currently working on. Now, number two is to build the technical toolkit. The technical toolkit is based in two parts. We have to build the geography. And the geography is the combination of the visual models of the land space of Ekiti, including images, vector maps, topographical maps, drainage maps, and the geodetic framework, the contours, and all others. These are covered under the acquisition of the geography. And of course, we envisage that the geography will be a veritable platform for viewing and locating features, resources, and physical infrastructures in the state. It will also be used to plan all uses of the land. It will be used to prepare hazard mitigation plans and also facilitate visual tourism and land search. We emphasize that every service will be able to search the state, even on their phone, so they can locate where the pieces of land and features are. And most importantly, we emphasize that the geography will present visual evidences and witnesses for land transaction and discussions. Usually, in many of our meetings, we always imagine locations in the brain. And it's actually very painful when we are discussing Victoria Land, for example. We will all be picturing in our mind where is Victoria Land and how it looks like. But it's easier when you have the picture of what you are talking about right in front of you. It makes work easier. The reform of this geography is part of the new innovations that we are doing. We are changing from the paper operation to digital form. The second step of the technical implementation is to create the digital cadastre. Everything that we are talking about, the GIS makes use of units of land, other points, or small areas describing something. And that is what we have to do to make sure that we can break down the geography into smaller manageable units, because those are the units that contain the information that are always of interest. Now, we also try to link both the cadastre and the geography so that they can work together. The last presentation that we saw layers of different kinds of data. Those are cadastral layers. So we can reference all the information and use the geography at the base map for the cadastre to be interrogated. Now, we're also trying to make sure that that is in the digital form. Currently, they are in paper form, and they are actually very contributing to the problems that we have. Now, the status of all these projects. Our current efforts are focused on meticulous execution of a 7-pillar implementation plan to produce the technical infrastructure for the EK GIS. Now, the first thing that we have done, which we have completed, is the establishment of the geodetic framework. We have deployed 5-number continuously operated reference stations, which are already in use as virtual reference stations to establish the geodetic framework to form the base layer of our geography. It is now possible for any user with a single receiver unit, to determine their positions to centimetric level, that is to single centimeter level accuracy, everywhere in the state. It will also serve as the essential bedrock for all the other precise mapping that we are going to be doing, which will involve the land titling and also infrastructure analysis and display. Now, we are currently acquiring the geography is an aircraft that is currently flying, though they have suspended the flying now because of the bad weather, but the action is continuing. The third step is the creation of the cadastre, which we are doing. We have completed the scanning, the conversion of our old stock of data, our legacy data, into digital scan form. But for a proper GIS, we would need to get the data in an actionable form, in digital form, where we can actually query, we can issue query to be able to do better management of our land transaction processes. We are also automating our land transaction processes. This was done before, I'm sure with the assistance of Sambus. We were able to automate the land transaction processes, getting the C of O, doing your deed registration and all that. We were able to do that. But we are reviewing this again because we are doing we are reforming the entire land management system. This will enhance the efficiency of our land transaction processes and improve the speed of transaction processes so that people can get their land registered more quickly. We are also automating for infrastructure. Our EKGIS is not only for distributing the land, it is also for to provide support for all other engineering designs and construction that we are doing. Within the GIS environment, we can do any design that we want, and we can overlay even those infrastructure that are yet to be constructed can be studied within their environment using the display capability of our GIS. We are also building capacity. Technology is nothing without the people to run it. A major component of EKGIS is the ambitious on-the-job training of our staff, the staff of the Ministry of Lands, Survey and EGIS, and personnel all across our participating agencies. They are all currently being trained. Linking everything together, we are building a state-of-the-art centralized enterprise GIS infrastructure, leveraging on ArcGIS Enterprise. We have chosen a hybrid cloud model to ensure security and stability, enabling web-based access for our civil servants across the state, from the Bureau of Land Services in Ado-Ekiti to agricultural extension offices in the remote villages. Envisioning our tomorrow. What is tomorrow? We are envisaging with all these efforts. We envision a tomorrow where a farmer can access soil maps on his phone to determine the type of crop that they will plant. We envision a tomorrow where land transaction that once took months to conclude or never got concluded will take just a few days. We also envision a tomorrow where an urban planner can simulate flood risks, and plan resilient infrastructure before a single foundation is laid. We also envision a tomorrow where the Ministry of Health can track diseases, outbreaks in real time, and deploy resources with precision. In essence, we envision a tomorrow where the entire state is seamless, integrated, and intelligent ecosystem, and where governance is transparent, efficient, and responsive to the needs of the citizens. A call for collaboration. This journey is not one we can make alone. We are proud of our partnership with Sambus Geospatial and Esri Incorporated, whose technology provides the tools for the transformation. But we also look to this conference, to all of you, the experts and the innovators in this room. We invite you to partner with us, share your knowledge, your innovations, and your experiences. Let us learn from you, from your success and from your challenges. To all government officials who are no more here, I say the time for geospatial innovation is now. It is not an expensive luxury. It is a fundamental infrastructure for modern governance. It is the key to unlocking the efficiency, transparency, and economic growth. In conclusion, envisioning tomorrow requires us to act today. In Ekiti State, we are not just envisioning, we are building. We are laying the digital foundation today for the smart, sustainable, and prosperous state of tomorrow. We are confident that our investment in the Ekiti State infrastructure, geographic information infrastructure, will become a model for other states in Nigeria and across West Africa. Finally, I thank once again the organizers of this Esri User Conference and wish all attendees fruitful deliberation, which we have almost concluded. Thank you for your attention. God bless Ekiti State, and God bless the Federal Republic of Nigeria. Now, I delivered the message of my governor. Now, I want to make a small comment of my own. Because when I came in here yesterday, I was actually surprised that most of the people who have come to display something outside there for us to see, and those who are here, many of them were my students. Even the governor of Lagos State was my student. So I felt very proud that we are at this level witnessing this. I'm not sure. This is the first time that Esri and Sambus are making this kind of arrangement where we have this kind of international exposure. I had wanted to go along this line where we have the last person who presented before I came up announced himself as a geomatics engineer. And when I came back, after I finished my PhD in 1992, the experience that I got from Canada, at that time, you know, you could be in one room, you can communicate with your colleague in another place right on your computer, which was not here. So when I came back with the knowledge that I got, I said we must start to think in a different direction. I'm a surveyor by upbringing, but I found that we have to do more than just surveying, collecting data. There are so many data that GIS requires. The surveyor would only define boundary, four corner. That's not enough. There is a huge pile of data that GIS requires, depending on what you want to use it for. So we determine the kind of data you will get. And my supervisor told me a story that I'll never forget. That GIS is a replication of the human brain. And that the way the human brain works is it collects data. We have 5 data types that the human brain collects. We have the voice, we have the sound, sight. We collect heat data with the skin. We collect odor with the nose. So God gave us 5 sensors. Every human being has 5 sensors. Those sensors collect data. The data that those sensors collect is not what you finally experience. So I started thinking in my mind that this thing that they call GIS is a real issue, that we should start thinking in terms of how we can use that one as a model for teaching students. What you see is not, what you see is different from what your eyes capture. What you see is already processed and loaded with the information that is already in your brain. That's the difference. Anyone that you have not met and you see them for the first time, you don't know them. But you find that next time when you come back to the same setting, someone you have met before, you'll be able to see the person and recognize the thing. And that is the difference between data and information. So this is now projected into real life. For example, if your phone rings, it gives you an alert. That alert that it gives you, if the person's phone number is on your phone, that's the first thing you look. Who is this person calling me? But if a number that doesn't have a name comes, you may choose to answer it or to ignore it. So what we see is different from what our eyes collect. What we see is the information, and that's what the GIS tries to do. That's why we call it a brain box. It was my supervisor who first mentioned that the GIS is a brain box for physical activities that we do. And what we do is to now see how we can apply it. I'm happy that we are trying to create our own brain box in Ekiti State, and we are following the fundamental principles, not just meeting it. When the last man, the geomatics engineer, was making presentation, he went through the whole spectrum of the learning that we have to do. They are already applying it. We are trying to put together our own brain box, but it is never late. Let us always remember that they are following the plan that God has for humanity. God has the plan that we should be able to develop something close to the human brain, where data capture is automated somehow. And, anytime you open your eye, you see a new geography. What you see is geography. Then the rest is processed by the brain, and then information is made available. That's what we are doing here. And then how can we apply it to all human activities that we want to do? And that's what we are doing. So I want to encourage everybody here that we should embrace this technology. I had wanted to start geomatics engineering program when I came back. And my colleagues who were here said, no, we can't allow you to do that. Otherwise, you will take us out of job. So that delayed it, and we have not been able to start the geomatics engineering program until I retired. But fortunately, the National Universities Commission has just approved for that program to take off. So that's the joy that I have, and I'm very happy with the presentation that was made. I was very, very happy, and I hope Esri will get to a point. Maybe Sambus will also create a university for teaching these kind of things so that we can have a new set of professionals. So thank you very much, all of you.
Please, can we put our hands together for Professor, ladies and gentlemen? I think I got very inspired. Professor said, what you see is different from what your eye will capture. When he came to this event, when I saw him first, I thought he will do his presentation in 5 minutes. But by the time he now said his PhD was 1992, my brain started capturing. So nice to meet you. Very amazing moment listening to you. Very inspiring. And now I understand when you said Governor Sanwo-Olu was your student, I now know why Lagos is, you understand? Yes, very amazing. Thank you very much. I especially want to appreciate His Excellency, the Executive Governor of Ekiti State, for not just sending a rep, but for sending a very perfect rep who has delivered very well. Professor James Bola Olalaye. Please can we put our hands together for him? Thank you. Oh, sir, you left your speech here. Do I have the privilege to keep it? Can I see it and capture it and take it? Capture. Okay. We'll go for breakfast. But before we step out for that, I want to quickly borrow your 10 minutes. And after that, we'll just go for breakfast. I will come back and explain how we're going to exit for breakfast. But the 10 minutes I'm borrowing, we're going to take we have to take 3 things before breakfast, but now we're doing just one. And that one will be in the frame of 10 minutes. And that is a technical deep dive into advanced spatial analysis and geoprocessing. We'll just do that in about 10 minutes. And to do that is professional service lead of the Abuja office, Sambus office. I'd like to invite Mr. Rotimi Jubril Salau. Please can we put our hands there for him? Can we clap for him so he can remember 10 minutes? Thank you, sir. I wish you the best in the next 10 minutes.
Good morning, everyone. My name is Salau Jubril Olarutimi. I'm the Professional Services Lead for Sambus Geospatial Abuja office, and I'll be taking this session, which is technical deep dive, advanced spatial analysis and geoprocessing. So the agenda is to visualize economic trend in 3D, geospatial analysis through creation and sharing, and then question and answer. So for visualizing economic trend in 3D, in the ArcGIS Pro toolbox, there are more than 2,000 tools, and for the first workflow, we would be making use of tessellation tool, which will show how we convert 2D to 3D. The idea behind this is normally we always see that what we want to show in 3D has to do with elevation, but for this particular one, we'll actually be using the 2D data and converting it into 3D. So the idea behind this is this. This data was actually gotten from portal, Living Atlas, to be precise. So it's VIRS data for the entire world. And then using extract by marks, we've actually clipped out Lagos from there. So for the process, the first thing is to now search for generate tessellation, which would now create XGrid for Lagos, which is the study area. So the first thing is to select where you would want the output of your data to be, which is your geodatabase, as you can see, which is what is on the screen presently. And then you select your study area or your study extent. You can now select the size of hexagons that you would want or XGrid. You can set your geospatial referencing, which, as you can see, it has generated for the entire Lagos state. So for the next slide is for you to go to attribute table, and then you create a zone integer, like a field where you would be able to, as each of the XGrid that has been created, you would be able to assign a number to it in a sequence. So next thing is for you to right-click, go to calculate field. So you could use Python extension, so you could do for it to actually calculate, as I said, generate numbers for each of the grids. The next thing is to now calculate statistics to this. So you could use the zonal statistics as a table, which is another tool in the ArcGIS Pro toolbox, and you select the XGrid that was created earlier for you to be able to calculate the mean brightness for each of the hexagon on your or within your study area. So we're using mean for this. So after you run this, so the reason it is showing, you can see a warning sign, is that you'd see that the grid that was actually generated, some of them actually fall outside the study area. So it's trying to tell you that for this particular area, it's unable to calculate figures for those areas. So the next thing is to now go back to your attribute, you could now join and relate. So it's for you to now select the X grid and then the zone integer that was created earlier on. So you could actually validate this before you actually run the tool. As you can see, it's going to give you or let you know if there's going to be an error at the end of the day when you run it after you. So after you do that, as you can go back to the attributes table, and you would see that it has generated the main value for each of the areas that has been created, and then we can now create another field, which is extrude, for us to be able to add the 3D data to this that will now take to scene. So for this particular one as well, you go back to calculate field. You see use Python expression for this. So the first thing to do is to now use the zonal mean that was calculated earlier. And then you could multiply it. So the idea behind multiplying it by 1,000 is just to sort of exaggerate so as to be able to make sense or show your results better, for you to be able to get a better visualization. So after you've done this, the next thing is to now create a 3D scene where you can come to convert in the view tab in the content pane for you to be able to export your data into a 3D scene. So you could just drag and drop it into the 3D layer. After you've done that, you come to types. You can use a maximum height based on the values that were generated earlier on, which is extrude. After you've done that, as you can see, you can go to symbology, and you can classify this using graduated colors, and then you set, as you can see, you can select up to 5, 10, 15, depending on the number of classes that you would actually want, and you could select the type of color. So as you can see, it has generated a 3D scene for night light for Lagos State, Nigeria. So this is how you can convert 2D data into 3D. So the next one is creating tool creation in ArcGIS. So for this particular task, we will be creating a Python tool. So for you to do this, you can actually go to the catalog, and then you right-click and you click on New Python tool. After you've done that, you could right-click and then click on Edit. You could edit this using Visual Studio Code, PyCharm. You have a snippet of the tool that was actually created on the right side of the screen. So after the tool has been created, for this particular one, we actually generated settlement growth fingerprint tool use. So for that, how this UI works is this. You could input old settlements and then new settlements. You set your output, and you could actually even add distance that you would want to use. And this would actually generate for you to be able to understand or know how settlements are spread over time. So for this particular one, using dummy data, we're doing this for Kaduna State. So as you can see, it has actually generated, and you can see where each of these developments actually, how sort of for you to understand the first building that was in a particular area and how from that particular building, other settlement actually came up. So after this tool has been created, you could go to actually run this tool using your Python script as well. You could create a notebook. So this is how you input you bring in the tool, and as well you add your layers or your input data, and then it's still going to generate the same statistics and the same result as what we generated earlier from the geoprocessing toolbox. Likewise, this particular tool that was created, you could actually use it in a model builder as well. So just like as you can see on the right-hand corner, where we go back to toolbox, and you could drag and drop it. After you've dropped the tool, likewise, you could bring in the layers that you would actually want to use. It's just for you to drag the arrow and bring it in and select which layer this would represent. So for 2025, it's going to be new settlement, while for the year 2020, it's going to be old settlement. After you've done that, you could modify, as I said, you could add buffer distance and unit, and you can actually set your output to this particular tool so as to know where your end result will actually be saved. And you can run the tool. So this actually shows the idea of how you could automate your workflow, because you could still add other tools to this for you to be able to get the end result that you would want. So it's just, the next thing is for you to go to your geodatabase or what that you're using, and you could drag and drop your results. You could come back to map, and then you see your result just like what we had earlier. So after this tool has been created, another thing that you could do is you could actually share this tool. You could go to a new item on your ArcGIS account. You could zip your script, drop it, and then you could actually select this tool to be a geoprocessing sample. You click next, you give the tool a title. After you've done that, you can save it. And after saving it, it's going to automatically upload it in your content on your ArcGIS account. After that has been done, you can share, you can actually keep this tool and use it within your own account, or you could share it within organization or everyone for the public to be able to have access. So here we've actually shared it within organization. So for any user within your organization, after you've actually shared this tool, you could go to portal and then you could scroll down, and as you can see, the tool is already there. So it's just for you to right click and then click add to project. After you've done that, just like the process that we've run earlier, you could anybody within the organization can actually run this particular tool. So that's the idea behind sharing this tool. So the QR code on the screen is, if you scan the QR code, it will take you to the tool. The script, it's on the Sambus Geospatial Data Hub. Thank you for listening. Please, if you have more questions, you can actually come to the technical booth, and you will find myself and my team members there to answer your questions. Thank you.
Okay, thank you very much. Please, can we put our hands together one more time? So I just want to confirm our exit doors, so if that can flow. But two quick announcements before we go. First is that, like we said, it's happening again like yesterday. We're a little behind the schedule, so the breakfast will be for about 20 minutes. It's just quick tea and something. And the lunch is coming very quick in the program. So you just grab as much as you can grab, very light, and then come back. We'll take quick sessions, and then we go back for lunch. So let's see how we can run the breakfast very quickly. I'm suggesting about 20 minutes. So I'll be back here at the 20th minute to come remind everyone. There are two doors we're going to use. Just what I want to confirm now. There are two doors we're going to use. And so we have one door there. Sorry, the hostess, can you wave? We have one door there. Yeah, at the far left, and another one here. So we can exit from this door or this door. There will be service points directly in front of you as you exit the door. And so we just grab quickly, and then we come back for the main session, for the afternoon section. Thank you very much. When we come back, we have lots of activities. We're going to have user stories. We're going to have a few breakout sessions today. I'm sure you'll love it. You'll enjoy it. Please, let's grab breakfast and then come back as quick as possible. Thank you. One more time, my name is Chukse General. I'll be back at the 20th minute to also proceed. This is 15 minutes to 12. I'll be back by 12 o'clock. Yeah, I'll be back by 12 o'clock. Thank you. 12 o'clock, please. Thank you all. Please, can we come inside? We're waiting. Let's see how we can start the program in 2 minutes. That's 120 seconds. Please. We are counting down. Please, can we come inside, please? I humbly request. Please, can we come back inside, please? Please, please. Thank you very much. I'm still hoping to get about 50% so we can start. Where are we, please? Help me tell people outside that we're already about to start. Please, thank you very much. Renaissance Energy Africa. Are we here? Anybody from there? Pronounce it. I got it, yeah? Renaissance. That's what I said now. Okay, what is it now? Small MC work I'm doing so they'll pay me. You want to spoil the work. Is that not what I said? That's not what I said. Oh, that's what you heard, but that's not what you captured. Okay, it's a capturing issue. Okay. The capturing issue. Okay. So, wait again. Renaissance. That's normal shell, Abi. Okay, it's not shell. Okay. It's not formally shell. Formally an NPC. That's shell now. Formerly Shell Petroleum Development Company. Okay, now Renaissance. Okay. Please, we need to gather everyone. Can we just please come back to the hall? Ladies and gentlemen, please, can we just come back inside, please? I humbly request that we all please come back inside. Then, for the exclusive sessions, those for oil and gas, natural resource sessions, those primarily in the oil and gas that will do the exclusive session for oil and gas. Please, those for the oil and gas session. Okay, first of all, those in the oil and gas space, can we just wave? Okay, we don't even have. So, design. Oh, okay, so let's just be cooperating now so I can administrate the thing, please. Design and construction space. Can we, those in that design? Okay, so we have like 2. Okay, so we don't need to have any issue now. We have 2 for design and construction only. Okay, so, okay, ma. Okay, please, can we, I need to to choose the hall where you will be. Can we just cooperate, please? Oil and gas, please. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, Emek, about 15. Where's Emek? Hi, planner. Where's the planner? Event coordinator, 15. Okay, so please, 15 of you, can we come this way? Yes. Those that will do the oil and gas breakout session. Okay, I have a change of plan. Please, sir, can we come a little forward? Please, sorry to disturb you, please. Then oil and gas, can we just file in there? Sorry, sir. I'm sorry to disturb your sitting. There's space. We have space there. I'm very sorry. Sir, oil and gas. Okay. Can we just please oil and gas? Please can we go? Oil and gas. Can we sit there? Then the second. Oh, I need to disturb you, please. Can we go on the next row? So this roll and that first roll after the door is oil and gas. How do I explain to them that, sir, can we go on the second roll? Yes, thank you. Where they stood up from? Sir, here. If you don't mind, I'll be glad. Please, can we cooperate? I need to create this structure so I can do what I'm asked to do, please. This is oil and gas, Abi? No, that roll is for oil and gas. Yes. Let me tap that. Sir, oil and gas? Okay, that roll is for oil and gas, please. This roll and this roll should be, let's do oil and gas. Oil and gas. Bros, oil and gas? Okay. Oil and gas. Oh, okay, I didn't know. What you do now? Okay. Oil and gas. Yes, that's it. I'm looking for you. Oil and gas. If it's more than this roll, let me know you are oil and gas. Let me tell you where you sit. Please, oil and gas, don't sit on your own without telling me. This roll and that roll. Okay. Now, design and construction. Here. Sorry, sir. Design construction? You don't have anything to do with that, Abi? Okay, can we? If there is oil and gas remaining that's not seated yet, please let me know before you sit. If you're not on that roll and this other roll, tell me first. Don't use your discretion. So I can give you numbers, please. Thank you, ma. Yes, ma, here and here. Thank you, thank you, thank you. Can we cooperate? It's a little bit difficult if you're not cooperating, please. Sir, it's oil and gas, not groundnut oil. Hello, sir. Sir, re-oil. Okay. You are in re-oil and gas. You can sit here, yes. Because the way that man just came here. You are not oil and gas. Me and you are together. We're just eating palm oil and groundnut oil. Okay. If someone is just coming in and you are oil and gas or construction, let me know before you sit. Thank you. The rest of us can actually now occupy. This place is empty now. You just left it. All of you just left it. No, I've not called your category. What's your category, sir? No, tell me the one you are. Let me call it. Academics. Like you want to be like that professor that spoke English. that way. Okay, so let's fill up. Let's just come. Energy. Oil and gas. I've been saying this since. You want to use oil to threaten me? I've been saying the oil and gas since. Yes, sir. Yes, ma. You are what? Utility. I'm coming, ma. Yes, I will get there. I want to just sit. Okay. Please, can someone help me get Mr. Fernandez that oil and gas is already together? The event team, can help me get Mr. Fernandez? Then, okay, so why I pulled out these two people differently is that the people that will have the exclusive sessions with them want to see them. That's why. So the rest of us, I will tell you who your session takers are, who will do your exclusive sessions with you. I'll let you know. But the two of them, the man from Dubai and the man from Saudi Arabia, wants to see this session. So this is just design. Okay, so can you use a smaller venue for design? Where is? Yes. So I'm ready. I'm ready for oil and gas. Yes, oil and gas is ready. I want to believe that some people are seeing design that are yet to come. So let me give them a bit of time. Now, we'll take our good afternoon, distinguished delegates, ladies and gentlemen. We'll continue with our conference. Now it's time for geospatial innovation in private sector. We're about to hear our user stories, and we're taking some around from private sector. It's user stories, and we'll be taking private sector. I'd like to invite Renaissance Energy Africa. Please come and tell me what. We'll take our first user story, and it will be from formerly Shell Development Company. I got that? I didn't get that. Okay. Then get your slide ready. Renaissance Energy Africa. Please, can we put our hands together for her? Can we clap for her? This is the first lady to come on the microphone. Men are not clapping. I don't even know this country, what we are up to.
All right, good afternoon, everybody. Um, okay, so good afternoon again, everybody. I'd say it's been an interesting couple of days so far, and it's an honor to be here representing Renaissance Africa Energy Company. So I'm going to be talking about geospatial innovations in the energy sector, and I've called this transforming energy. So maybe, okay, so the question is pointless now because I see that my oil and gas people have just walked out of the room, but if you spend any amount of time in the industry, the first thing that you come to realize is that there's a delicate balance that we're always trying to maintain in the industry. So first of all, our primary objective is to discover and produce hydrocarbon. Without this, there's no industry, there's no business, right? And to put this into a bit of perspective, in a CBN report from February this year, February 2025, they said oil revenue accounted for 30% of the entire federal government's revenue. So you see that it's important that as an industry we're able to continue to do what we do, which is simple: produce oil and gas and make money. So after that, right, how do we continue to do what we need to do? We need to ensure that we are compliant in terms of regulatory and statutory requirements within the industry. That's what we need to do legally to be sure that we can continue to operate. Apologies, I forgot about this. Yeah, to ensure that we can continue to operate within the industry, right? And then next we have the non-negotiables. We have safety and the environment. Everything that we do within the industry, we have to do it safely, and we need to ensure that at all times we maintain respect for the environment. So what we need to do is clear. Produce hydrocarbon, remain compliant, keep an eye on safety, and respect the environment. It should be simple, but there are challenges. If I were to ask anybody here now what you think the major challenge facing the oil and gas industry is, I think that we would all say what I'm thinking right now. Again, for perspective, a forum organized by the NMDPRA, that's the Nigerian Midstream and Downstream Petroleum Regulatory Authority. They had a forum in July 2025, and the Deputy Speaker of the House of Representatives estimated that as a nation, we lose over $79 million to crude theft every single day. So imagine what that is in a month, imagine what that is in a year. And that's in addition, of course, to whatever sums would have to go towards repairing sabotaged or damaged assets, that would have to go towards remediation activities once the environment is compromised, and also the value that would be eroded with any deferred production that happens as a result of that. And this is the point where GIS comes in. This is where your geographic information systems become important, because what we're trying to do is to not just be able to continue to do what we do, but we also need to continue to thrive, to grow increase production, and meet those targets. So at this point, we turn to the vast amounts of geospatial data that we have within the industry and even beyond it. So the IOGP has estimated that about 80% of the data in the industry is actually geospatial. So this gives us an idea of the kind of solutions that we can begin to deploy, keeping an eye on that data and geospatial technology. So I'm going to be highlighting some of the solutions that we have deployed so far. Of course, leveraging the Esri suite. Okay. So first, we have the geofencing system, right? And it's basically a surveillance system. And when you talk about surveillance and asset surveillance and monitoring, your primary objective is to create a system that allows you to proactively respond to incidents, to either entirely mitigate them, to avoid them, or to reduce the severity of the consequence that comes as a result of that. And that's usually done by being able to minimize your reaction time, right, between the point that the incident happens and the point that you are able to fix it, basically. So the geofencing system is, think of it as a digital fence that we have deployed around our assets in the shallow water area operations. Okay. And what it does is that the moment that an unauthorized vessel enters into the marine exclusion zone around our assets, an alert is triggered for follow-up action. And what that has done is that whether the vessel strays in mistakenly or whether it is deliberately encroaching into that zone, we are able to take action so that it doesn't get to a point where incidents happen, maybe collision with other assets or vessels or crude-related issues. In the same area of operations, right, the shallow offshore areas, we also do have a lot of jack-up barge moves that need to occur during the year. We also have field support vessels that are moving around the field, carrying out different operations. And it's important that we provide the required location intelligence to make sure that all these activities can occur simultaneously within the same area. And what goes into that is a lot of mapping, a lot of visualization, a lot of analysis. So if you're talking about a jack-up barge move, for example, you need to look at where is it coming from, where is it going to, and you need to chart a passage that takes it safely from point A to point B, keeping in mind the infrastructure around it within the field and also the water depth wherever you are. When it gets to its location as well, you also need to ensure that it is able to position safely. Again, integrating data like geotechnical data and data from historical moves. So we also went a step further and created a move tracker to be able to visualize the planned passage move against the executed move and then start to highlight portions of that move where you see that the jack-up barge has moved to a certain distance from an asset. So those areas are now highlighted and we can start to discuss and improve on that process. So I'll go now to the environment, which I mentioned as a non-negotiable. So first we have the flood monitoring dashboard, and it's a real-time solution that we've deployed specifically to allow for monitoring of water levels within our areas of operations. And the data that we see here on this dashboard, I know that it's not clear for everybody, but the data that we see here is updated daily. And you see that there's a web map that's included in that, and what that web map shows is the estimated flood risk per location. And what this allows us to do is to, first of all, be able to compare the current water levels against historical marks, right? So we have water levels there going as far back as 2012. So we're able to see that for each year, and then we've also been able to establish thresholds based on that. And those thresholds are per location. So what it means is that when the water level at a certain location gets to that point, follow-up action may need to be taken to ensure safety of assets and lives within that area. Still on the environment, we have the net zero deforestation projects as well, which are remote sensing projects that we do. So the primary objective of the net zero deforestation is to ensure that for any deforestation that must occur in the course of our operations, we are identifying suitable sites for reforestation. So if deforestation must occur here, you need to find somewhere else where you are reforesting an equal amount of what has been lost. And we do this through remote sensing, which is one of the beautiful parts of GIS as well, right? So projects that you would have had to send somebody to the field, you send the whole crew, mobilize them to the field, maybe they are there for months just trying to do this identification. It's now a process that you can sit in the office and in a matter of weeks, you have this completed and delivered. Another thing that your remote sensing solutions do as well is that for every time that you deploy a remote sensing solution or analysis, it means that, like I just mentioned, you're not spending money mobilizing a crew to the site. It means that you are minimizing your HSE exposure as well. You don't have survey crews outside that are exposed to the elements. You don't have them outside exposed to security risks and all of that. And you also have the data that you can continue to use and reuse. So this is my last slide. I see Chooks in the aisle. So I'll just say that this is a continuous process, right? We are always learning to understand the challenges that we face. We're learning them, we're understanding them, and we're adapting to these challenges to be able to deploy more fit-for-purpose solutions. Of course, there's an ever-growing need for faster solutions, safer solutions. We want things that can do what we need them to do better and faster. And so we see that geospatial technology is moving or has moved more towards artificial intelligence, Internet of Things, machine learning, and it is a change or a trend that we as an organization have fully embraced because we see that in the integration of those things is where we are able to reduce inefficiencies, optimize workflows, and drive smarter decision making. And all of this will come together to do what we need it to do, which is basically unlock greater performance for us, for the nation, and for the region. Thank you.
Please, can we put our hands together for her? I think this is the first lady that have done a presentation. Why men are not clapping, I don't understand why. Thank you. I like the way we're going quick. We're going to move a little faster too, and I'm sure we are ready. So, utility. Yes, you can. Utility, you can go. Yes. I'd like to now invite. Oh, sorry, design and construction. Sorry. Design and construction. Yes, please. Sorry. We're going to take our next user story, and that will be Support System Limited. Design and construction. Yes, you can go. That will be for support system. Please help me welcome Mr. Ben. This is the first man to smile for me when I came to this conference. Can we clap for Mr. Ben? Personal requests. Help me clap for Mr. Ben. Thank you, sir.
Good afternoon, everyone. I don't usually have bars on my voice, so I don't know what's happening here. All right. All right. I'll stand on all existing protocols. But I'll start by observing that this meeting is a meeting of practitioners using GIS. And the president of the Geoinformatics Society of Nigeria was not recognized. So please, where is Dr. Fitka Bishaka? Dr. Fitka. So that's the president. And I felt he should be on the front row. So with your permission, can he come to the front row? Please. That's my president. I need to honor him. Thank you so much, sir. Thank you. Also, to recognize some special people, Professor Olaya taught me in 2022, 202-203 Masters in GIS. Thank you, sir. Thank you so much. And he's still practicing. All right. So we are, of course, Support Systems Limited. We have 25 years experience in GIS, IT, document management, digital scanning, and then we deploy a lot of our solutions. But I'll plead the Fifth Amendment here. I'm a Chief Data Compliance Officer, and you know right now, NDPC has made it mandatory that if you put anybody's data outside without consent, it is 2 to 5 years imprisonment. And I'm still young. So a lot of those things, we don't have data here. All right, but we'll talk about the issues. My topic is about data traditions with GIS and the challenges faced by the private sector. You know, the Surveyor General spoke yesterday about flying the drone in Abuja and then putting Geo AI and finding very wrong decisions. It has to happen. Geo AI is written on already informed data. We don't have the data here. It's like cars that drive themselves in Dubai. If you bring it to Nigeria, they will have accidents. Because we don't obey rules here. We don't obey rules in Lagos. So that's the biggest issue we have. So the root cause of our issues is data inconsistency.
story goes from Shegilola gold deposit to a completely new gold deposit that becomes multiple commercial mining pit. And before I go fully into my presentation, I'd like to give a brief of what the mining value chain looks like for Shegilola. So the project starts from exploration to extraction and rehabilitation. When we are talking about exploration, the question is, how does GIS factor into exploration as for a company like Shegilola? The most fundamental question an exploration geologist is asked on every day we go to the office, we go to site, is the question of where. And here is the question: where is the gold? The location. GIS is a location-based system. Shegilola is trying to find the location of the gold. You see, GIS is very important to us. We understand to do exploration, we are opportune to have access to a series and a lot of information, a lot of data. Most times when those data come to us, they are scattered, disjointed. Our work requires us to get real-time data so as to make decisions right on ground, because most time you're on site and a decision has to be made by a GO on site for the contractor to know the next step of action, what they have to do. What GIS does for us is bring structure, insight, and bring speed to our exploration workflow. Like I said, a lot of data, but chaotic. If you look at the map on the page, the map has a series of information on it that anybody looking at it, we ask yourself, what are you looking at? It doesn't really make any sense. But when you start combining GIS and making sense of it, the same data from here is this. This is just a map showing the mineral occurrence of Nigeria. This is a map showing the various licenses given out by the MCO. And this is a map of lithostructural information of Nigeria acquired from NGSA. One of the tools we use GIS for is to manage our license. Like I said, MCO give our licenses grants for exploration. We acquire various grants, over 2,000 square kilometers, multiple licenses cover those areas. We use GIS to manage the license boundary. This is a map showing some of the location of Shegilola current license. That is a map showing the road network that passes through some of the licenses across the whole country, which is part of what we do when we do proximity analysis to determine the road network that passes through our license for accessibility, the kind of infrastructure in terms of airport, power, the kind of geology we have in the area, and nearby deposits, which informs our decision making. The next step we usually do after acquiring licenses is desktop study to understand what the area we have, what kind of geology are we dealing with. This is a map showing the geology of an area. This data is acquired from NGSA. Some of the data we use are geological maps, satellite imagery, ASTAR data, which sometimes we use in predicting potential areas where we are likely to find structures capable to host mineralizations. Then from there, this is a terrain model integrated into our system. This is just a basic slope designed for an area where we are working. The idea is to generate slope and use it to determine, combine with some structural information, use it to determine the likely area where the mineralization is likely to fall into. This integration of an arrow mark, a geophysical data, just to understand what kind of lithology you are dealing with and the structures we are dealing with. When all these things are combined, it takes us to the next step, which is target generation. when targets are generated, we make decision on where do we sample and how do we sample them. The first map is showing some stream sediment sampling plan location, while the map on the bottom left corner is showing some gridded sampling profile for some of our soil program. These are turned into field maps given to the geos and the geotechnicians to take to the field so that they pick the samples at the correct locations. Integration of QA, QC, and lab results. So this is showing integration of one of our anomalies. After the samples have been picked, the lab have done their work. We come back, put them back on a map to look at where we have the anomalies, the areas that we have our interest should be picked. And from there, we developed some various targets based on the initial information we gather. Then, part of what we use when we are doing this is automation, which ArcGIS Esri products offers us, because most of these tasks are repetitive tasks, and a lot of people get to do it multiple times. So we built some set of tools so that once it's set up, everybody that needs to work on it just goes in, pick the tool, and you get your work done. One of the new tools we start using currently is the suitability modeling. We've acquired some geochemical anomalies and a series of other informations. Now it's time to combine them and turn them into a more complex information that will be easy to read for anybody looking at it. This is a raster map developed using the geochemical anomaly from stream using kriging. When the stream interpolation was transformed to class ranges, this is what we have. Soil interpolation using Bayesian kriging. When interpolation was done, we have this. Rock interpolation using Bayesian kriging. When interpolation was transformed to class ranges to classify the areas that we are interested in. And this is a suitability map to generate a potential drilling target based on combination of the stream, the soil, and the rock chips that we have the anomaly in our hand. And this is a final map ranking the potential drilling target that we have generated. If you look at the last map that came in, you see there's a gray area, the blue, yellow, and green. From my legend here, the gray is the top ranking target, yellow is second, green is third, blue is fourth. Part of what we use GIS to generate is to monitor the programs, our sampling program, create dashboard to monitor our sampling program, and give a live update of what our program is currently going through. When it comes to mineral exploration, every work we do ends up in drilling, because drilling confirms what is in the subsurface. And what is in the subsurface is what we are interested in, which is where the gold is. GIS affords us, after generating our targets, affords us the opportunity to plan our drill hole collab, make orientations, and make plans for where we want to drill.
Conference, the science of where. Everything that was presented there just excited me. The way they did it. And funny enough, today they mentioned one of the tools, which is one of the things that they presented at that conference, which is the Dubai Pulse, which is something that Mr. Adele talked about, which is completely fantastic. So I'm excited to actually be presenting at a user conference. So let's get right to it. Allow me to share with you our story, our Redwire story, on how we have been able to make our clients not just the best decision makers, but some of the smartest decision makers, driven by data. Data has to be one of the most foundational things for anything. One of the most foundational things for anything. It drives everything. To me personally, I feel like it drives everything. You need to know. You need to know in order for you to make decisions, in order for you to do anything. So being here today, I'm going to be presenting how we at Redwire actually use data to help our clients become some of the best decision makers. RedWire primarily is one of the foremost research brand and strategy consultancy. In simple words, we help our clients solve problems. We are problem solvers. We can go from today to tomorrow telling you how we have done this, how I've done that, but I think the summary of it is we are problem solvers. What we try to do is we look ahead. We try to, what's the name of the man? They said the man that saw tomorrow, I think is Nostradamus or so. We look ahead, we use data to try to give our clients an insight into what will happen, what is happening, and what will happen. We are driven by intelligence. We are a company that is driven by intelligence, marketing intelligence, consumer intelligence, location intelligence, constituent all intelligence. That is what we do. We are driven by that, and we use that to push our clients. In the last 5 years, we have collected over 1 million data points across Nigeria using the Esri tools. I must add that part. We operate completely within the Esri ecosystem. We have worked with over 4,000 mappers across the country. We were very particular about this, our Esri ecosystem. We work with a lot of the fantastic tools that have been presented to us. Obviously, ArcPro for our analysis, Esri field maps, ArcGIS Online, Survey 123, and dashboards. How is RedWire utilizing geospatial tools in enhancing operations English? This is one. I'll use case study 1. Now, this is a dashboard. This is a dashboard of a market analysis, a market research we did for a client. But please, kindly note that a lot of the data that we're going to be displaying is dummy data. We cannot display our clients' actual data. The X and Y may be correct, but the other data is not a reflection of what it actually is. So this is a dashboard we designed for our clients. Our client was trying to find out what their strengths and weaknesses are, what competition is, what they're targeted, what their consumers are, what their consumers are saying, consumer behavior and all of that. And we had this live dashboard running with people collecting data all around the country for this particular brand. You see, it shows their service delivery ratings, how they rate their services, competition X, which is our client, versus top competition. It shows income brackets of the consumers, people consuming their product, the basic demographic information. This is another one for political intelligence. Now, this is for, again, dummy data. This shows the performance. This shows the performance of different political parties, or the two prominent political parties in the state, giving an insight. This was a research work done, giving an insight into government projects, how many government projects have been done. This is actually an interactive dashboard. If you click it, the whole thing changes when you select a local government. So I think right now it's on Eastern Northeast. That's why everything is filtered to Eastern Northeast. So this gives that intelligence of what is happening, different performances. It gives you the insight. How many government projects, infrastructure, in terms of infrastructure, education, water scheme, all of that. So we were able to do this. Then this is my favorite. Sorry, I'm going to maybe get a little excited on this one. This is my favorite. Now, I think Mr. Adel did a little bit of justice, or a lot of justice, to what the Esri field map is. But the Esri field map, to me, besides the ArcPro, is one of the most exciting tools. God's honest truth. It's one of the most exciting tools on the Esri suite. The points you see are outlets that will possibly stock one of our clients' brands. The ones highlighted in green are outlets that have the brand in stock. The ones highlighted in red are the ones that don't stock the brand at all. Then the ones in the gold color are the ones that have the brand, that stock the brand normally, but are out of stock at the moment. So we mapped out all the outlets and created this live dashboard where the brand representatives that go around, they have their daily routes, they go around, they know the inventory of each of the outlet owners, so they update this. So with this, you are able to see the performance, who is not in stock, and decision makers can do that. Decision makers can make decisions based on this. And this what is powering this is the Esri field map. I think one of the most fantastic things about the Esri field map is even the integration with your Google Map. So if I have this, let's say this loaded on my Google Map, and somebody needs to find a particular outlet, if you click on it, it integrates seamlessly with your Google Maps, and it gives you directions to the particular outlets that you want. And that's fantastic. That's the brilliance of some of these tools that that Esri has managed to design. So you see the full performance number of in this particular selected outlet. You see two branches, local government. Sorry, 2 branches have the product in stock, profit margin from last year. They are able to, again, these numbers are dummy. So with all of this, we have been able to use these tools to help our clients make better decisions, smarter decisions, data-driven decisions, be the best, insightful decisions, be the best version of themselves. At Redwire, we believe in proactive insight. I think somebody mentioned that yesterday in the presentation, and I was like, yes, that actually is what we do. We believe in proactive insights. We do segmenting the consumer markets. We also do research in terms of measuring poverty. We have done poverty studies in different parts of the country. We have collected data. We have done the analysis. We have done the reports. We do framing economic narratives. We collect data to help that, tracking political pulse, site suitability, even the site suitability, which will, another Esri tool. Sorry, a quick story. Okay, thank God Chooks is not around. No time. A quick story. Site suitability. I was just coming back from leave, and my boss called me. I had not even entered my house. My boss called me. I was like, oh, we need to do this particular project that involves site suitability. And Mr. Adel yesterday mentioned that in strategy, you spend 40 to 50% of the time gathering data. And I needed to gather some data. See me looking for data all around, calling all the people I know. Because before you go into the field, you first do primary data. Something just pushed me away. You have your Esri suite. I went to the Esri Atlas, and three of the 5 data sets I needed were already there. The other 2, I know why they were not there. Because, again, everybody has mentioned that there is a data gap that needs to be filled. But out of the 5 data sets I needed, they had 3. That's my prof said, that's pass mark now, at least that's above average. They had 3, and not just 3. Those were very important data sets. And that's what living in that Esri ecosystem, working within that Esri ecosystem gives you. It gives you that opportunity to be able to work effectively, the best version of yourself. At Redwire, we commonly refer to our brand and marketing as intelligent marketing, as I said earlier. It's not guesswork. If we tell you cite this thing here, if we tell you do this thing here, if we tell you this is how to tailor your campaign, if we tell you, and not just political campaign, brand campaign, whatever it is, if we tell you do this, know that we're not just telling you, yes, we're coming from years of experience and all of that, but it is also the foundation of every insight, of everything we tell you is data. It's based on the data that we've obtained. And every tools give us the ability to collect, analyze crucial data that is crucial to strategic planning and decision making. Thank you very much. I did under 10 minutes. There's nothing you tell me.
Thank you very much. The good thing about our user story segment is that it's a good time for us to get such wonderful feelers and get them to talk about their experience and how it's going. So one more time for Support System Limited, for Shegilola Resource Operating Limited, and for Redwire. Please, can we clap for them? Can we put our hands together for them? Okay, so we're going to a next segment. After this segment, we'll go for lunch. When we come back from lunch, we'll take 3 segments, and then we are done. I needed to give that summary so that everyone can be seeing the end in view, and we can be able to survive in this hall together. I saw that some people are already eyeing me with their red eyes. But I must say that it's been a wonderful time. It's been a wonderful time, very impactful, very insightful, very encouraging, and it's been a distribution of knowledge like never before. So I'm sure we're having that good time. We're going to invite 2 people to run this segment, and we'll go for lunch. And this is environmental focus. We're focusing on environment now. So we'll be doing monitoring and climate action. So I'm sure that the first man will be more on climate. And so for FIG Climate Compass Task Force, I'd like to invite Mr. David Elegbede. Please can we put our hands together for him? Mr. David already assured me that he will be on this for about 10 minutes. So we have Mr. David Elegbede on stage. In my opinion, I think we should clap for him again to keep us warm. And okay, thank you. So I've noticed categorically, and if you give me the permission, I can point at them if you want. There are some people in this hall, I've noticed them since yesterday. Anytime I say clap, they have never clapped since they came to this hall yesterday to today. I know them. If you ask me to point, I will point. But I'm sure you don't want me to show you who they are. I don't know what I did to them. I don't know what the speakers did to them. They have never clapped. One is looking at me now. I'm looking at him. So now, can we clap for Mr. David? He still didn't clap. Hello, sir. Okay.
Thank you, Chooks. Good afternoon, everyone. And I bring you warm greetings from the International Federation of Surveyors. As earlier introduced, my name is David Elegbede, a registered surveyor here in Nigeria, based in Nigeria. And I'm a member of the International Federation of Surveyors Climate Compass Task Force. Permit me to adopt the realities and I give you your respect. This presentation was actually supposed to be split into two. One by Clarissa Augustus, who is the lead of the task force. Unfortunately, due to media issues, the audio could not come out to the audience, so I rather want to run through it. So I'm going to take you through a journey, and let's assume we are now taking off, and please use your seatbelt and let's join together. Okay, so we actually had prepared this, but unfortunately we just go on and I'll just do the discussions. So first, okay, let me give it a pause, yes. I need to give us a background. The FIG is a UN-recognized organization representing interest of surveying, which cuts across different disciplines of surveying and not just land surveying alone. We're talking about the planners, we're talking about anything environmental, spatial, data, and the likes. And it will interest you to note that Esri is actually a corporate member of the International Federation of Surveyors. So the council decided to bring alive again the FIG Climate Task Force to run between 2023 to 2026 with a term of reference that says that to raise awareness. So we assume that we know that there is a climate issue, but we might not be aware of possible solutions or actions that we take that causes disasters within our environment. Build on surveyors' climate actions and harvest their knowledge and communicate it. Surveyors are also active players. It's well recognized. We've discussed it yesterday. The Surveyor General has spoken. All of us are trying to see what we can do. But from the surveyor's perspective, we want to be able to outline the roles that we can actively play and contribute our quotas and put the same items out to colleagues so that wherever they find themselves on planet Earth, they are able to implement. The task force activity, so far we've had our FIG working week starting from Orlando in 2023 to Accra in 2024 and Brisbane, Australia this year. And we've had webinars talking about climate issues cut across the different regions of the world. Also, we'll be having a publication of 16 climate actions that will be launched in 2026. And these publication would happen in Cape Town during the FIG Working Week in May. You're all invited to be a part of it. You can read more on it on www.fig2026.org. Like I mentioned, Esri definitely will be there. They are active players. There are practical guidelines on key actions and tools for climate resilience, and these we have identified, we'll outline them, and we are much interested in ensuring that there is surveying land, marine, and water and marine, and for people and economic knowledge to be able to identify for growth and poverty alleviations and to improve our environment, most importantly. There are 16 geospatial key actions that we have outlined, and we look at ethics because in all of this, the last presenter talked about, this is a dummy data, these are dummy data. So the surveying profession itself is guided by ethics and standards, and we want to find a way to ensure that these ethics and standards are used in the implementations of solutions that we might be trying to provide across all professional engagement. Also interested in the people, because we are all here, but some guys are not here, and those are the people who we might need to reach out to also. That is the local people, the woman in the market, the people who do not have access to this kind of guiding. Then surveying and governance, very, very important, and we've heard from the Special Advisor to the Governor of Ekiti. We've heard from the representative of the Governor of Lagos State yesterday, and we've seen how much governance means to some of these policies and legal frameworks that we come up with. Quality assessment, it is not just gathering data, it also has to do with the quality of the data and technical capabilities and use of AI to automate, be able to predict what will happen next so that we can prepare for them. Customers and users, education, training, and continuous professional development. This is very, very critical. We've had a lot of discussions so far. We need to keep building our capacities to be able to meet up with these challenges when they come. Scaling up the workforce, redesigning geospatial and cadastral, urban, rural, and disaster risk management, climate-related conflict displacement. The smart cities that we want are actually embedded in these things, and it is important for us to put them to play and see that they are actually put to work. Government-led response and role of international bodies like the International Federation of Surveyors. Our key focus as surveyors has to do with infrastructure. To put these things, we can do the design, but how do we put it on ground? We can do the beautiful designs and the beautiful models, but we still, the input of the surveyor is actually needed to be able to put these things implemented on the ground. So if we have done any design, and some of us who are very good in construction, extract your point out, somebody needs to go and replicate these things, whether by robotic or anything, but even robotic needs those guides. So it is important that in everything that we do, the role of surveyors actually goes into infrastructure, water, waste management, and utility, placing them in their true position and ensuring that there is a direct flow of these utilities and they are able to get to where they are supposed to get to and who they are supposed to serve. Sea level rise and coastal zone management. This is something we're beginning to shy away from, especially for a city like Lagos, where land is becoming a scarce commodity and we are already encroaching into our habitats. Land use change, carbon emissions, and protecting natural areas. We cannot shy away from the pollutions we have, even though we have strong body because of the color of our skin, actually. Maybe it's an advantage. However, we must also recognize that some things are changing every day. They might not be visible to the eye, and we must catch them ready. We must catch them and begin to put them to consideration in all of our policies. Managing urban sprawl into agricultural area and into agricultural areas and agriculture into natural areas. We see now that agricultural areas are now becoming urban areas for want of land. And in doing this, it is not enough to just allocate from the comfort of our laptops or from the comfort of our designs. We must put into planning and make use of geospatial intelligence to be able to come up with the best fits kind of urban developments that we wish for and be sure that they are very sustainable. Building climate resilient geospatial and cadastral data and system. We've had that in our keynote, and you'll see that the optimization would actually aid the information of knowing who owns what, where, and when it was owned, and speed up the process of our system, information system. Now, so it could be land, it could be cadastral information system. And to also add that it is important that government is able to know what they have and the quantum of what they have and the kind of revenue that could be generated from them. Land restoration, forest, wetland, rivers, and lake protection, and implementation of national climate plan. There have been a lot of COP meetings every year and year. It is important, even though we have different cultures, even though our backgrounds might not be the same with that of the developed world or the Western world. But it's important that we take note of some of the things that are workable and try to see how we can make them work at our end without actually affecting our culture or our background. Climate resilient geospatial application, land administration, land use planning, cadastral surveying, valuation, infrastructural development, compensation, and property market. The coastal road is one good example. And if not well planned, if not well mapped, how will government know how many people they need to compensate? It is good to hide development, but it's also good to put everyone into consideration. And these are some of the things that we are hoping that the surveying community is able to assist government with in all of its activities. Indigenous and local community tenure, land consolidation and readjustment, geospatial data collection, analysis and management for strategic planning and disaster risk management, carbon upfleet management, displacement and relocation of people. When you displace, where do you want to put them? A proper mapping helps you to know where you can put them. Proper mapping helps you to know where you can put them that also does not have an effect on their economic benefits. Just like in Lagos here, most people who are on the Riverine area are declared to be informal. And myself, as a student of urban and sustainable urbanization at the Center for Housing and Sustainable Urbanization in UNILAG, I've also learned that they are classified as informal. They are being displaced, but where do you want to put them? But a proper mapping helps you to understand, because while you are taking them away from the riverine area for the purpose of safety, environmental safety, you also note that it also has an economic on its own that can be improved upon if we use an integrated method of approach. Digital twin, I think yesterday we talked about a lot of these, and valuation for insurance and land use partners analysis. This is very critical for the government, and I think that is one of the reasons why the president have decided to put the Surveyor General close to himself. Our call for actions. This is what we're trying to push at the International Federation of Surveyors through the Climate Compass Task Force. Develop and implement climate resilience land governance practice. It is very, very important. We should not wait for it to come before we act. It is not until there is a disaster before we take an action. So it is good for us to have an understanding of our environment and put in place mechanisms that would help us to avoid disasters. Build geospatial tools for climate resilience and safeguarding land rights. Build capacity in using spatial data for climate action and disaster recovery, and strengthening standard quality, access, and new tech, develop new data acquisition tool for West African context. So we need to continue with our innovations, and that's one thing you would appreciate Esri for. Every time new innovations are coming in, for some of us that receive email from Esri, you see there is a new learning, there is a new improvement, there is something they're trying to optimize to ensure that everyone is kept abreast with new technology. We design systems to reach national environmental goals and engage in regional partnership and knowledge sharing initiative. I'm already preparing for my descending, and I hope you are joining with me. In conclusion, so we have a strong message for the gatherings that we have today, and that is, that, let me go back to conclusion so that we can go run it together. Surveyors undertake many critical climate actions which often involve multiple stakeholders. While government plays a major leading role, and climate, private sector, academic, and national and international institutes, train institutes, and industrial building new technology tools are also key to climate resilience in surveying. Climate action involves technology, governance, and the people itself. No matter what you're doing, technology, yes, governance, to put in the policy, but again, we need the people to be involved, which in climate context also means safeguarding people's land rights and livelihood. To support climate resilience of people and the environment, surveyors are strengthening and adapting professional standards. As new technologies and progresses emerges, quality assessment as well as testing and developing new data acquisition tools are key. This is something for what surveyors are well known, and it is vital for sustainability, both for system both in terms of system design and climate resilience. This also means adopting AI and machine learning, and that is why we see optimization. Guided by the reasons of surveying for accuracy, customers, both old and potential, need to be supported as they too walk the climate resilient journey for adaptation and mitigation. To ensure that the surveying industry can do the job, surveying education, training, and continuous professional development need to be geared to support the development of surveying for climate resilience. This is also needed to scale up the workforce that has undertaken the required climate action locally, nationally, and for the planet as a whole. International and regional surveying bodies play a major role in supporting national organizations to do this by providing manuals, documentations, good practice for climate resilience, and supplying use cases that can be adopted for local contexts. To ensure that the surveying industry can do the job, surveying education would have to continue, and we will keep on with educations like this. In my closing, the first major environmental disaster that is recorded in the history of mankind was the flood, and that flood was the story of Noah. I am sure one way or the other we have all heard about the story of Noah, whether in one book, depending on the context that you want to put into it. Between yesterday and today, we've had different experts talk about different things, and in this hall, we have different experts here, and everyone is seated because we want to contribute to geospatial technology, and we want to learn to be better and provide solutions. Now, the beautiful thing about Noah's story is that if you are close to my age, I am sure you watched my book of Bible story. And in my book of Bible story, the cartoon now, it was cartoon we watched. Then somebody came and said it is called animation, so I will accept it like that. So in my book of Bible story, you will see that Contrary to the story that says that a bird went outside to be sure that the sky is okay and everything is calm for them to be able to come out. But in my book of Bible story, the cartoon shows that even the elephant was holding the wood for Noah to be able to eat the nail. The giraffe was helping to put some wood up to be able to put the roof. Now, what I'm trying to say in essence is that every animal that survived the flood during the time of Noah actually contributed something to keep safe, and they all enjoyed it. There's no better national cake than that. I want to employ us today that the safety of our planet Earth is in our hands, and we all have a role to play. Thank you for listening.
I'd like to appreciate David Elegbede, who is a registered surveyor and an upcoming pastor. Please, can we clap for him? This book of Bible story to threaten us. Unsuccessful pastor. So do you want to join that too? Add to, okay, pastor surveyor. But that was very amazing. I like the way you carried us along. I didn't lose you at any point. I followed you and it was very interesting. I was happy to see you on stage and we listened to you and it was very clear. So one more time, can we celebrate Surveyor David Elegbede? Thank you. Before we go for lunch, final presentation, I'm looking for how to appeal to this man to keep to 10 minutes because he's a professor. Even his fellow professors say, ha! Okay, you see? That's how we felt when you were talking. Even him said, ha! He's a professor, not just a professor, a very intelligent one, from one of the best universities in Africa. I'd like to, with all due respect, invite a professor from the University of Lagos. Help me invite Professor Ademola Omojola. Please, can we put our hands together for him as he spends 10 minutes by the grace of God.
All right. Where's the opener? Let's try it. Okay. Good afternoon, everyone. First of all, I don't think there's much protocol to really observe, but I can but appreciate the presence of my president, GeoSyn president, my brother there, Professor Olaleye, and colleague, the MD of Sambus. First of all, I want to say I appreciate and I appreciate you even inviting me to this forum, sorry. As maybe due to my work, I will begin from some of the memory lane. I think I started using Esri products in 1989 when it was on the Sun Microsystems. And the same year it was ported on the PC. And to Sambus, I think I knew Sambus in 1992 when they first came to Nigeria. And ever since, I've been a user of Esri products, and Sambus have been supporting my professional career by donations and by a lot of support. So thank you, everyone. And ladies and gentlemen, esteemed colleagues, because we are all colleagues here. We've come here to learn and to interact and to network. And again, I must say I'm very happy to see us not from within Association of Geography, geospatial thing, but from an external, maybe software based, because when we are doing it locally, people don't really appreciate. But when you see people doing it internationally, coming down here to do it, now they are not stupid by doing it out there. So we know we are in good space. Thank you very much. So I will be talking on nothing more than on geospatial technologies for environmental monitoring and climate actions. So in essence, how is geospatial technology revolutionizing our ability to understand, monitor, and protect our planet? That is what I want to be talking about. There are so many things to talk about in this technology, but I'll be concerning myself with the environmental monitoring aspect and how it's supporting climate action. So my scope of presentation will dwell on geospatial technologies. What is it all about? I know we are all professionals here, but we need to remind ourselves what the technology is all about. Contemporary environmental challenges, environmental monitoring examples, deforestation, land use, disaster management, water resources, and air quality. Then climate action support. What is it that is supporting in climate action itself? And then challenges and future directions, and then my conclusions. So let's start first of all. What is geospatial technology, or what are they? It's a suite of tools for collection and storage, analysis, visualization, and that is tied to specific location on the Earth's surface. Mind you, we are here because of one thing, because of space, geography. And every position on the Earth's surface is unique. And because of this, that uniqueness is what makes it. Before you come in here today, you must have made some GIS analysis in your brain. Am I going to take Ojota? Am I going to take where? Some routes might be longer, some might be shorter by time, some might be, all those things you must have done in your mind. But we don't really look at it from that viewpoint. And because the real world is complex, you need something to help you to lay this real world out, in front of yourself so that you can do the analysis. And that is exactly what geospatial technology is doing. But the cocktail of what makes up the geospatial tools are basically three. Remote sensing. You talk about satellites, manned area systems or vehicles, the aircraft, and then you talk about geographic information system itself, which is the core, and software for mapping, analyzing spatial data patterns, model trends, create predictive maps, and turning them into actionable intelligence. And then the global navigation satellite systems, which is the GNSS, the GPS, the GLONASS, the Galileo, the Baidu. I think you know all this. I would just want to be fast. You know that the global satellite navigation system is what makes up of the GPS, which people know normally. But there are different countries with different satellite systems, like the GPS, the American GPS, which is the commonest, the Russian GLONASS, the Galileo of the Europeans, the Baidu of the Chinese, the RNSS of the Indians, and the QZSS of the Japanese. So there are tons of them now in orbit. And many of the systems you carry to do GNSS can communicate with at least 3 of these systems to fix your exact location on the Earth surface. So what are the contemporary environmental challenges? But before I even move further, I don't want to be like I just talk about remote sensing just like that. I think we are all aware that it's the art and science of getting information about a particular environment without getting in touch with that particular environment. And like I said, from different satellites, we all know the satellites in orbit, both commercial, most of them are commercial, and some are like freewheel, like the Landsat system, the, you know, the modern commercial one like the Planet, the microsatellites. A lot of countries are launching their own. You know, we all have our own tool here, although these days we can't download from our own satellite systems. But don't not to worry, you can always get different satellite systems. You know about a lot of people are parading the drones there. They are filling the informational gap within the GIS domain. But one thing I just want to say is that we keep complaining about no information, no information. A lot of information is out there. Or data is out there. It depends on what you want to get out of it. Have we interpreted even the data sets we have, the images to extract what we need from them? We've not done enough. So a lot is out there. And GIS, I don't want to say that I told you I've been a loyalist of Esri since 1989. So that means something is happening there. So there are tons, but if you want to protect, I do consultancy services, maybe I should just say it. If you want to consult, I don't want to give them something that cannot, that cannot stand the test of time, and it's not repeatable. And that's where Esri comes to the fore. So again, contemporary environmental challenges. What are those environmental challenges we have in the modern day that needs monitoring, that needs to be, tackled? We have the generalized climate change, although sometimes I laugh. Some people can even compare what is happening in their family to climate change. Climate has been changing for years. The only thing is that it's on an accelerated pace now that is anthropologically driven, that is not natural. And that is why it's becoming so critical. And we have extremes of events. Things are happening more than they used to happen, or amplification of events. So we have melting of the ice cap, sea level rise, extreme weather events, biodiversity loss, habitat destruction, flora and fauna, biodiversity loss, and species extinction. You have deforestation at an alarming rate, maybe for even logging purposes and even for fuel, for driving fuel and for a lot of activities. And you have pollution, degraded air and water quality, the urban heat island, natural disasters, increasing frequency, in intensity, flooding, droughts here and there, land degradation. So there are tons, there are legion. And why? Because the stock for human beings is like dwindling. When all these things are being depleted, they're getting depleted. So it's a lot of crisis on our hand. And we need to do something. But this tool, these geospatial tools, is at the core of really finding solutions to them. It's like you want to go to the market, you don't know how much is in your pocket. What are we even talking about being depleted? Inventory is the key thing that GIS is helping us to manage. You can even do the inventory if you don't have a way of quantifying them. If some of you will still look at the initial ways by which when GIS was formed, in the days when Jack Dengerman and some of them and people like Roger Tomlinson, they were charged with wanting to even quantify the forest resources in Canada. And they did mapping, the country is about 10 times the size of Nigeria. They couldn't quantify, so they want to compute. Maps have been used for years. Our evolution from the normal basic maps, which are just papers. But you could not give intelligence something to it. You can't query. If you want to query, how we used to do in secondary schools in those days, when we want to compute the distance between one town and the other, we have to just use the tape and something like that. And so GIS has been really helping. So in deforestation, for instance, it's been used extensively. We did a lot of studies at the University of Lagos. We have a very active research group at the University of Lagos. And many of these areas I'll be talking about, if you do some Google search, you'll be able to see a lot of publications that the team in Unilag have done in some of those things. I don't want to really talk too much about them. In fact, I think land use mapping is what I did my PhD on. And we started this project in 1985 in the Sokoto-Rima River Basin. It was the first land use after the Fomeku one that was done in 1976. We did the first major one using satellite. In fact, the first satellite imagery being used for land use mapping in Nigeria, we did at the University of Lagos using Landsat MSS and Landsat, and Spot, Landsat thematic mapper then, and MSS, and then we use Spot image and to do change detection in those days. So it's been a long time. So land use mapping is no big deal. And an average scholar from the geography department from University of Lagos will know how to do land use map very well. Disaster management, we've been, a lot of things. So let me just talk about deforestation, for instance. We have global to local examples, satellite imaging analysis over time to detect forest loss. And if you still have a lot of global, I've forgotten the site now, there's a US site where you can download all those things and do the chronology of changes into the forest system anywhere in the world for different years. Results are mostly used to support foreign regulation enforcement, carbon credit markets, biodiversity protection. There's a global forest watch which uses the technology to provide free actionable data to government and NGOs holding the foresters accountable. Several local examples, like I said, we did that at the university. And maybe, I'm not sure whether you've seen the Fomeku report on the vegetation and land use map of Nigeria. From 1977, we did the 1970, in fact, the first radar satellite used in the country was done by Fomeku in 1976, based on the Joint Overseas Navigational Map at 1 in 250,000 scale, 100 maps covering the entire country. Then after that, we did the 1986 and 1990, early 1990s. So this thing has been operational, but unfortunately, how many people have seen many of these data sets? And that will take us back to what we talk about data. The data sets are available, but people don't really use them or they don't really have access to them. And we always keep this data to our chest, forgetting that it's the taxpayers' money, which you have to add value. Disaster management. In disaster management, you need to look at the three things that, or some of the basic things that you use GIS data for is in disaster, pre-disaster, in preparedness, creating flood risk map, identify vulnerable areas. I'm not sure there's any area here, unless the person from Renaissance that was showing us something they do about their flood risk map. But even the urban areas where the flood mapping, where the flood risk is out there, people don't do it. And even the informational content for providing this thing is not there. And the thing is that why I want to challenge this community is that it's like we're not tasking, many of us are not marketing well to let the policymakers know the importance of what we're doing. Because some of these people, many of the decisions people take out there, they are spontaneous and political. They don't care about informational content driving the decision-making process. You just come out and make the decision. Oh, the Oga wants this, Oga wants that. Are you informing the Oga very well that these things can be better informed by using this technology? So we still need to do that marketing very well. But I've been practicing GIS for years. I'm still not very encouraged in this country because we are just too, too peripheral about all these things. So that's why I'm challenging this gathering, that you should go out there, because sometimes when you see some things that you can make decisions or you can help support decision and it's happening before you, you're like helpless. And we shouldn't be helpless. So And during disaster, in response, when we are responding to disaster, sometimes it's even shoddy. God forbid any bad thing. If there's a disaster around Lekki axis, is there any exit strategy? No. Because it's like a boxed-in area. And many people are doing a lot of things in many parts of the world. But, you know, we are too like a diaspora about some of these things. Flooding, delineated inundations, and post-disaster, in recovery. What are we doing? So this technology has been helping out. And it's not much. Basic maps will do many of the things we do. And in water resources, water quality monitoring, algal blooms, sediment runoff, oil spills, water quantity measurement. You know, we know what algal blooms indicates in the water body. That means the biochemical oxygen demand will be deprived. And it's not good for fit for human beings. So there are so many things that you can do. Watershed management, modeling runoff, and managing land use, for instance. Air quality, greenhouse gases, pollution tracking. There are a lot of satellites for doing some of these things, which you can, in public domain, which you can really, you know, work with. Monitoring the greenhouse gas emissions, identify and quantify methane leaks and oil facilities. When there's an oil leak, even in Nigeria, some people see it around the world, even where we don't know, because they have satellites for doing all this methane gas in the air. But are we using them locally? If there's an oil spill, we don't even know. Sometimes, some people see them. So that brings me to the climate action. The climate action we are talking about is that there are two-pronged approach to climate action, and it's about mitigation and adaptation. The mitigation aspect is reducing the emission. It's just about reducing the emission, monitoring, the emission monitoring satellite. There is troponomy, instrument satellite for pinpointing these areas, renewable energy, GIS for optimal placement of solar wind. Many of us don't even know that, although in this part of the world, because we are very close to the equator, the sun angle is not so different. In some other parts, the sun angle can be so varied that you need to set up where you alignment of your solar panel, or else you won't catch enough, energy. Because you could see that in some areas, there are some mountains that even in summer, you still have the permanently frozen surfaces because they are shielded because of the slope angle. So those things are not really very important in this part of the world. Then in carbon sequestration, remote sensing and GIS modeling above ground biomass in the forest, estimate carbon stocks, monitoring effectiveness of reforestation. We've done a lot of studies in this area in Nigeria. There are a lot of things we did in the southwestern part at the geography department. A lot of active things. So if you search and Google the environmental use that are local examples, you see a lot there. And then the key area of climate action is in adaptation. That is how to live with the existing amplification and climate change that we are talking about. Planning adaptation strategies. Adaptation is always at the local level. People talk about adaptation. How do you adapt when you don't even know what is on the local level? I challenge anybody here. There's no local government chairman in Nigeria that can tell me that he has this number of rateable properties in his domain. None. The cadastral map, in fact, the Surveyor General confessed there, since our so-called colonial masters left, or the last cadastral map that was produced in Nigeria was in 1972. And we are not even trying to do much. Many states claim that they are doing GIS. Sometimes I laugh. We are doing GIS, yes. But we still need a lot of data. We still need to go back, drill down. There are a lot of data framework, but we are not following them. And that's why we keep saying there's no data. So, I don't know. I think there's somebody from NASDAQ here. I think I'm calling, it's high time we go back. Because if the federal government, the Office of Surveyor General is dealing with the framework data set, that is the base map, that should be able to coordinate the thematic data aspect.
So the thematic data aspect of the country is very, very deficient for now. So, and that is why we are complaining about lack of data, lack of data, lack of data. If we tidy up that end, you see that we have a lot of data that are just disjointed and fragmented. So, you need GIS and all these technologies for climate resilience, agri, coastal management. In coastal management, at least there's some works we did about even Lagos vulnerability and risk assessment with Columbia University. So there are a lot of things and a lot of uses, but we are not using them for our own, and they are not trickling down into the decision-making process. That's the worst part of it. A lot of you are doing so many things too. They will never trickle down because possibly they just think you are doing them for, like somebody said, fanciful something yesterday. So it's a shame. But the technology is, you can't do any efficient modern management without this technology. And then planning support for infrastructure, climate proving, where roads need to be constructed with special materials. These are things you can sit down in your office and create scenarios for and move forward. Then in disaster management. So what are the challenges, even with this technology? The challenge is there's a kind of data overload. Somebody was saying it yesterday. There are some data sets that you cannot, they're too big. In fact, these days the computers are so smart enough and so powerful, but they still need some things. I could recollect when we started this satellite imagery processing as far back as 1985. When I was doing my research, I used to carry tons of, for a scene of, it's a Lancer thematic scene. I used to carry 16mm tapes, about 4 or 5, for a scene. Whereas your computer, your phone now can take the entire African something. So, but the data gap, the data overhead is still there. So today you need to talk to some special servers or work on some special servers to do a lot of other things. But we may be wondering, why are we getting, when you use your Google Map, for instance, you might be thinking, why are we getting this information? It's not that anybody is doing anything, it's just leveraging on big data. As you are with your phone, the transponders on your phone communicate with the base stations. The base stations are vested all over the world. They don't put you there. So it's the way you move along the route that is showing how you are, whether the road is busy or not busy. It's not that anybody is doing anything. It's just big data. And these are supercomputers crunching figures and doing everything in real time. Access and cost. You know, in this part of the world, the great challenge is the access and cost. To buy a small computer is like it's like war. Who wants to even buy satellite imagery, high resolution satellite imagery these days with the rate of the naira? We can't. So, and even the software itself. So that's why we are pleading with Sambus to really have these African-centric costs for us so that a lot of people can have access. A lot of other things, technical expertise. I'm very glad that the modern generation, the younger ones are having these, they are techie, they're savvy, you know, they're very good these days, but they still need some mentoring because it's like power without control. A lot of them can crunch the numbers and everything. So they need tutelage, they need to be mentored so that they can think very much spatially. Because I have found that what is missing is that with all these technologies, people are not still thinking spatially. So you still need to think spatially to really leverage on this technology very well. And then the data resolution. We can't cope with many of these things because the revisit time of some satellite images, is the data I want to use appropriate for what I want to do? You don't want to be generating a 1 in 1,000 scale using satellite data. Many of them cannot cope. So all those things you have to manage, and it's by you leveraging and knowing exactly what to do. So those are the basic challenges, but they are not challenges that you cannot really conquer easily. They are challenges that can be depending on whether you are focused or you intentional. So future directions. I've been hearing so much about AI, AI. Yeah, AI. But it will interest you that even GIS itself was one of the first adopters of AI. In anywhere, in any software. I've been using image classifiers that are object-based for years. And these are artificial intelligence based on expert knowledge and based on pattern recognition, all these neural nets. So it's nothing new to this. In fact, the placement of your test on your maps is driven by AI for years. So they are adopters. All these things is just like we are following the masses to talk about these days, the ML and everything. But GIS has been using AI since inception. So democratization of geospatial data, cloud computing. You can see what the ArcGIS online is doing to the, many of us we've been mapping for years. It's just in our closet. And a lot of people, these data sets are not shareable. But these days, with your portal, with everything, the data sets are, can reach everywhere. The visibility is there, the accessibility is there. So it's good enough. So sensor proliferation, new public and private satellites are out there. Like I said, we have our own. There's lots of nations. In fact, the planet has over hundreds of microsatellites in orbit, taking pictures of different places around the world. So it's all there. It's for us to just use some of these things. In conclusion, geospatial technologies are no longer ordinary observational tools, but foundation pillars for achieving an unbiased, transparent, accountable, and detailed view of our changing planet. They are indispensable for monitoring environmental change, managing disasters, and tracking progress on climate goals. Again, they turn raw data into actionable intelligence for policymakers, scientists, and communities. By leveraging these tools, we can make more informed decisions to build a sustainable and resilient future. Thank you so much. And that's my submission.
Thank you very much, sir. I must confess that this is the first professor I've seen that kept to his time. Can you clap for him? And this is the first time I'm also lying to you in this program. Okay. I want to take our time to sincerely and specially appreciate everyone that come on this platform to come and talk. It's been you delivering from your wealth of knowledge. We do not take it for granted. We sincerely and genuinely appreciate you. For every speaker, both the one that spoke yesterday and the wonderful ones that have spoken today, I think we should clap for them. Can we do that together? So we're going to go for lunch. And when we come back, as I said, 3 things will happen. And then we'll be done for today. But let me just drop 2 quick announcements. First, I'd like to humbly request to all our partners that your lunch may be a little faster because we need you in meeting room 1. That's a boardroom 1 that's just by, the ushers will direct you. All our partners. I'm going to try to run through that list. Try your best to make your lunch a little faster because we need you in boardroom 1 for very important conversations. I'm going to try to quickly mention our partners. MySats, can we wave? MySats. Oh, they are not here. MySats, absent. Okay? Anadata. Okay, present, thank you. Tech Bridge, did I get that? Yeah, Tech Bridge. Did I get that name? Or they are absent? Okay. OAS Technology. Yes, okay, thank you. Icon Geo. Okay, thank you. Starfix Geo Solution Services. Thank you. Yes, I see you. GIS. Okay, yeah. So that same hall you're coming from. Yes. That boardroom you're coming from. That's where you're going back to after breakfast, after your lunch. GIS Consult Limited. Absent. Oh, thank you. Geospatial research. Okay. Geometer. Absent. Okay. Support services. Okay, thank you. GIS transport. GIS transport. Okay, so every name I've mentioned, I'm sure Angela has a plan for you all. Please, we'll direct you, meet any of us, Angela or the hostesses, to show you boardroom 1. I will recommend that, okay, let me do it this way. Everyone I caught their name now, please can you stand? All our partners, please can you stand? Please. I add them please to it. Please, can you stand? Thank you. They're still not standing. How do I say stand so that they will stand? What is stand in, where are you from? What's stand in Yoruba? Ekujometer. Huh? What's it? Jide, yes, please. What's that? So you know it, just stand. Exactly what you are saying, just do it. Okay, I had more numbers than this now. Okay, let me be sure that I don't have partners that are sponsors. Okay. Yeah, please. Can we follow? Let's go for lunch. These people that are outstanding. Angela, can you wave, please? Yeah. Please, everyone that's standing, all our partners, we need you to grab your lunch because we need you in another 10, 15 minutes. We need you. The rest of people will need them in 20 minutes, but we need you in 10 minutes. Yes, thank you. You're part of them, yeah. Everybody I mentioned. Now, I want to take our time to appreciate our sponsors. So, Tremble, we appreciate. Can we clap for them? Can we clap for them? Yeah. MySats, we appreciate you. Thank you very much. Sacridion, we appreciate you. Thank you very much. 9 Post is also our sponsor. We appreciate you. I don't know why you're not clapping for our sponsors. I still don't know why you're not clapping for them. Just a minute. Okay, well, I apologize. My half money, I apologize. I think what happened was that I skipped it when I couldn't get the pronunciation. I didn't want to murder your name. Sorry, ma. So half money, our partner too. Let's wait for her so I should not be angry with me again. Help me to clap for her. This can affect my balance. She went to go and meet who is paying me. Madam, you want to report me straight to my balance. Small balance while they wait for end of today. You should help me now. Clap for her again. Half money, ma, are we okay now? You are forgiving me. They can pay me. Okay, that's fine. Thank you. Okay, so I have said a big shout out, salute, respect to all our sponsors. Thank you very much, all our sponsors. MySat, Nipos, Sacridon, Tribo. Can we clap for all our sponsors? Let's do that. Let's do that. Come on. Thank you very much. Yeah, when we are coming back for lunch, please, our media team, we're going to put sponsors' logo on screen. I'm going to properly appreciate them. We'll share a few things about them when we come back after the lunch. Now, it's time for lunch. The first 4 rows. First 4 rows. Please, can we use this down? The first 4 rows. First row. Who is moderating that for me? Hostesses. Yes, first 4 rows. Because of the nature of the space, this lunch is VIP lunch. Then when you come back, I think I advise that we come back quickly. After lunch is the bottom pots. We're coming for the last lap. It's going to be very amazing. Let's use 25 minutes and let's come back. First 4 rows first. Hey, officer is not in 4 rows and they stood up. Oh. Nigerian Army, you're not in 4 rows. And I cannot now say, I'm afraid of your uniform. First 4 rows. Nigerian Army is in 7th row. They stood up. Is it fair? And I cannot complain. Who am I? I'm a bloody civilian. But he's my friend. Major, sir. Major, sir. It was just a joke. Oh. Let me not go and do frog jump I didn't plan for. Okay, first 4 rows. We are going to use the elevator. The first 4 rows. Then, already outstanding. I cannot now say my mind. But, Major sir, do you know it's a joke? Like, I didn't mean to say anything. So that this is what they are laughing now. I mean, let me not go and cry outside. Major, let's shake hands so they know we have settled. I come in peace. I'm not any terrorist. Okay. Yes. Now, Major, help me to move them quickly. Can we, Major, let's go so I can move the next people. MD, man. I'm just reminding you, man. So I can move the next set. Okay, which group is this? Okay, which group is this? Okay, there are two groups. Prof, sir. Prof, sir. Prof, this door, sir. This door, yes. No, sir, you. Yes, sir. Thank you. Sir, you, this door. So that we are using two different elevators so that that one doesn't get choked. Okay, you want to use here? You want to give me information? Okay, sorry, sir. Okay, now, you're raising your hand. Okay. Madam, you're not hungry. For you to gossip this serious gossip, you're not hungry. Two of you were gossiping seriously. You were thanking God that I apologized to the soldier. That's not what you were saying. No, I heard you. You're gossiping. You were telling her, that man. She said, which man? Okay, I'm the man. Okay. I'm waiting for your instruction. Hostesses, they have left the WhatsApp group. What if, for example, they say the lunch is not finished? Are we in the first 4 rows? 1, 2, 3, 4. Sir, first 4 row. You wanted to wait? Me, I said you should wait. I said first 4 row. 1, 2, 3, 4. How do I say 4 in French? No, sir, we're using this door. Yes. Okay, now, 1, 2. Okay, no, we're not counting the couch. I heard what you said. I'm hearing everything in this hall. I should hold on. 4 minutes. Sorry, excuse me. My apologies. We're using an elevator. If we go there, we'll just be standing. Those people that went. You want to catch up with somebody? Sir, the Eba will not finish. Can we just wait? Okay. It's not food, okay. No, he said it's not food. I believe him. My mouth. That's the only way I can feed my family, with my mouth. We're waiting for them. Meanwhile, yeah, I think I'm doing a good job. People should clap for me now. Am I not trying? You don't even like me. You have issues with me. Oh, yeah. We're going to become friends now. Follow me on Instagram. You're not on Instagram, you're on Facebook. Facebook is for old people. I thought you're young. You're not on Instagram, true. I don't believe you. What are you on? You're on what? You're on X. Okay, it's the English you didn't hear. Instagram is a social media app. Okay, on Twitter. Okay. Follow me, I'm still there. Yes, of course. Chooks the General. I'll follow you back now, of course. How will I remember you that you're the one that don't like me? CHUKS-D, like D for domestic. General. CHUKS. Then D, like normal D. D for domestic. Yes, then general. Should I spell general? Okay. Of course. You didn't follow me? You seen it? Yes, that's me. Jokes the general. Follow me. I'll follow you back. What's your name on Twitter? Follow you back. Don't trust me. If it's a normal country where everybody is okay, this Instagram, this is my handle I just got now. People would have followed me, but they don't like me in this place. Okay, are you on Instagram too? You are, yes. You followed, you saw it. You saw me. People that wear suit are my friends. Okay, are we set? 4 minutes. Okay. 4 minutes. That is 60 seconds times. You have a question? Yes, ask me. Is it about GIS? Okay. I said what? I said CHUKS. D. I'm D. For dog, for domestic. My own D is not for dog. Who is this man? How did you register in this conference? You want to be sure what my D is for? I saw the word dog, I skipped it. Yes, before it was D for dog until I saw you and I changed to domestic. I left dog for you. 2 human beings or 2 rows? Rows. Okay, so she said 2 rows. Elevator is ready. 2 rows. are set to begin. Please, those outside, please come inside. Please. Please. Needed seat method. There's no seat for anybody. Okay. Let me first of all say a very good afternoon to you all, our very special delegates, distinguished ladies and gentlemen. We're back from lunch. I'm sure we had a good meal. Can we all say yes? I'm sure we had a good meal. Thank you. Yeah, it was good. It was good. We're set to begin the final session for this year's conference. I'd like us to just pop the energy up a little bit and drive through these three set of things we're going to do now. So first is users presentation and lightning talks. And I have two people that will do that. The first will be from University of Ibadan, and second will be Spatial and Data Science Society of Nigeria. So I want to be sure that we are back here. I need the energy, I need the vibe. So the first person to come to the microphone, delegates, ladies and gentlemen, please can we put our hands together for Temitope Wahib. Please can we clap, can we clap, can we clap? Wow, they didn't clap. Maybe that's why they're not coming. From the University of Ibadan. Where's Temitope? Okay, I should skip that. Okay, I'd like to now invite from Spatial and Data Science Society of Nigeria, Adedoyin Samuel. Adedoyin Samuel. Is he your own Samuel? Okay. Okay, so our first one will be from Spatial Data Science Society of Nigeria. Ladies and gentlemen, I present to you Adedoyin Samuel. Can we do that? Come on.
Good afternoon, everyone. My name is Ajeyomi Adedoyin Samuel from Spatial and Data Science Society of Nigeria. I will be presenting a body of work titled Spatial-temporal Analysis and Forecasting of Population Growth Hotspot in Nigeria using the World Pop data. Okay, I will just continue. This paper is actually a body of work that we worked on at SDSSN. And sorry, let them just attend to this. Is it from me? All right. The background to the study. Nigeria is the most populated black nation in the world with a projected population of 340 million by year 2050. That's by the United Nations. And as we all know, population is a spatial component. Every resource planning, every sector actually depends on population data because as a nation, our population makes us a nation. Without the people, there's nothing called a nation. And the population is a spatial data, which means when you want to actually plan resource allocation and every other thing, development, even agriculture, population is a very critical thing that you have to consider, because the people you are planning for actually determine what you need to do and where you need to place it. So when you are doing site stability analysis or any other analysis, population is a very, very important data. But here is the twist. The last time Nigeria did a population census was in the year 2006, which means we don't have accurate data and accurate information about the distribution of people. We don't really even know the exact people that are in Lagos State. All what we've been using is estimate. And thanks to the United Nations and to some lab at South-13 and a lot of other geospatial scientists working together, they've been developing some frameworks to actually help estimate population for all these countries that do not actually know their population. But the issue is that all these estimates, are we even using them in resource allocation? Are we using them in development? Are we really using them when it comes to planning? So our research is actually to take this data. Recently, the UN actually released the estimate from 2015 to 2030. If you go to HDS, Humanitarian Data Exchange, you can find the data there. So they are even break down into sex and other parameters. So we decided to actually analyze this data set using the ArcGIS Pro software. And then as you can see, the aim of this study is actually to see the changes that was estimated. So they've actually done this estimation from 2015 to 2030, but we want to actually extend it, analyze it, and see what changes they are really seeing. And we also want to try to also predict for future to see what the population will be by then. And all this is being done within the ArcGIS Pro environment. So we are going to examine the current growth trend that they predict from 2015 to 2030. Let's see what's really happening. Let's see what they are saying. Let's see what's going to happen in Nigeria in the next 15 years. I think 2030 is, okay, 5 years from now. Let's see the trend they've been seeing in the past. Let's see what's going to happen in the future. So we are going to apply some statistical method within ArcGIS Pro. We are going to also forecast, and we are going to actually compare all this stuff. This is our methodology. As you can see, the data source from the World Pop, like I said. And our process is to collect the data. I already talked about the data source from the HDS. We actually pre-process this data. We have different layers of population data sets. So we combine them together, convert them to a net CDF file so that we can do a time series analysis and also understand emerging hotspots, which is something I'm going to talk about in the result. We also did population forecasting. So the first thing we have to do using the spatial autocorrelation tool within the spatial statistics tool in ArcGIS Pro is to be able to get some figures, because you need to understand the clustering distribution of this population before you can actually apply the emerging hotspot tool. So we did that, and we also tried to actually find outlier. While we are trying to understand this trend, we understand that there will be presence of outlier in all these changes. So, and we then did forecasting. So I'll be taking us to the result. So this is the result section. As you can see, according to this result, the data actually showed, according to the UN estimate, that by the year 2030, Nigeria is going to be 240 million plus, and as at year 2015, Nigeria is said to be around 190 million. And then some of the driver for this growth is high fertility, improved child survival, and the rural to urban migration, because people are actually leaving the villages to go to the town to get, to actually improve their way of living. Then you can see the chart to show the trend. You can see a linear trend that our population will continue increasing. And this has to come to the question is, where are they increasing? How are they increasing? And what is causing this increase? Because remember, as a nation, you need to plan. And you are planning for people, which means you need to understand the trend in this growth so as to be able to plan efficiently. So as you can see, this is the beauty of the spatial temporal tool in ArcGIS Pro. it gives you that map that is very, very easy for you to interpret based on the legend that it automatically generated. When you look at those places with thick red, they are new hotspots. That means is that this place, they don't used to have a lot of population before, but as time goes on, people have started migrating to these places. Their population have started increasing. When you look at the other one, you see the intensified hotspot. You see that those places, they are hotspot before, but currently now, there has been a sudden increase. And when you look at the map, you will see that when it comes to south-south and southwest, a lot of people are actually migrating from the north towards this region. As you can see that those regions actually have, like in Borno and around Taraba, you can see a new coast spot. Those places, people are living there. People are actually leaving those upper parts here. And as you can see now, in the southern part, the key insight shows that in the southern part of our country, there is urban consolidation and growth. People are moving down. Why in the northern part is being depopulated? People are actually living there to come to this lower part. And some of the reasons that can cause it are insecurity, displacement, and poor facility. So one of the analyses we can also do is to actually know the outlier. Because within an hotspot, there are actually cold spots too, which means a place might actually be a cold spot where a lot of people have been living, but there might be a different ward that is actually maybe safer or is actually having a lot of things better than the other. So this actually shows us that from 2007 to 2018, we can see that there is a lot of displacement in Nigeria. So one of the things that this data is helping us to see is to go back to our history and see how are these things happening in this area. So when you look at the population trend in Nigeria, it shows that we have unequal urban growth. There is sparsity in the rural area. So this is actually affecting our planning and resources. And you see that there has been a consistent growth. There has been a consistent issue of urban sprawl, where a lot of small urban areas are actually coming out, which is actually very bad because the major issue that is causing this are insecurity and lack of resources in those places. So we also take our analysis forward and try to actually do prediction, which we can do within the ArcGIS Pro. So we use the linear model within the ArcGIS Pro to actually predict what our population will be by year 2035. And by year 2025, it shows that Nigeria will be over 270 million with a net increase of 18.6 million within the 5 years. And we also test the accuracy of our model since our growth actually has a linear pattern. So it was easy to actually use a linear model to actually predict that. As you can see, our forecast actually shows that Lagos, Ogun, Oyo, FCT, and some part of Southeast and South-South are going to continue to grow in the next following year. Their population will continue increasing. While in the Northeast and Northwest, there will be a lot of slower growth and depopulation over time. So the implication of this now is on policy and planning, because this is showing you that housing, transportation, and healthcare in all this area that are actually experiencing all this growth, they need to increase. You need to increase services to the people. It talks about inequality, and we all know what inequality can cause, because some part of the country will continue to struggle at this rate if resources are not well planned and allocated to this area, because people are leaving their region to come to where they feel is safe, to come to where they feel has a better economic. So my findings and conclusion after everything is that Nigeria is expected to rising rapidly and steady, projected to exceed 277 million by year 2035. And we've also found out that Lagos, Ogun, and some part of South and FCT will continue growing. While Borno, Yobe, and Adamawa, there's going to be a lot of depopulation there due to poor services. And as you can see, the pressure of all this is going to be on housing, transport, and the resources in all these places. So the key message here is that Nigeria growth is fast, but it is uneven. It is not growing across the whole nation. Some parts are growing, some parts are reducing. So as you can see now with GIS now, we are able to analyze this and to visualize this. So these are one of the ways you can apply GIS and data science in predicting and estimation population growth. Our analysis is actually based on world level because a lot of analyses are mostly done on LGA level, but the resources should be taken down to the world level so that everything can be spread across equally. So to actually end my slide, I'm from the Spatial Data Science Society of Nigeria, and it's actually a community of people who are trying to learn together, train together, and be better at GIS. And I would also like to recommend those books for anybody who is interested in spatial statistics. You can download the ArcGIS Pro 3.5 and then actually follow these two books, and you can pick one or two things from there. So I'm going to end my presentation here. Thank you, everyone.
Thank you very much. We're moving very quickly, and I like that. Can we now get University of Ibadan? I'd like to invite Temitokbe Wahib. Please, can we look for a good place in our hearts and clap for Temitokbe Wahib? Okay, one is Temitokbe, the other one is Wahib. Who is Temitokbe Wahib? You. Okay, this is your best man. Okay, that's fine.
The Esri management, the Sambus complaint, we said, all protocols duly and well observed. Amolalo Philippe Oguntoyinbo with Temitokbe Wahib representing University of Ibadan. We are master student, third semester. Thank you. And we say that the usefulness of Esri products can never be undermined when it comes to research. So we're working on a pattern of air pollutant and land surface temperature in Nigeria using space-time pattern mining techniques, which is an updated technique in research. Background to the study. All right. As you all know, Nigeria is facing critical environmental challenges due to urbanization these days and high increasing rates in industry. And this has actually exacerbated air pollutant in Nigeria today, and this calls for research and for us to provide decision making in the society as well. So, and this leading to increased air pollution and high land surface temperature in urban area. So, background to the study, we also examine traditional ground-based monitoring system are very scarce. So which there is need for a satellite base to have a kind of a large coverage. Next, please. All right. The aim and the objective. The study is to examine the spatial-temporal dynamics of major atmospheric pollutants, which is NO2, SO2, CO2, and the ozone. So these are actually increasing based on the industrial evolution and expansion as well. So the objective is to analyze trend and time series clustering of air pollutant, the NO2, SO2, CO, and the ozone, and land surface temperature because of the conversion of the natural ecosystem into industrial activities and working as well. And detect emerging pollutants and land surface temperature hotspot for us to provide adequate measures to mitigate the land surface temperature, and also forecast LST for the year 2025 using multiple predictive models to support future planning because urbanization is rapid and it continues to increase. There is need for us to predict, and this comes with a predictive model. And these are potencies. There is no statistical or significant difference in the predictive performance measured by the ranks, and also among core fits, exponential, smooth, and random forest model for land surface temperature forecasting across all states. So the study area, the study area is Nigeria, which is the populous country in Africa, approximately 290 million. So we focus on that, and there is seasonal pollutant pattern, which is based on the season that we have, April, October, and also the dry which is in November and March. Okay. The methodology. My colleagues continue from here.
Okay, thank you. Moving forward, I'm going to speak into the methodology for this research. Table 1 gives the description of our data, the sources, and some characteristics of the data used. And the flowchart here shows the methodology that we employed for this research. Basically, 360 rasters were extracted from Google Earth Engine, and the process of masking, reprojection, the zonal statistics was automated in ArcGIS Pro using the ArcPy environment. We actually created space-time cube to perform this analysis because we realized that majorly the problem we have dealing with spatial data is to be able to capture both the spatial and temporal components, the temporal and spatial dynamics of this data. So since Esri now came up with this idea of building a space-time cube, so we adopted this model for our research. And a very close example of space-time cube is the Rubik cube that we all use to play game, whereby the horizontal arrangement of the data records the event across space, and the vertical arrangement records the event over time. We perform trend analysis, emerging hotspot analysis, and also we integrated 3 models to see how this model can best perform across different states in Nigeria, because it cannot always be a single model fits all on different states. So this chart, figure 3, shows the trend of these pollutants and LST in Nigeria. We actually observed that there is a clear seasonal variation in this data. We also use the 2 time-based dimension plot in ArcGIS Pro to actually see the intensity of this pollutant and LST. We observe that they always have their peaks during the dry season, and they take a nosedive during the rainy season. But the question remains, the trends that we are seeing here, are they statistically significant enough to inform decision making? We will find out. So we made use of the trend analysis inside the space-time cube to know if the trend observed earlier in those charts are statistically significant, using the integration of Mackinder trend statistics. We observed that NO2 and CO, they do not have any statistically significant, whether uptrend or downtrend, while SO2 has a statistically significant uptrend with 99% confidence level. And also, ozone also exhibits an uptrend of 90% confidence level. The chart over there, the figure 6, shows the percentages of these different states based on their confidence level. We also made the attempt to put all these states into clusters. We want to have the understanding of how probably we have states that actually exhibit, that demonstrate similar values across space. So we're able to achieve all of this to see that there is a clear north-south environmental gradient, and CO2 trends upward in the north, while SO2 and NO2 also trends upward in the south. Also, we use emerging hotspot analysis. Here we want to see that, okay, the hotspot that we are seeing, are these 2 currently happening? So we are not dealing with what has taken place in the past. That was why we use emerging hotspot analysis. And we discovered that emerging hotspots, we have persistent hotspots in the northern, mostly in the northern part of Nigeria, and we have the persistent cold spots in the southern part of Nigeria. We adopted core-fit model, exponential smoothing, forest-based, in order to predict for 12 months to see what the variation in the LST values is going to look like across Nigeria. The first one is the result of the core-fit model. We observed that it captures seasonal trend, but missed out on short-term anomalies. The exponential smoothing model performed better. It captures seasonal changes, but in some cases, it underestimates extreme events. But the forest-based model performed well, and it was able to model non-linear patterns and spatial anomalies very well. So this is the distribution of the RMSE value, whereby we take the error between the validation and the observed value and the predicted value, then we square it, take the mean, and root it again. The lowest RMSE value, 0.32 degrees Celsius, occurred in Akwa Ibom, while Sokoto proving to be more problematic, and the only model that best predicts in Sokoto was forest-based model. And the map there shows the distribution of the best performed models across the state. Finally, we evaluated the predicted values based on the best model we picked, and this is the final result. We also take the national average of the LST for 2019 to 2024 and compare it with the predicted value. We observe that it actually shows some kind of similar trend with the historical data that we have. So we did not just want to base our final results, our final conclusion on what we see based on the RMSE value. We want to understand that, does this model actually predict, does their accuracy significantly different from each other? So we adopted the Friedman statistics on our data, on the RMSE value. So we're able to obtain the value of 47.19 as a statistical score. That was when we realized that the model performed differently with different accuracy across space. Hence, we adopted the Nemei post-hoc test, and we visualized the results with the critical difference diagram. Normally, the critical difference distance was calculated to be 0.54. So if a model should be statistically significant from another model, then the distance between them will have to be greater than the critical distance. And as we can see here, exponential smoothing and the forest were very close to each other, so they are not statistically significantly different from each other, while the core fit is statistically significantly different from the two models. The heat map there shows the comparison between the three models. So our study was able to demonstrate the power of using space-time pattern mining techniques in uncovering complex environmental dynamics across Nigeria. We were able to review seasonal trends, geographic disparities, and persistent environmental stress zones that conventional method might have overlooked, because this pollutant and LST, we understand the way they behave across space and their dispersion mechanisms. Tools like preparedness protect environmental preparedness, protect environmental integrity, and increase environmental livability across Nigeria, because our landscape keep evolving. Thank you.
So let's see your face. Yes. Please, can we clap for them? Thank you. Thank you. Especially appreciate you, students, master students. And that was very amazing. I said this before. Multimedia can help me. I want to especially appreciate all our sponsors, Milsat Technologies, Tremble, Nipost, and Sacridion. I want to appreciate all our sponsors. I think one more time, we should clap for all our sponsors. Can we do that? Very well. We're going to spotlight our sponsors now. So, multimedia, we're going to have Milsat Technologies just on screen now. So let's want to spotlight them for about few minutes. They just come share a few thoughts with us in their capacity as our sponsors. We should appreciate them. We should listen to them. We should clap for them. We should celebrate them. I'd like to start with Milsat Technologies. Please, can we put our hands together for Milsat Technologies?
Good day, everyone. My name is Adida Malabaderewa, and I'll be presenting on behalf of Musa Technologies. Sorry. Okay. While the screen comes up. Okay. MuSat, we are building the infrastructure for Africa's most comprehensive data. I started off as a GIS person. I don't do GIS anymore because GIS hurts me. One of the first jobs I had was as a data support person, and my task every day was to clean data. And it was something I don't want to remember. If you have ever cleaned data here, you will know how data can hurt if it's not collected the right way. So for us, that has been the dream, to ensure people collect data the right way. So, yes, this is a common saying. We say data is the new oil, but which drilling? I think it's a very simplistic answer to just say everybody here is drilling because we deal with data, we have collected data. If you have not, you will probably collect one day. But the bigger question is, are you actually drilling the right way? So what's the right way? It's a way where you ensure that the end users, people that want to use the data, do not have to question or bring up that big question, who collected this data? So we are building the African geospatial infrastructure to collect, integrate, and share data. One of the things I've seen, speaking with people that don't deal with X and Y every day, is that they want to know, when you collect this data, how does it fit into what I already have? You can imagine legacy systems that have existed for 10 years, and then you say you want to collect the data, you want to pipe it into their system. We have something that has existed. We don't want to pull it down for what you are bringing in for us. So when you collect this data, how does it make sense for them? That is the most important in integration. And then sharing data, we foresee a future where everybody here can put our data into one big bucket, and anybody that just comes can just pick out of it. So this is the product. It's a suite of products that is designed to enable the end-to-end management of people and data. Those are like the two major components of data, actually, the people and the data itself, in the pre-field, the field, and the post-field stage. I see a lot of problems in the post-field stage of data cleaning, trying to establish relationships between data after it has been collected, whereas it could have been established at the time you wanted to go to the field. Pre-field planning takes a lot of time, but even the right questions that are supposed to be answered then are mostly answered in the post-field stage. So we are trying to cut that system to ensure that we do things the right way, and the right way is the only way to do things. Eliminating the pre-field headaches, profiling, you have people that you have trusted for a couple of projects. They are probably supervisors to you in code. I don't know your language, maybe project managers. Imagine a system where you onboard all of them, your data collectors, your supervisors, your validators, into a single system where everybody just sees what they have to do. If my role is to supervise 5 people, I'm only seeing to supervise 5 people. It's not a thing of, Kunle, go and do this. It's a system that tells everybody what to do. Once you onboard them into the system and assign them roles. The workforce management, one of the things that is a big problem is, how do we ensure people are at the right place? I can be in Marriott here and tell you that something is happening in Alimosho. How would you tell me it's not happening? Because I can emulate the geo coordinate and then give you a report. So we are trying to create a system where people have to do the right thing. The system forces people to do the right thing. Workforce assignment, the questionnaire design. I've seen clients say, oh, the system we use, when we want to design our questionnaire, we have adjustment, we send an email to people, they get back to us in 2 days. What if you could do that in just 5 minutes? Create your own questionnaire, logic skips. If you say yes, some questions disappear. If you say no, some questions show up. It's a simple system. And then the unique coding. After every data is collected on the field, you want to establish a uniqueness to it. If I am Adida Mola, you want me to represent 1. Professor here sitting down, probably is number 2. Why should you establish that after the field when you can easily do that on the fly? And then solving the field problem. I already mentioned geofencing. The way our system works is that it geofences you. A lot of lines divide Nigeria. We have settlements, we have localities. If you are doing some specific projects, maybe in health intervention now, you can see a settlement. Settlements are so dynamic. You want to ensure that people are in the right place, and then you want to know who collected what in the right place. So we have been able to create a system. You can see that particular picture there. Once you try to click a point that is not within your work area, your geofence area, it tells you this is not what your work area, so you can't do anything. So the system practically just forces people to do the right thing. And then data layering. For people that want to use data, it's a rare case for people to just say, come and collect Marriott, and then go home. You want to know the attribute data, how many rooms are here, is there a restaurant, is there like maybe what kind of halls are there. So that means in a particular polygon or a point, there has to be like some layers in it. Oftentimes, this is collected, somebody comes, collect the building, brings up another form, collects another, maybe the attribute. But in a way, we have created a system where you can layer all of these things, collect the building, collect the attribute, collect the people that are inside in just one single swap. So, and then real-time validation. Validation oftentimes is always a 7-day cycle. I collect data today, I send it to the HQ. Some people sit down in the 3rd day and then send it back to me. That really slows down field work. What we have been able to establish through the ArcGIS Experience Builder is to establish a near real-time validation. Why I don't put real-time is because oftentimes data collection occurs in offline areas, places with zero connectivity. So you have to wait for them to sync into cloud. But once they sync, in a minute, you are seeing this data, and then you can flag for completeness, accuracy, and anything that you want to flag for. And then offline data collection, I already mentioned a part of that. All of this happens offline because that's the biggest question. Many people that want to sponsor data collection, the donors, they want to know what is happening in the cut-out areas. Practically, many people want to know what is happening in Lagos, but the real money is in the bush, as I'll call it. And then in the post-field, so I already explained how we eliminate the headache in the pre-field phase, how we solve your problems on the field, and how we simplify. This is how we simplify in the post-field stage. And recall and deployment. At a certain extent, or let me just give a use case now. For vaccination now, if you're trying to vaccinate kids, the first thing is to identify. It's a 3-step. Identify, enumerate, and vaccinate. You have to identify the target population. Do we want to map people between the ages of 0 and 59 months? When you enumerate them, when vaccinators want to go, maybe in 3 months' time, they don't have to collect a new data. The way we have created a system is that when you get to a child, if you ask the name of the child and the child's name is Umar, all you have to just do is call Umar and the surname, or probably a unique code, and then it brings Umar's record. You had the fact that you just vaccinated Umar, and then Umar is appearing as a vaccinated record in just one single application. It's not a thing that you have to bring in paper or have to collect a new data. So you are appending it, and it's establishing a continuum in terms of how the data is collected. So I know a big question that comes up is, if you are doing all of these things in one single application, how is the base map handled? One of the things that stands out for us is the fact that the application itself is around 2 MB, and then it has base map everywhere you go. So how is this done? So we compress the data, the base map, put it in a bucket, and then stream it into the application. So the application is not holding the base map. And it's not a thing that you're only provisioning for Lagos. If I tell you the same application, if you open it in Lagos, you see your base map. If you go to Sokoto, you see your base map. It's not limited by geography and equal. And then, like I said, just upload and stream. So it's a very, very simple application. And records that you're collecting on the field, because the base map is streamed, it inherits all of the geographical attributes. So you're not collecting the geographical attributes differently. You're just doing a single click, and then you have all your data in a single click, like I said. So what I'm trying to say here today is that all of this application exists, but we have built it in a way that we don't want to eat the good things alone. Everybody here probably has data collection projects that you have done one time or the other. This application now is being deployed for you to put your color, your brand, everything you have to do, maybe your server, without having to write a single line of code. Such that you show your clients that this is the app I've built, and you can see my brand on it, you can see my color on it, without having to write a single line of code. We have solved this problem, and we want to ensure that you are not having to do the hard work we have done for the past 5 years to ensure that you get the same result that we are getting. Some of the people that have trusted us, I can see my people from the Nigerian Postal Service here, some people from the National Population Commission. This particular tool is currently being used for the census in Sierra Leone. These are the people that we have worked with, and if you don't trust me, you can speak to some of our people. Thank you.
Thank you very much. I must say that we trust you. That's why you're on board with us. And so thank you very much. We'll take our next sponsor to speak. I'd like to invite Sacridion. Please, can we put our hands together for Sacridion? Thank you. And to speak is Mr. Chika Okorocha, and he'll be speaking on behalf of his company, Sacridion.
Good afternoon, everyone. My name is Surveyor Chika Okorocha, and I'm representing Sacridion and making this presentation. So I'll be speaking on satellite-based positioning in optimizing the use of limited land resources. So Sacridion is a geospatial company, and we are involved in mapping services, engineering application, and IT solutions. So GNSS application, satellite-based positioning, can be applied in transportation, mobility, environment protection, security, timing, health, and agriculture. And in every application use case of satellite positioning, it involves an understanding of the position on the Earth's surface. And you can map what you don't know. And like we know, the Earth is a limited resources. We will not have another Earth. So everything we do is understanding where and how are we going to map what we already have. And with this understanding, we've partnered with a couple of companies in deploying geospatial solutions from GNSS receiver, just like what you're saying there. Now, this is one of our products that we support engineering companies, surveying companies in using. And that solution is what we call a global navigation satellite system, and our partner deploying that solution is Tassos GNSS. And today's world, for construction application and even surveying cases, we have solutions now that can track under vegetation cover. Previously in the past, if you're going to carry out survey, topographical survey in dense vegetation area, you will realize that the main issue is how do you track satellites under canopy? And now these solutions have the capability to track under canopy. And that's what you're seeing being demonstrated there. The man using it there is walking in a densely a forested area and is still able to walk with it because we have an extreme RTK board that has been designed to be able to track under deep vegetation cover. And that's what you have there. We went on to have receivers that can actually tilt, because when surveyors work in the field for construction purpose, there is always this need to have your rover. You're supposed to hold your rover vertically. But today, the solutions has also been designed in a way you can even tilt it up to 90 degrees, completely horizontally to the floor, and it gives the geospatial professional in construction application the ability to carry out the mapping purpose. So that's just what is being displayed there. And we go on, we now have another compact solution which we call the Tassos Luca GNSS. This is actually a palm-sized solution that can be integrated for every kind of surveying, mapping purpose, even GIS application. These tools can also be integrated with handheld devices for high level of accuracy. With this, you can work up to 1 cm accuracy in your project. So we went on the conventional process of engineering construction work, it's the requirement to have a base station, what we call a reference station, and from that reference station, you're expected to stream correction for various surveying and construction application. But today we now have what we call the TASOS advanced positioning, and this solution has been used for offshore as well as onshore application. Let's take, for instance, if you're carrying out offshore positioning, in offshore environments, there is no internet per se. There's no internet communication, and there is no access to infrastructure. So you depend on correction that will come from the sky, and these are subscription-based correction service. And that is where the TASOS advanced positioning comes into play, providing people in offshore, carrying out offshore positioning service with the right level of centimeter accuracy they can use for the application. And this is currently being used also onshore. Let's say in the land environment, you can still use this, and without looking for a reference station, you're able to have 2 cm accuracy for different applications. And that technology has been integrated in agriculture and farming, precision farming. In today's precision farming, there is always a need to have a tractor that completely plans the entire farm scope, whereby you design the farm, the farm system is designed, the layout of the farm is built into the planning software, and your tractor is going to work with respect to the precise farming lines. And that's just what is being demonstrated here, where the receivers is connected. And going on, we also have a solution for marine application, and that is the dock. The dock is an autonomous system, an unmanned surface vessel that is used for hydrographical surveying and marine application. And that's just the dock in action. And with the dock, instead of going with a vessel and a boat, you just launch a dock the same way you launch a drone, and the dock can move around the water body, carry out the bathymetry survey, and return back to the position where it has been launched, and everything about the seabed is obtained. So that's the dock in action. So if you have a water body, you just launch the dock, it goes on the environment, carry out sounding, what we call bathymetry or hydrographic survey sounding, provides all the depth information of that water body, and comes back to the man controlling it. So part of our solution is the UAV. We now have LiDAR-based drones for mapping application. And that's our team and one of our clients carrying out training for the deployment of the solution. We now have also a mobile scanner. Now, if a building would need to be redesigned, the first thing that is being done today is to acquire the data as it is. Let's say they want to redesign where we are, this auditorium. The first thing to do is to acquire this data, and what is being used is either a mobile scanner or a terrestrial scanner. And this scanner provides a point cloud of this environment, and the building information model can be built out of it. This is another one. That is a mobile. This is a 3D scanner. This is a terrestrial scanner. This also works similar with that one, but provides higher level of accuracy. And one important thing is, let me just go back. So if you look at this solution, I'm working with point cloud. The new one we have here is what we call visual positioning system. So the visual positioning system now is a situation where cameras are integrated with a GNSS receiver. So you have receivers where you just walk around and the receiver captures images as you're walking with the rover. As it captures the images, from that image, you're able to generate points, unlimited number of points. Every scene within what was captured, every scene can be converted into point cloud directly from the field, and unlimited number of points can be generated. So unlike a situation where you need to go to all those points to acquire the location, you just capture the scene And from your data logger, from the controller, you're able to generate the coordinates required. And your performance and efficiency in the field is increased. So in all this, if you're working with point cloud, you're working with large image data sets, you're working with drone data, something is very important, and that is the processing machine. You can't work with this high level of data without having a very stable workstation. And that is where our Schneider digital solution comes in. This is a stereoscopic monitor integrated with high-performing workstation. You can see that in our screen. Working with, in our stand, you can see the solution in our stand. High-performance workstation, stereoscopic monitor, where we transform terrain data to 3D models. And with the stereoscopic monitor, you can see everything in 3D, putting on the virtual reality glasses. And what are the compatible software of our solutions? Esri software is very compatible, Bentley, Trimble, Faro, and several other software. Thank you very much.
He came here to speak because they are one of our sponsors. Please, can we clap for them again, ladies and gentlemen? Okay, so we'll be taking our final sponsor presentation, sponsor spotlight, and that will be from NIPOST. I'd like to invite Ambassador Talent Kola from NIPOST. Please, can we put our hands together for NIPOST Ambassador Talent Kola? Who is the... Okay, that's the chief bridesmaid. Okay. Thank you, sir. MC.
Okay, good evening, everyone. My name is Ambassador Dr. Taliat Kola Talent. I'm the Special Assistant to the Postmaster General of the Federation. And I'd like to stand on the existing protocol. We are very happy to be here, and I hope that by next year, when I hope Aqua will be organizing another one next year. So when we come here next year, we'll be able to tell you our own story. We'll be part of the panel where we'll share what we're about to do for Nigeria. NIPOS is the desk office for Nigeria in charge of national postcode and addressing. We have the National Addressing Council that is chaired by the Vice President. I was happy to see Professor Mojola, but he has left. He was part of this project many years ago. But now that we are actually going to be working with Sambus, Esri and the partners, we trust Milsat. Milsat was there, so we trust them. Let me let you know that. We know Milsat, we know Jamita, and we are going to be working with Sambus and Esri. We are going to start implementing the national postcode before the end of this year, and hopefully by next year, Nigeria will have its postcode so that you can give your postcode to anybody so they can find your address like you have in every other developed nations. And I also use this opportunity to mention to you that NIPOS is still in the business of mail movement. We have our EMS and speed post that is extremely fast, and I can tell you that even DHL use NIPOS to go to the interland and all. And I'd like to also let you know that we have something called the Universal Service Obligations. That's why you can still post a letter from Maiduguri to Lagos for 250 naira, because we belong to the Universal Postal Union that allows everyone to be able to send mail from one point to the other, regardless of your class. So we still do that. And then we have the Epos Express, which we send mail within 6 hours. It's the fastest of our product, especially to Lagos, Abuja, Kano, and Port Harcourt. We have that product you can get from us. We have what we just launched recently, our financial services, where you can do your banking transaction in the post. You can go and do your banking because we have the super agency license. We have the IMTO license, International Money Transfer license, and then we are the only one that have the UPU corridor, like post to post, where you can send money to other countries and they can send money to you from about 192 countries. So you can patronize us and all that. NIPOS is also in charge of Korea and logistics licenses. So we license the likes of DHL, FedEx, UPS, and all these small and medium enterprises, businesses. All the logistic guys you see on the road, the bikes, they are licensed by NIPOS, to empower the young business to grow. So we do that, and then we have also what we call the stamping protocol. That's the one that first we had a very big issue with the FRS like 2-3 years back. The one you popularly known as stamp duties, because in 6 months we generated about 61 billion. So FRS had to come to fight us, and then they overpowered us, and they took it over from us. But that was stamped. Now we have what we call the stamping protocol. We are promoting the culture of stamp. Like I'm an ambassador of the African Union, where people like Prof will tell you that in the Western world, do you know that even coins are still recognized? You still use your coins in New York, you use your coins in the UK, but you don't use coins, especially in Africa. We don't keep our cultures, we don't keep things. Our stamp, we don't talk about it. Go everywhere, they still keep all those things. Even with all the technology, they still keep all those things. So we must promote what we have. So we still continue to promote what we have. Now we also have the electronic stamps. We have the electronic stamps for electronic transactions. And we have other things. You can visit our stands. They will let you know. And if there's anything that you need to know. But NIPOS is still moving Nigeria forward. Thank you for organizing this. Love you guys. MC, you're a wonderful guy. You have collected your balance.
Thank you very much, sir. Yes, you can video that. This is what I want to say. They will send my balance to me through NIPOS. I think we should put our hands down for NIPOS one more time. I know I've said this before. I don't want to be tired of saying it. I want you not to be tired too of hearing it. Let's especially appreciate one more time all our sponsors. Milsat Technologies, can we clap for them? Sacridion, please can we clap for them? Thank you very much. Tremble, and then NIPOS. Can we together clap for all of them? Yes. Milsat, yeah? Yes, please come forward. You'll be sponsor. Sacridion, please. This seat, so they will not. So, yes. So I can sponsor next year too. Thank you. All right. We are going to switch gears now as we begin to plan to descend this flight. We're going to take another set of user presentations, but this time around, you will love it. We're taking 3 sets. One is from Cooperative Information Network, Ayorinde Kapo. Please, they are waiting for you at the media for you to give them your presentation. Is Mr. Ayorinde here? Oh, yes. Media is waiting for you. Thank you, sir. Dr. Ayorinde. Okay, put it title so I will know. Dr. Ayorinde, I'll correct that. TechBridge Limited, James Edebo, you here, sir? Mr. James, please can you come closer? Thank you. And Lagos State University, Michael Fasong is here. Mr. Michael. Oh, Michelle. Oh, Mrs. Michelle. My apologies, ma. Okay, Mrs. Michelle Fasong. Okay, thank you. Yes, so we are set for it. Each of them will drive about 7 to 8 minutes on the presentation, which will be user presentation, their experiences using Esri and everything they've been going through. So they'll share that with us very quickly. So I'd like to start with Lagos State University. Let me welcome Michelle Fasong. Please, can we put our hands together? I'm happy when ladies are coming to present. Can we clap for her, please? Okay. It matters, please. Let me just correct that. I needed to ask her. So this is Dr. Michelle Fasong. She's PhD. She's a PhD holder. Please, can we clap for her? Some of you don't have BSc. Can you clap for PhD holder? Thank you. Media.
Okay. Good day, everyone. My name is Michelle Fashono from Lagos State University. And our study is connecting habitats, modeling landscape connectivity for large mammals in Omoshasha, Ulua Forest Reserve, Southwest Nigeria. It's important to note that this study was done in collaboration or association with the Omoshasha Ulua Forest Reserves Initiative. And that includes Nigerian Conservation Foundation, Ogun State Government, Ondo State Government, and then Osun State Government. Okay, I think I've named all of them. And in collaboration also with Pengtong Zoo. All right. Okay, so the Omoshasha Oluwa Forest Reserves is a vital forest block in southwest Nigeria. But human activities have now fragmented this once continuous forest. And due to that, animals are not able to move from one habitat patch to the next. When we were doing this study, somebody was saying, "Shebi bush na bush. Bush no be bush." Just like how we have our own preferences, animals too have their own preferences. We have a lot of forested areas within Nigeria, but they're being affected by the empty forest syndrome, meaning that there's forest, there's bush, like how the guy said it, but there are no wildlife inside. All the wildlife are gone. So, this study, we modeled the connectivity within the Omo-Shasha Oluwa Forest Reserves, and to show areas that can be reconnected. And like when I'm talking about reconnection, I mean corridors can be placed in between forest patches so that animals can move from one forest patch to the next. All right, so this is the Omo-Shasha Oluwa Forest Reserves. It's at the boundary of Ogun, Osun, and Ondo State. So these are the forest reserves within there. So first thing we did was that, okay, we have animals within that forest reserves. Where are they located? So the first thing we did our species presence, absence survey, where here, okay, the species is present, here the species is absent. Then the next thing we did was using ArcGIS, we generated our layers. So we looked at nearness to water, nearness to settlement, DEM, the land use cover, and the rest like that. And we fed it into our landscape connectivity model using Circuscape. Then the next thing we did was that looking at the habitat suitability, where are those areas that are connected? Where are those areas that we have corridors? So we used our generated suitable habitats for each species because we're dealing with large mammals. And then along with our land use layer, we now fed it into the landscape connectivity using Circuscape, and then we now presented the maps using ArcGIS. So at the beginning, we didn't know which species we're dealing with. We knew that we just wanted to deal with large mammals. So all we did that after we did our survey, we found out that we had 12 species. So these are the species that we had using, some of them were captured using camera traps. All right, so where are the suitable habitats? So when we ran our model, we found out that across the 3 forest reserves, we had suitable habitats. The animal with the largest extent of suitable habitats was the civet cat with 1,760 square kilometer. But the forest elephant had the least with 729 square kilometers. So you can imagine, for a large animal like that, within the forest reserves, its habitat is already gone. All right, so our potential connectivity we're able to generate for like 7 species. So the other species, there were not enough data because some of them could only find them in one forest reserve. Some of them, just only once. Like, for example, the chimpanzee, we could only find it in one location, and that was only once. But for those species that we could generate potential habitats, just like the bushbuck, the civet cat, you can see that there's some kind of potential corridors that can be generated for them. Another one is the Maxwell Diker. You can see in the diagram, the first diagram there, that's for the forest elephant. You can see that this animal has lost its habitat totally. There's no connectivity between the habitat patches for it. Others were the Mona monkey. Another animal of concern was the red cat mangabe. That's the second map there. You can see that connectivity is almost non-existent. And the last one was the red river hog. So we have some patches of connectivity within the forest reserve. There's one reoccurring thing. We found out that connectivity moved from this northern part of Omo Shasha Forest Reserve down to the southern part of the Shasha Reserve, down to the Omo Shasha Reserve. So with this now, the management within the Omo Shasha Ulua Reserves Initiative can see areas where can be reconnected, areas that we can create corridors for these animals so that they can move from one forest patch to the next. So this study, we're able to address a knowledge gap because at the time when this study was carried out, nobody knew where the resources are supposed to be put in place so that they can maybe reforest those areas so that those animals can move from one habitat patch to the next. So we're able to identify those areas and using large mammals as a keystone species so that if it can work for large mammals, it might also work for other animals within the forest reserves. And also, this study helped provide evidence and for land use and policy decisions within the study area. So, the take-home message is simple. Connecting habitats is conservation in motion. If we don't connect our habitats, if we don't have corridors where species can move from one place to the other for new resources, for maybe to mate and other things, we'll find out that our wildlife will no longer be there. And I want to acknowledge those who did the study with us. And thank you. If you have any questions, you can email me at michelle.fashioner@lasso.edu.nigeria. And thank you.
Thank you very much, Doctor. We appreciate you. I'd like to now invite very quickly James Edebo for the next presentation. Ladies and gentlemen, please can we put our hands together for James Edebo.
Yup. Thank you, everyone. It's a pleasure to be here. And I think when I first heard about this conference, I was really excited. The reason is this. 5 years ago, I asked myself a question. And the question was, when can we have a user conference? So I learned it happened last year. Unfortunately, I wasn't online enough to be present. And this year, I told myself I have to be here. And it's a pleasure being here to share in this very special program. I want to congratulate Sambus for putting this together because I believe this is just the starting point. And Greater User Conference is coming, okay? So thank you for giving me the privilege to share this with everyone that has been using ArcGIS. Basically, when you talk about Esri products, I will start this presentation by saying something. Permit me, of course, to stand on the existing protocol. Our guests and distinguished personnel, I greet you all. So I want to start by saying we have been using ArcGIS starting from the days of what now? Not ArcMap. ArcView. Thank you, Dr. Shika. The days of ArcView. Then we have ArcMap, and then today we are dealing with ArcGIS Pro. And I always say that Esri is an ecosystem that is big enough to accommodate everyone. Okay? But there's a question I always ask. And the question is, many of us use ArcGIS Pro, for instance. That is what I'm going to show you. It's basically on ArcGIS Pro. But this extends to every other component within the Esri ecosystem. But we are very relaxed with the tools we can see within ArcGIS Pro or within Web Builder or within the enterprise solutions. We have not bothered to ask, how can we extend this tool to solve local problems, okay? And that is what this is all about. And from the title, you can already see it. We can do beyond the default tools that are in ArcGIS Pro. We can do beyond the default tools that are in Web App Builder. We have Experience Builder, you can extend it, but today, let me just talk about ArcGIS Pro. Maybe another time we'll talk more, okay? So in ArcGIS Pro, for instance, we can extend ArcGIS Pro, and it makes our life easier. And then we'll be able to achieve even much more, okay? So let me just do a quick test. How many of us, permit me to do this, have used ArcGIS Pro? If you have used ArcGIS Pro, almost everyone. How many of us have custom application using ArcGIS Pro SDK? ArcGIS Pro SDK. How many of us have it? Have used that? Nobody. This is the reason for this presentation. You can extend ArcGIS Pro to do more for you. The reason is you'll be able to solve local problem. Why automation in ArcGIS Pro? I'll just run through it briefly and share with you what was done so you can see it. You'll be able to solve local problems. I give you an instance. The Surveyor General for the Federal Republic of Nigeria yesterday mentioned something. They have drone data, images, and they wanted to run through an AI model to extract features like roads and all of that. Of course, they ran it through maybe the already existing AI models in ArcGIS. It didn't give much result. We did a project a few years ago. We had drone data. We trained a model specially to extract faults in electricity distribution line. This can be very useful for Ikeja Electric. Now, the question is, why don't we train our own model? That other project we did for electricity distribution line, we used less than 500 drone images. And I'm sure they had more than that for the use case he mentioned yesterday. We can train our own model and call it up in ArcGIS Pro and use it. You are going to see that in this presentation. Okay? So, when we want to solve real problem, business problem that drive the needed innovation, that drives the needed impact that we can sell to people to value what we call GIS, then we must be able to develop custom application. And Esri, in their own wisdom, has provided a platform for us to extend Pro. But the question is, how many of us use it? Many are not into it, and I understand why. It can be a topic of discussion another time. I just want to show you that these things are possible. That is the answer to the first part. Why automation in ArcGIS Pro? Second, why artificial intelligence in ArcGIS? Please, I'm running because of my time. Why artificial intelligence in ArcGIS Pro? You see, recently, we have Esri India. I know many of you have been seeing what they are doing. And the AI Research Institute for Esri is there. Why? AI is everywhere today. Why can't we utilize it in ArcGIS? I saw a lot of dashboards yesterday. If you want to query that dashboard, it's either you go through a query layer and then maybe you throw a SQL query, or you select layer, select. We are talking about NLG, natural language, language models, where people can interact using prompt. Just say what you want, and you get the answer. Why can't we do that in ArcGIS Pro? We can do it. Everybody say we can do it. Yes, we can do it. So all we need to do is to do what? We don't even need to develop from scratch our own models. No. There are several LLMs. We can integrate them. That is the power that Esri has given us by providing ArcGIS Pro SDK. It goes beyond model builder. It goes beyond ArcPy. It goes beyond all of those, okay? So AI is the business of today. We can bring it in. The use case I want to share with you was part of the problem the Surveyor General mentioned yesterday. In 2018, I was opportune, of course, to lead a team on the Lagos GIS project that many of you know about. And the first assignment I had was to build the enterprise database. And what we did, we deployed our men to the State Surveyor General's office, and we had to collect all the survey plans. We had millions of records, and we have to begin to digitize one after the other to capture the records. After 2 weeks into that project, I knew it's something that's going to be messy. We spent over 2 years to get it, to try to, even with that effort, there were still random errors. So I knew we have to come to a point where we can automate extraction of data from survey plans. For those that know what survey plans are, okay? And if you don't know it, I think you are going to see it very quickly. So I started working on this idea ever since then. And ever since then, I started working on this idea. And of course, it gained momentum early this year, late last year, early this year, when we had various AI models, from Google, from OpenAI, and the rest of them. So what did we do? That's what I want to show you. We trained a document AI model on GCP. Sharing this, why? Because my aim is, at the end of this project, we should be able to do much more, okay? We trained a document model, Google Document AI. We trained a special one using survey plans so it can interpret survey plan. Then we incorporated it we called the model up in ArcGIS Pro and placed a UI in ArcGIS Pro to be able to interact with the model. And then we have a database management system on Superbase. Superbase is Postgres, PostGIS Online, okay? To manage the user session and populate all the attributes that will be on the survey plan. Some of you may not easily appreciate this, but you are going to see it. So this is just a high-level diagram of what was done. I want us to do a demo of this so that you can see the application in action, okay? I want to play this. Please, I need your help. So, the demo will show us the application. And then, this, I want to play the. So let's see what was done so that you see the application itself. Yeah. No internet. So it's trying to connect the internet. So with this, the bottom line is we are able to extract automatically all of the details you can find on a survey plan and load it directly in a database. So you can easily interact with it in ArcGIS Pro. So we develop a custom form that interacts with all the data that has been generated from the survey plan. So what normally takes 5 to 15 minutes to digitize, manually, using maybe the conventional tools we have in ArcGIS Pro, was brought down to less than 1 minute. How many percent efficiency save is that? That is over 80%. Over 80% save in efficiency. And so with that, when you have millions of records, it shouldn't take years anymore. And if you have random errors associated with manual digitizing, with this, you are talking about what? Systematic errors that you can easily eliminate. Okay? So that is it. The integration points again. AI model. Python scripts for pre and post processing. Then we brought everything into ArcGIS Pro. So if I do not show you that these scripts exist in the back end, you will think everything is happening just within ArcGIS Pro. Okay? You will see everything happening within ArcGIS Pro. But then that is not the case. There are several back ends powering and talking to different APIs. So, well, I think there is internet issue, and unfortunately, you are not able to see the demo. That is not very good for us because I really wanted us to see it. Everything I've said without you seeing it, it doesn't make sense to many people. It's okay. So if you're interested in seeing this later, please, you can check the Sambus booth and then we'll play it for you to see. So for me to round up, I will just round up by saying that we have been able to reduce this manual process by 80%, and this can happen to every other part or every other thing that require manual processes and can be automated. And then we're able to also show just in a way that we can adopt various AI models to solve many problems right in ArcGIS Pro, okay? Using the ArcGIS Pro SDK. So if today, before you came here, you have not bothered to have even one member of your team with ArcGIS Pro SDK skill, ability to customize it and use it, please think about it. It's going to be great to have such person being able to do these things, and you will see direct value, okay? Thank you for giving me this opportunity.
Thank you very much, sir. I especially appreciate you. So we just try to move. I'd like to invite from Corporate Information Network, Dr. Ayorinde Kapo. Please, can we put our hands together for Dr. Ayorinde? What happened? Why are we not clapping for Doctor? Sir, the people here don't like you. One more time for Dr. Ayorinde Kapo. Can we do, yes.
Distinguished ladies and gentlemen, good afternoon. Please permit me to stand on the existing protocol. I want to specially thank Sambus for organizing this program, and I also want to thank Sambus for offering my organization a package, an academic package which enabled us for all our multidisciplinary facilities to have ArcGIS Pro license. But I also want to let Sambus know that I'm representing not just Cooperative Information Network here. In fact, most people don't know is that Cooperative Information Network is a sub-center of National Space Research and Development Agency. So I would like if you'll be able to give us that kind of access that you have given us, you can extend it to our parent agency so that all the scientific officers in NASA, technical officers will also be able to benefit from this package. Just to add to what Prof was saying the other time, he said something about data that we don't have data. I want to correct that impression. In 2003, we launched NigerSat-1, and during the lifespan of the satellite, we were able to give over 18 universities free satellite image, about 3,000 free satellite images. And as we launched it, our activity centers, the NCRS, happened to be the training centers in which many of the professors then learned the rudiments of remote sensing and GIS. So I just want to clarify that. So without wasting further ado, I'll be presenting a project which we carried out, which is partial assessment and accessibility of cold chain equipment, cold chain distribution of vaccines in Gogolada Area Council. So my name is Dr. Kapwa Yorinde, Cooperative Information Network, like I said, from NASA. So poor vaccine and delivery system is one of the major problems in the immunization supply chain. Because over the years, we have been able to, if you look at the trend of immunization, we have over the years been able to assess how the vaccines are brought. And you know the vaccines, most of them are live organisms, and so they need ambient temperature. So over the years, they've standardized the process which the manufacturer brings them, takes it to the airport systems and what have you. But the major challenge now is how to get it to the end user. Now, the vaccine system works in Nigeria in a simple way, such that once it comes to the airport, it goes to what we call the National Cold Store. And the National Cold Store is in Abuja there. Very close to the National Cold Store, you have the Federal Capital Cold Store. So from National Cold Store, it is sent to all the state cold store. So for the one for Abuja, which is of interest to our topic today, it is a state cold store, and it's in very close proximity to it. Now, from the state cold store, from the FCT cold store, it is now sent to the 6 area councils that make up the Federal Capital Territory, which is Abuja Municipal. But the one of interest is the one of Gogolada, which I'll be talking about. So this study simply looked at tried to provide a spatial context to the immunization supply chain. And the basic objective was to determine the spatial distribution of the healthcare facilities and the cold store and assess their accessibility. So in carrying out this study, we used the primary data that was collected on the field. Actually, this study was of a larger scale because it involved the whole of Abuja as a whole. But for the purpose of visualization, for us to properly understand our results in better context, I decided to take it down to the subnational level, which is the area councils. So we used the healthcare facilities and the local cold store. Now, as you have in the states where you have the state cold store, once they get to the state cold store, they go to the local cold store. So it is from local cold store that these vaccines are distributed to the various healthcare facilities where they are used for immunization campaign. So we used the healthcare facility and local cold stores. We took the road network data, we processed it. We also looked at the elevation because, you know, Abuja has a lot of hill and rocky places. So we used all that to determine how the places are distributed. And for the analysis, we used the spatial analysis. And for the first time, we also used spatial statistics. One thing I like about Esri, 2 things actually, is the map composition. As has a very good map composition, though I must say QGIS has stepped up the race. So I will employ Esri to raise their stakes up. But the major thing which they have is the spatial statistics. And that is one thing you can never see in any other GIS software. Other ones will just give you the mean center. But the descriptive statistics which you are all used to in school, in our research work, is actually embedded in Esri. and you have what you call the main center, the median center, the central feature, what you call the standard distance, what you call the standard distribution. And before you go to the spatial statistics neighborhood there. So this is a flowchart which the process was carried out. So for our results, we're able to identify 24 healthcare facilities and 1 local cold store in Gwagalada local government, Gwagalada area council. Now, 7 of the healthcare facilities had functional cold chain equipment. What we simply mean by functional cold chain equipment are refrigeration equipment whereby vaccines can be stored for a longer period. So we had 18 of them had no functional chain equipment. And what that means is that once the vaccines are brought to them, if they are not utilized that day, then their lifespan is gone. And this has serious health implications for vaccination campaign. Now, in our statistics, which we did, so what we did there was we looked at the statistics there. You can see the green there. Now that green is called the main center. The green center works in this way. It takes the distribution of all the facilities you are looking at and picks the closest point using an Euclidean distance, and that gives you the mean center. We also have what you call the median center, and then you have what you call the central feature. Now the main and median center fall within a geographical space. And when they fall within a geographical space, they don't fall directly on any healthcare facility. But you have what you call the main central feature. This is the main healthcare facility, and it falls directly on the main healthcare facility, which is Anagada here. And the implication for the Anagada there is that this place can be upgraded to a secondary or tertiary healthcare facility. And in cases of crisis, just like we had in COVID, this place can serve as a very good supply chain or a command store for them, because it means that you have so many healthcare facilities that can be reached within this period. Now, for the standard distance, which we know as our standard distance, standard deviation from the mean, here we have that here we call standard distance, and it's about 11 kilometers in the buffer there. Then we now have what you call the directional distribution. It's a sort of pattern, but it's different from your normal clustering pattern. It shows the direction in which the healthcare facilities are structured. And for this particular project, you can see that the healthcares are coming from the northeast down to the southwest. So in running our neighborhood analysis, we discovered that the pattern of healthcare there is random. So what that means is that they are neither clustered nor dispersed. And that's also an indication of our distribution of our data. It shows that we are getting something closer to what you call a binomial distribution. Because the rule is that the closer your main is to your main center and your central feature, the closer you are to getting a binomial distribution. So you can see that reflected there. So we now did a flow pattern, and that we use the network analysis tool in ArcGIS for. And we're able to look at the distance that it takes from the local cold store itself to all the healthcare facilities within the Gwagalada area council. And so you can see that the closest one having different rankings from the first to the first. Now, we now also looked at the pattern further, looking at it from the cold store now to the healthcare facilities, looking at the better distance at 30 meters, 30 minutes, how many healthcare facilities will be able to cover within 30 minutes. So for the first one, we got about 18 here. And now in the other one, we can only get about 10 healthcare facilities that can be reached within 10 minutes. Now this has implication because only the local cold store has mobility. So that means that once the healthcare facilities have exhausted their vaccines, they cannot access another one until the local cold store brings the bike, which is the only mobility. And the local cold store is serving over 24 healthcare facilities. So you can imagine the logistics and the time it will take for it to move from one healthcare facility before it covers all the healthcare facilities. Because how immunization works in the healthcare facilities is that a particular day is set for all the women who need antenatal care to come for their vaccination. And so all of them come at that day, and that is the day in which the local cold store will distribute very early to all the healthcare facilities for them to reach. So we now carry an analysis which you call the service coverage area. Now, the difference from this one with your normal buffer is that while your normal buffer just gives you a physical distribution of what is available, which will give maybe like a 5 kilometer or 2 kilometer buffer. But in reality, it assumes that you can just walk straight from the radius, from the center to the place with equal distance. But in reality, it doesn't work that way because you have natural encumbrances, such as rivers, you can have roads, you can have rocks. And so this one now looked at the road network, how long it will actually take, and it was divided into three classes. Those who could be reached within 3 minutes are in the green classes there, and those who could be reached within 5 minutes are the red classes, and those who could reach within 7 minutes are in the blue classes there. Now, these are applications on the health because the standard for the WHO is that you should reach an healthcare facility within 2 kilometers. And so when they carry out NGO campaigns, immunization campaigns, the first thing is to look at all those settlements that can be reached within 2 kilometers. And so for those ones, the immunization campaign is usually carried out at the healthcare facility. Now, for those outside it now, they have what you call the outreach. And that's the one you see them going from house to house to capture. And then you now have the one that is furthermore. And those ones, they require what you call a mobile site. So that means that they cannot go back to the same healthcare facility to restock, to capture the people there. So looking at the another health primary facility, I've already said is the primary can be upgraded to secondary healthcare facilities. The flow pattern flows from 0.3 minutes to 42.6 minutes, and we'll have over 56% of the healthcare facilities can be reached within a 30 minutes thing. So looking at the service area, we can see a lot of spatial disparity in the healthcare gaps. So in conclusion, GIS gives us an efficient planning and logistics for vaccination requires a key to strengthening for logistics and health system. Geomapping with GIS of available facilities and also characterize them, not only their service or their ability, but also on the functionality of their equipment will help improve the immunization supply chain in Nigeria. Thank you very much.
Thank you very much, sir. The only difference between the last year event and this year's one is that last year we're clapping more than this year. I don't know why we're not clapping this year. Please, can we put our hands together for Doctor? Okay. We're going to do a very quick session. As I said, we're landing, so we'll be appreciating our speakers. But I'd like to quickly invite Chidebere, Marketing Officer, Sambus Geospatial Abuja office, to quickly help us explain the first award we'll be giving, how our young scholars fared, and how they are getting this first award. After that, I'll come back for another set of awards, and that is us landing gradually. So for those who went outside to do as if they went to eat themselves, whereas they went to remove sleep, can they come back? We are already landing gradually. Help us tell them. Thank you. Then we also have an issue with the media team complaining that we should try and sit together. So those behind the camera, please, can we come forward? The videos are not coming out well because the seats are empty. So please, the people behind the camera, hostesses, please help us. The people behind the camera, can they come like before the camera? Please. Thank you very much. While landing, and these awards, we need your clap, your smile, your face, your responses, so we can have them on camera. Thank you.
Thank you so much. I would like to stand on existing protocol. I recognize distinguished ladies and gentlemen. Thank you so much for this opportunity. So we are here to recognize a few individuals who have done so well, young people like you and I, who have excelled in the geospatial space over the past year. And the first person we would like to recognize is Akintola Messi, Akintola Messi, who is the YSA winner for Nigeria. Yes.
We'd like to invite the MD to help us do this very special presentation. This young man coming up is the winner. I think the clap should be a little better for the winner.
Yes.
Okay, these are his friends who just became his friends because he won award. As of last year, they were not his friends. Just make sure you succeed. That's the moral lesson. Thank you. He's shaking his new friends.
All right, so I also want us to recognize the guys from Ghana, David, Desu, and Monica. These guys also won it from the country Ghana, and please, a round of applause for them. Yes. So the YSA is an international award organized annually for undergraduate and graduate students. So if you have an innovative, interesting project, applications are usually open towards the end of the year, and you see them on all our social media platforms, and you can as well submit your applications and follow the processes, and hopefully you'll be standing on stage next year as well. So put your hands together once more for them. And the next set of individuals I would like to invite here are the Map for Impact winners. Yes, we have 3 teams who did very well in our annual hackathon called Map for Impact. These guys, they applied from all over the country. We got applications from Ajayi Crowther University, FUTA, University of Lagos, Lagos State University, and all around the country. And annually it's organized, and some 2-3 teams did really, really well this year. And I would like to invite them on stage. Yeah, so we have 3 teams. Team Spatial Syntax, Omolola Adeyemi, please can you step forward? We also have the Falcon team, Abayomi Glory Ainde and Olushola Favor Joy. And then the team Geonexus, Ogunbemi Ezekiel Tobilo Pa and Fatoki Akinjide Lawrence. Please, if anyone is here, I would like you to step forward. And yes, please. So these are the Map for Impact winners this year. It was really a tough decision. We had quality entries, and after some deliberations, these 3 are our awardee winners. But you know, in every competition, there has to be just one winner. So I'll be proud to announce that the winner is...
Okay, so before, let MD just take a picture with all of them. Let them assume they are the winner.
Oh, okay.
We will now announce the real winner. Let them just have hope small. Can we come to the middle with hope? Can we clap for them first at this point? No, my guy, just come here. Ah, okay. Because of his height, I was just thinking. Okay, so sir, the winner.
So we are all set for the winner, right?
Yeah, yes.
The winner is?
Yes.
The Falcon team. Yeah. Put your hands together for them. It's quite unfortunate that they are not here present because they are writing their exams.
Okay,
yes.
Sorry, bros. These people, when we no come.
They no come.
Okay.
Yeah, they are writing the exam.
Okay, they're writing the exam. Yes. Okay, so these ones, can we clap for them as if they won?
As if they can.
Okay, thank you very much. Thank you, thank you. Thank you very much. Thank you. Sorry, Chidebere, the phone, is it? I should keep it? Okay. Just to be sure that you're not dashing me. All right. I'd like you one more time to clap for them. Can we do that? Can we do that? Very amazing. I would like to, at this point, kindly request for our managing director. I will be doing a few presentations to appreciate people. We'll do it in different categories. Yes, thank you, Ma. I'd like to also invite Regional Manager, Mr. Karinsa, to also join this presentation. This is that time in the program where you have to clap as it's coming to the stage. We start with our sponsors. And tell them that we're giving them awards. So, Lords Field Limited, Geospatial Research, Otic Survey. Okay, they're all at the boats. Okay, so which one are you, sir? Otic, yes. Yes, we'll swap it, sir. Okay, so I'd like us to put our hands together for Otic Survey. Please, can we clap for them deliberately, please? Thank you very much. Then we'll now let's take a joint picture. So, no, sir, while you're still holding that, let's take a joint picture. Yes. Yes. Anyone here? Geospatial research? Still at the booth? Lordsfield Limited? Lordsfield? Okay. I will now go to our speakers. So just help us do 2 more before you march the parade. I know you're going somewhere. We'll go to our speakers. Yes. I'd like to invite one of our speakers. It was very impactful to us all. It's time to appreciate Mr. Emmanuel Avula. Please, can we put our hands together for Mr. Emmanuel Avula? I enjoyed him while he was speaking. Please, can the clap be a little louder for him? Let's do that. Okay. I'd like to invite, this one came all the way from Ghana. We should give him a very loud clap. I'd like to specially invite Engineer Donald Appiah. Please, can we clap for him? Can his fellow engineers, can we come with him? Why are we not doing it? Yeah, let's come. Please come. Let's do that so that when people succeed, their friends will now, you understand? Yes. Mr. Donald, Engineer Donald Appiah. The 4 of them are all engineers. And they are all equally intelligent. And they came to be a part of this conference. But Donald Appiah did a presentation, and we're appreciating him. And in my opinion, their clap should be 4 times louder. Can we do that? Let me specially invite Surveyor Olayinka Dukbe Nilola, PhD. Yes. Surveyor Olayinka. That presentation, sir. I know you have to go. Yes. So I'll find out original surveyor. Okay, he too is a surveyor. Oh, okay, that's fine. Please, can we clap for him? Thank you very much, General, sir. We are new friends. Welcome, Temi Tokbe. I'd like to also invite Surveyor Vincent Adewebi. Surveyor Vincent. Surveyor Vincent. Vincent Adewebi, registered surveyor. You here? Representing. You here? Representing. Okay, yes. He's you said I should call surveyor. Okay, thank you. No, we'll take a picture together. Yes, wait. Yeah. Okay, so 2 different awards. SSR, Special Advisor for Surveyor Vincent Adewebi, and Surveyor David Elegbede. He'll be picking for the 2 of them. So we can also bring the second one for Surveyor David Elegbede. So we'll take the first picture. This picture, you will send it to Surveyor Vincent. Are we done? We swap the award now. And you take another one again for David. Yes, hold that one. You take another one for David. I will ask you for a favor, sir. Please help us make sure the award gets to them in one piece. And we'll be very grateful. Please, can we clap for him? Let's join now and take this picture. Oh, you should hold the 2. Okay. The gentleman photographer said he should hold the 2 so we can have evidence that we gave him the 2. Okay, just hold the 2. Just hold the 2. Yeah, but they want a picture of two. Just, yeah. Yeah, evidence. Yes, that's it. I'd like to invite Habib Adeyemi Yusuf to come and receive the next award. Another speaker that imparted knowledge. Habib Adeyemi Yusuf. Please. Habib, okay? Absent. Ben Oyebe, another of our speaker. Ben is also absent. Uncle Ben is here. Oh, okay. I'd like to invite, ladies and gentlemen, please can we put our hands together for Uncle Pastor Ben. Yeah, I enjoyed his sessions very well. Thank you, sir, one more time. And at the back, during the break, he became my friend. I'm his new mentee. Thank you very much, sir. I especially appreciate you. So we'll take that presentation. Yes, and he came with his compound people. Okay, so man, we'll just take the group picture. It's very important. Compound people, can we? I'd like to invite Juliet for the next to come and receive the next award. Juliet Ikbere Amaka. Yes, I'd like to invite Juliet Ikbere Amaka. I love that name. Prayer is so good. Thank you very much. Okay. Tori Seju Omasheyi. Shori Sheju. Tori Sheju. Okay, so special advisor, thank you very much, sir. We appreciate you. You can have your seat. Please, can we clap for special advisor? Thank you very much. So, MD, the two of you, yes, will help me finish. So we'll start with MD. I will send your invoice to me. I will approve it. But I won't help my help out. Okay. So you said you is not around? Okay, so I should continue. Surveyor. Oh, okay. Busayo here too. Busayo is also absent. Busayo is not here. Muiwa. Can we have another speaker? Mr. Muiwa. Mr. Muiwa Dele, are you here around? He should be. Okay, not here. Professor Ademola Omojula. Where's Prof? Yes, please can we put our hands down for Prof? Ladies and gentlemen. Yes, our Prof from Ekiti State got his PhD in 1992. Yes, that's what he said. 4 years after I was born. I don't know why you did that to me, but that's fine. So Professor Ademola also got his PhD in about 1997 or so. Yeah, but he has done his master's in the 80s. So these people are really learned people, and their wealth of knowledge is something we should respect and salute. So one more time for Professor Ademola. Please can we put our hands together? Thank you very much, Prof. Thank you. Thank you very much. We especially appreciate you, Prof. Thank you very much. I'd like to invite Babatunde Oluwashola for the next presentation. Babatunde Oluwashola around. Babatunde Oluwashola. Okay. Dr. Akinola Adesoji Komolafe. Yes, doctor is here. I like the way the claps came. Thank you. Please, can we do that for him one more time? Now, I'm about to stress you all. Let me apologize to Prof first. Prof, sorry. Prof, don't pack it. Everyone who got an award, can we come with the award? Let's take a group picture. A group picture. Just the recipients, the speakers, people who are holding the plaque. So all the flower boys, chief bridesmaids, don't come with them. Just the ones holding the plaque. Thank you. We'll take a group picture together. Thank you, Prof, for coming out. I apologize for that back and forth. Yes, thank you. We'll take a group picture, sir. We're taking a group picture. Everyone holding the plaque. Yes, with this one too, yes. Everyone, our sponsors, our speakers, where are we? Let's take a group picture together. If you took a word on behalf of somebody, you can come out too. Special advisor will also join in the picture, sir. Night post. Yes. Thank you very much, sir. No, hold on. No, my night post is not here. No, one night. Okay. Two night posts. Okay. It's not really your award like that, but you can join. Remove the carton. Yes. Okay, you know what we'll do? Please, engineer, can you can we go that way so this thing will not block, the podium will not block anyone? Yes. Engineer, sir, travel a little bit downward. Yes. A little bit again, so I don't want the podium to block anyone's face. Thank you. That's very perfect. You can now close up the rank. Very perfect. The gentleman on the camera will take the pictures very properly. This is a time where we clap for them. Can we do that together? I don't know how much energy you have. They deserve a standing ovation. I will send it. Let's clap for them. Can we do that, ladies and gentlemen? Let's do that. Thank you very much. Thank you. Thank you. Thank you very much. Sir, you may have to wait behind with me a little bit. You just stay with me a little bit. MD can go. It's now time for closing keynotes. Envisioning tomorrow. It's time for closing keynotes. The path forward for geospatial in West Africa. Ladies and gentlemen, our special delegates, I don't know how much energy you have, but please, can you put your hands together all the way from Dubai, Regional Manager, West and North Africa. Can they clap a little louder for Mr. Karim Assem? Come on.
Thank you so much. I didn't know that I have a closing remark to do, so I don't have a presentation. Definitely, it was a real pleasure to have you around. And thank you for being present. Thank you for being with us. Looking forward for next year. So for you to be around, for you to be always representing as partners to us. Partners in the journey itself. So happy to have you around. Hopefully we can we meet next year or even before next year. So feel free to reach out. Feel free to, if you require any support, you require any queries, we're here to help you. So thank you so much. Hopefully we can I can see you very soon. Thank you. Where's your... I'm good. I didn't have anything. I'm good. I'm good. Next year. Huh? Next conference is Sambus. Okay.
So to round up this session, we just want to slightly announce that next year, 2026, we'll be having the Esri UC Conference West Africa in Ghana, Accra, and that will be on the 15th to 16th of September next year. So we hope that everyone here who has enjoyed the conference, I'm sure you did, would be present in Ghana. So if you've been needing any support, visa requirements, if need be, I know for Nigerians, we don't need, Ghana is like our home. So we are humbly inviting you to come to the conference next year. make connections, share experiences, meet old friends. I'm sure we must have had good friends. I know our MCA has been talking about how everybody is his friend. So I do hope that we all come together again like this next year in Ghana. We hope to see you there. Do have a lovely, lovely evening.
Okay, so before we leave the hall, two things. I'd like us to create a content. So we're all going to take a group picture, everyone here. If MD and Mr. Karim can step forward, we'll all just come. Let's try to make this content. It's my final request. After now, I'll see you all in Ghana. She said we should all try and come. Me. Sorry, ma. MD, can you forward a little bit? Everyone is joining this picture and this video. We're going to do a content together. Some can climb up. The people that are not too tall, we know ourselves. Let's be in front. The ones that are tall should just come. There's still a line we can form at the back. There's a line we can form at the back. How do I explain this? There's still a queue at the back, yes. Then let's just be this final line. Could we come step back a little bit? Behind, yes. MD, ma, just a little behind. Just a little. Mr. Karim, a little. That's it. So now, we'll now form this. I'll let you know how we're doing this content. Okay. Some people can squat here, because this curve may not work. From here may not work. Sir? Sir? Future governor. I'm the future governor. I said the top people should be here. The short people should be. You are talking to me, Abi. I don't understand. You say short, you are pointing at me. I don't get. Just tell me what you want to tell me. Okay, so the people that are not too tall, you don't say short, they'll get angry. Hey, we know what I said. You are the ones that will be in front, Abi. Yes, then the top. Okay. If you're tall, please come. You're tall, please come. Okay, some can just come and squat in front. Yeah. No, Mr. Karim, don't. You see, Oyibo just want squat, but Nigerians, can we just squat a little bit in front? Because I'm not seeing from here. The camera cannot see from here. Surveyor, sir. You may not. Let's make this picture interesting. Okay. I want to be sure that we're all ready. Yeah. So we're saying a Esri Users Conference 2025. We're doing that together. No, let's do 2025 so we can follow together. So do we get it? Let's do a test run. 1, 2, go. Okay. Who? Who added the who? That was a good one. Oh, you did? I want to say that's the only thing you have done in this conference. Because I've not seen you since. Okay, let's do it again. Now, we're going to add a bit of energy, a bit of vibe, so it will be interesting. Are we ready? 1, 2, go! So we're going to... Wait. So we're going to do it again, and after that, we're going to just go do the woo together. So you see, the thing is useful. I told you I will help you. I've added it. So we're doing it. Who is this? Okay, it's taking audio. You drop a bomb in front of MD, my balance. I wanted to fight for you. So after the 2025, we'll just do the ooh with our right hand up. Don't punch anybody, just up, not sideways. Okay, we're doing it together. Now, so much energy, so much vibe. Ladies and gentlemen, 1, 2, go! No, let's do one again. Sambus. Let's do Sambus. Now, I know why. I should not do it. It's not as if I really like them, just my balance, you understand? Okay, so we're gonna do that together now. So we're gonna do Sambus Geospatial Limited. It will be too long. My money long too. Don't do that. So let's do it together. Sambus Geospatial Limited. Let's do it. Yes. Now we're doing it only once. So let's cooperate with all the, and after the limited, we now also do the ooh. So I added the ooh again. Okay, are we ready for Sambus Geospatial Limited? Everybody, 1, 2, go, come on! Madam, I've tried. Now, only Sambus staff. Only Sambus staff. It's now time for networking, meet and greets. Thank you all very much. It's been a wonderful event. My name is Chooks, the General. I've been your host for this 2 days conference, and I'm sure it was very amazing. Thanks to Pan Events. Thanks to Edge Multimedia. Thank you all. Thank you all. Emek, can we play the video, please? AI video. Please, somebody doing, yeah, forgot his bag. Please, NLT, please check for your bag. All Sambus staff, members of staff, Sambus, please. Sambus staff, if you don't come for this picture, Sambus staff will assume that you have resigned. Who? Kola, Ado, Andoin, Isaac, Jibril. Okay. Benjamin. Can the hostess help us go to the exhibition ground and call all Sambus staff? Hostesses, please help us. Oh, the hostesses have closed. Oh, wow. I'm seeing hostesses now. Help us call, Nathan, help us call Sambus staff outside. Tell them MD is calling them. Earpiece. Okay, so the video I'm supposed to play, we didn't play before, it's playing on screen now. So you can all just watch it as it's playing. Earpod Black, lost but found, is with Pan Events. Mayowa. Who else again? Abdul Latif. Adedoyin, MD is waiting for you unless you have another job. Open this one, let me see. How much are you paying? No, just a joke. Okay, after this, we're taking one more picture that is very important. So let's rush this one quickly. We have a very important picture to take after this one. So, do you work in Sambus? Okay, yeah. Okay, who else is remaining? Okay. Yes, the video is playing. Okay, you know what we'll do? Media, put Esri first, then we go back to video. We need to take a picture with the background. Then you start the video from beginning, everyone will watch it. But go back to our background. Media. I like this media. Thank you. National ID card, Adam Kamaluddin. Your ID card is with Pan Events. Adam Kamaluddin, please. Okay, one more picture. Yeah, the rest of you can go. MC and MD. I'm gonna go now. Yes, since. Okay, Afit is hurting her. Pan events, let's take. They've taken the picture. Okay, photographer, one more for them. This. Nine posts. Okay, thank you. With MD now. Chooks the general and MD. Pan events. Okay. Now to the video. Can we have the video now? Let's have the video.
The video is playing. You can watch the video now.